It's working. And now it's working. I'll add another tick to my unconventional prison cell countdown. Or another tally. Or is a tally when it's 5 ticks? As a tick tells a tally. Like, does like the cross one make it a tally? I don't know. Add another tick, whatever you call it. I'll make this one like a log or something. Now get back to like making normal ticks. Because making them not just ticks makes it too complicated. Kind of like writing in 64-bit assembly. It's kind of complicated. Would a log like have like a circle ring on it or something? I don't know, it doesn't really look like a log. What? That's close enough. So I'm making JavaScript Engine. At some point, sooner than later, I'm gonna go through the JavaScript standards, whatever. I'm gonna go through the 2009 standard, then the 2024 standard. At some point, I'm gonna have to go to like assembly level because I'm writing my engine in C, and I need to be able to like compile C code at runtime in a C program to avoid virtualization. So I need to like make binaries, objects, whatever you want to call them. But more efficiently than calling like a DLL. I need to figure out how to like make a binary blob and have like fixed locations of things in memory at fixed offsets from the base of the program. And I'm trying to figure that all out for 64-bit assembly, and it's like really frustrating to wrap my head around it because it's just ridiculous. The fastest code is no code because code takes time to execute. It's faster to save the sign bit of a number than it is to extract the sign bit of a number. You can make an array or a data structure that's 9 bytes, save an 8-bit number, and use a byte, use 1 bit to represent the sign bit. And then every time you load that number, you can like apply that sign bit to the rest of the number when it's used. And then you can grab the sign bit from that byte or whatever Otherwise, you have to take the 8-bit value and shift it right 63 bits. I don't know. When you get to like working with bigger numbers, everything takes more time. Even though the whole thing, 64-bit processor, whatever, is set up to leverage that, it's basically like memory bound now. There's always like annoying little like
in x86-64 will mov x rbx 0 out the top 32 bits. Yes, in x86-64 assembly, the instruction mov x rbx will 0 out the top 32 bits of the RAX register.
So I thought maybe it was just C language, because in C language there's a whole bunch of like odd things. You always have to cast it to the bigger type, even sometimes when it is an 8-byte value. There's a bunch of odd little things where the top of the number disappears because it's not really 64-bit. In AMD, it seems. Okay, so like, here's what it says about 16-bit instructions. This is why I'm using 16-bit instructions right now, because it doesn't do funky shit. So here I'm asking it, what about a 16-bit move? Will it zero out the bits above? And it says this.
What about in x86-64 will mov ax rbx 0 out bits? In x86-64 assembly, the instruction mov ax rbx does not 0 out the upper bits of RAX. AX is the lower 16 bits of the RAX register. When you do mov AX, RBX, it reads 2 bytes, 16 bits, from the memory address pointed to by RBX, writes those 2 bytes into the lower 16 bits of RAX, leaves the upper 48 bits of RAX unchanged, including bits 16-63.
Okay, so that means I had to open up Sublime. And yesterday, I wasted too much time trying to fiddle around with freaking coming up with a creative solution to fucking get data into like the upper bits of the register where it's like above 32, between 32 and 64 bits. I just want like a clever way that I could implement systematically when working with 64 numbers to like operate between the 32-bit values and the 64-bit. I tried like, I wanted to like rotate the bits by small amounts to get them into the top of the register, but then I gotta like rotate every single time to keep loading in new ones. And if I don't load up the full register, then I have to like rotate again to get everything to the bottom of the register. And the rotate is one of the like slowest instructions. And I don't want to rotate bits in one by one, because that's going to take 63 rotate carry instructions or 64 to move that many bits. That's like if you're like processing like a data packet and you gotta like invert bits, then you're like, I'll bite the bullet and it's gonna be slower, but I'll just do this. But in that case, it's faster to use a lookup table, which is why they kind of like abandoned. By they, I mean the people that designed the CPU, whatever. They abandoned the whole rotate register stuff. They're like, just use a lookup table. So I wasted too much time yesterday trying to come up with a clever solution, because if this is a register, whatever, like they're called general purpose registers in x86. Okay, so I'll like have chatbot read this really quick, whatever. There's no way I could like organize my thoughts into like organized. So I'm gonna go back and forth. And I have to go back and forth to like, if someone else is watching and then they watch it, or I explain something, they missed it, so I kind of have to like go back and forth and repeat. I don't know, it's kind of on purpose. So moving 16 bits to 64-bit value, it's fine or whatever, it just moves it. Nothing gets modified above 16 bits. So like, here's what chatbot says.
When you do MOV-AX, RBX, it reads 2 bytes, 16 bits, from the memory address pointed to by RBX, writes those 2 bytes into the lower 16 bits of racks, leaves the upper 48 bits of racks unchanged, including bits 16-63.
So it simply does what it does. The register holds bits, holds data. The definition of a register, it's not what it used to be. Now it's a bunch of tricks. There is no technical register. There is a shadow register. There's probably a bunch of them. I'll get into that in a second. I don't know, the CPU is a joke. It's not hardware anymore, it's software. But what it does is when you move data in 16 bits, it moves the 16 bits, everything else remains as it is. It doesn't break anything. Because it says,
writes those 2 bytes into the lower 16 bits of racks. It leaves the upper 48 bits of racks unchanged, including bits 16-63.
so it just does what it does. It moves the data, 16 bits are reloaded, and everything else is fine. But with 64-bit, if you use a 32-bit instruction,
will zero out the top 32 bits of the rack's register. Explanation. In x86-64, 64-bit mode, when you write to a 32-bit register like EX, the upper 32 bits of the corresponding 64-bit register, racks in this case, are automatically zeroed. This is a behavior specific to the 64-bit mode of the x86 architecture.
so I think AMD did this intentionally. I think they extended how the 32-bit instruction set architecture was set up. And then instead of making a hybrid to support 32-bit, they toggle between 64-bit or 32-bit mode. So when you do a 32-bit instruction, it goes to like a different bank of memory where the 32-bit stuff is at, and just dumps the history that was tied to when it was at the bigger register. And they do this on purpose because compatibility is a pain. And I think that AMD wants to phase out 32-bit instructions, which makes sense because they want to go to 64-bit. And everybody holds on to the past. That's why the 16-bit instructions still exist and stuff. But since 32-bit came out, 32-bit works for 16-bit. So since they took the 32-bit instruction set and they extended on it, they still support 16-bit. They just don't support 64-bit and 32-bit working together. So if I have like a register that has 64 bits in it of data, that's 64 bits. What I was saying earlier is that if you keep an extra byte here, whatever, let's say like this is extra byte. Now, technically speaking, the only way this would be efficient for the sake of alignment, even though alignment doesn't matter in the new CPUs, because everything is, I don't know. They like smooth out the timing by slowing the excess of other things down, and there's so many extra layers in indirection that unaligned data doesn't make a huge difference because there's so much that goes to anyways that the time it takes for unaligned data is like absorbed by the overall time. Kind of like how like an engine, it loses performance to heat, or no, like, I don't know, you get what I'm saying. So like the only way this would really work, if you want to be efficient or whatever, is you take this byte and you group things by 8. And then you'd save like 8 numbers here, whatever. And then down here be like a byte for each of them. And then you could access the byte for each of them down here. And then the actual value, the 64 value here, instead of setting up like this. Because if you set up like this, everything's aligned by 9 bytes, and that's not as easy. It takes a couple more instructions to access whatever. So like this would be the cleaner way to do it. So like everything, the byte to describe 64-bit, if it's packed and aligned like this, rather than saving like a single byte and making everything 9 bytes. So basically though, I don't know, earlier, if you pick like this bit to represent the sign of the number, like positive or negative. If you're doing signed 2's complement, instead of picking the top bit here, because to get the top bit here, you're going to have to do a shift of the whole value to get it to the bottom of the register. So that's 63. You gotta shift it by, which is ridiculous. And if you save a byte with the bit, then you can take this bit and you can like assign extend a register. You can XOR. There's a ton of different ways to like apply it to this part of the value when it's being accessed, and we have to like flip the sign. You can set a single bit in one place instead of whatever. So there's like tricks to work with like bigger values and stuff that save time, because the fastest code is no code, because every code takes time to execute. So there's ways you can like minimize that time by doing less instructions. And then a shift whatever is generally faster than a rotate, because what you could also do if you have this number, you want to get the sign bit, you can rotate it one bit to the left. So take this top bit, it gets removed, and it goes to the left. And then you can mask with the number 1. So like this is like a byte. So now what you can do is you can mask with 1 to test this bottom bit, to test if it's signed or not signed. And that's like the same concept or whatever as here, but this is one instruction and one load and one mask. This one, you're gonna have to rotate the value. You're gonna have to test for it. You can do a branchless test, it doesn't matter. Same thing, whatever. But when you're done, you're gonna have to rotate whatever this bit was to the right, restore the value, because you just changed it. So you gotta put it back. So like these rotate instructions are like 2 cycles. So it's like 2, 4 cycles, whatever. And then a shift is generally 1 cycle. Or if not 1 cycle, at least half of a rotate. A shift is 1 cycle if it's 1 bit, typically, but if it's like 16, 18, 32 bits, then the count goes up higher. And it's the same with the rotate. The count goes up higher, but it's like twice as expensive as a shift. So here's the problem, or the annoying part of 64-bit that I shouldn't waste time on anymore, because I can't come up with a trick to make it work any better. So right now, whatever, if you don't know about computers, whatever, you're probably thinking, well, why don't you just access the top 64 bits? Why do you have to get it to the bottom of the 64 bits? That's because of how the computer is typically designed. And that's why when AMD made AMD 64 whatever, they like, I don't know. It's kind of funky. It has a smell to it, the way they set it up. So like, and like ARM 64, it's a whole different processor. it's still stolen. I'll talk about ARM when I do ARM later. ARM's like in a cell phone or whatever, typically, or like on the new Mac computers. And it's more powerful than x86 because ARM basically has x86 in it with an ARM CPU. It is actually kind of clever. So it's like literally twice as powerful as like, I don't know. It is actually kind of superior. So the thing about like the ridiculousness of having to like shift, you can also use a branch or a test instruction to test for the sign of the value. But then that's a branch, I don't know, whatever. Basically, you can't just get the top byte based on how the register is set up to work with the instruction set. So like a 64-bit value, I'll call like R for like, because it's like RAX. Okay, so the registers, let's say there's 4 of them, because there is 4 general purpose, kind of. Technically, I'm pretty sure the whole CPU runs off an A register, a B, C, D, and they're all nibble sized because they're CPUs before the 80 whatever, and they just kept extending to it, and it really seems like everything relies on a 4-bit CPU internally, but then they like add a bunch of stuff to it. Like now, lots of it's software driven, even though it's called a CPU. There's a bunch of like software on it. So there is an A register, but I'm gonna stay to like 16-bit. So like on 16-bit, you got A high and AL. A high is the high 8 bits of register. So like this is H, whatever for high. This is 8. 1, 2, 3, 4, 5, 6, 7, 8. AL is the low 8 bits of the 16-bit, because A high AL is 16-bit mode. So use L. So now when you put that together, this is a 16-bit value, and that's known as AX. So this is the 16-bit CPU for the register A. So when accessing the full register, it's AX for 16-bit mode. And you can get the high part and the high part whatever with A high and the low part with AL. So back in 16-bit computing, this is a 64-bit number here. This is a 16-bit number. So it's like put zeros and ones, whatever. So if I copy 16 bits, from this 64-bit number. And paste them underneath. Bits that are 0 go to low. It doesn't matter if they're 0. It's just 0 for like to represent whatever. So now they're just random bits. It doesn't matter. I don't know. It's hard to explain anyways if you don't know. So in 64-bit days, you'd think, can you just get the high part of the register to get the top bit? And it's like, you can't do that because it's how it's designed for a 64-bit. But for a 16-bit, when it's a 16-bit register, which is AX, register, whatever, you can access it as A high or AL. So a 16-bit number, the sign bit, is typically the last bit. And the last bit depends on little endian, big endian, but that doesn't matter because the last bit, either way it's represented, there's a bit that's last, basically. So in 16-bit code, it's a 16-bit number. To get the sign bit, you can just do A high, that register, because it's the top 8 bits. 8 bits of the byte, the 2 bytes. So like the sign bit's like set 1 or 0, whatever. You literally just type in A high, whatever. That gets you the register, a byte of the top. And then this, you can easily test for this bit. It's a byte. Like you can use a really small operation to test it. And then we get to 32-bit mode. That's EAX. So I use E to like represent the upper 16 bits after the 16 bits of 16-bit mode. But the 16-bit mode was based off the mode before it, and that was just A, because it was a A register. So the whole thing is based off the original instruction set, and it just keeps getting like lazier and lazier, except the bit count gets bigger and bigger, because that's all that matters apparently. Because a 16-bit register, that could be a real physical register that's easily manufactured, and it can access real memory, fast memory. It's all real. Once you step into 32-bit land, things become fake. There's a lot of software going on behind the scenes. There's extra decoder chips that do extra things to make it seem like it's 32-bit when it's not. But when you get to like 64-bit, the whole thing seems just totally fake. They really took 32-bit mode and then they blew it up to this magical wonderland. It is kind of impressive how they were able to like take 32-bit and expand it to 64-bit. But to do that, to expand the 64-bit mode to 128-bit, that would take a whole lot more work. Because right now, the whole thing relies on 32-bit. So if you add another system on top of the system, I don't think it would work. Someone would find a way though. So 32-bit mode. This is 16 bits, so 32 bits. Is going to be that many bits because it's 16 and 16. So I'll label the top ones E or E, I guess. Or like extended because it's extended AX mode. And I think the R stands for relative for REX. If you want to put a meaning to it, no one will put a meaning to it, but there's always some kind of meaning, even if it's not said or to say, it really doesn't mean anything. It's just a letter. Or, oh, it stands for register, which it might actually stand for because they kind of copied ARM and how they call it like register 0, register 1. So they just kind of like slapped an R on there and they go R, AX, BX, CX, DX, and they go like register 9, 10, 11, 12, 13, 15, instead of coming up with like letter names. So this is a 32-bit number. If you want to get the sign bit of a 32-bit number, there is no high register. You can't access this top 32 bits like you could back in the days of 16-bit. You can't split the number in half and get the top bit. So what you have to do now is kind of like 64-bit mode. You have to come up with a clever way to get the value at the top that's outside of this reasonable range of values, whatever. You would have thought that they would have like kind of like with A high AL. It would have made sense if they made like an EA high or EAL, and then maybe that would give you like the top 16 bits, and maybe EAL would get you the lower 16 bits. And that would have been useful when you're programming assembly, and it would have been cool because then you could do EA high, right? And then it's like the same thing as A high. So like, I don't know. This would have been cool. But no. Instead they just extended above the low 16 bits. So you can access the 16 low bits as high and low still. But when you access it as 32-bit, you can't get the top 16 separate. It just kind of like stays above the lower 16 bits. So they didn't do this, whatever. So instead, they have an instruction called exchange, I think, or something. So you could like swap around the bits. So like you could like call exchange and it would flip what's in the bottom 16 and the upper 16. So now what you could do is access the high and low part after it flips them around. But that instruction is extremely slow. So like you don't want to use it. Or you could, but it's gonna be really slow code. Okay, so this is 32-bit mode. So now 64-bit mode. So 64-bit mode is our AX. It's kind of like the same exact thing as 32-bit mode, but it's 64-bit, which is why I think they called it 32_64, because it's not any different than 32-bit mode. It's the same exact thing, except they just distorted it to work with 64-bit bigger values than 32-bit values, because it's RAX and EAX, and only the prefix changed because they changed the byte that they're looking for, or the bits in the instruction set to identify the instructions to do. Because with 32-bit, it's chatbot. Chatbot's typically generally correct most of the time, some of the time. Okay, so basically, chatbot's lying. There's no point in explaining every little thing. The newer CPUs, though, they're totally fake. Okay, whatever. There's a whole bunch of software that goes on behind the scenes. And they basically took what was used for 32-bit mode and they extended it, expanded on it, and didn't make a whole new mode. So since they did that, and they like don't want to support 32-bit, this is 32 bits. So like to make it 64 bits, then I'll like call it R for the upper 32 bits. So that's 32 R's. I'm getting my point now. Okay, so in 64-bit mode, it's the same exact thing as 32-bit mode. You have the upper 64 bits, they can't be accessed just like 32-bit mode. Except now, there's no access to the upper 32 bits of the lower 32 bits. So now when you want to access bytes of the full value, you can only access them down here at the bottom of the original mode of the CPU. And behind the scenes, whatever, there's a register page tables, whatever, where they're literally page memory for the registers now in the newer CPUs. And the whole thing, it's literally memory bound. It's all software. It's not even a CPU. It's like the old days of like a CPU, they're all gone. It's really disappointing. And I don't know, pretty much just sucks. Because you can't just get the top part of the value without a whole bunch of work. Because on top of it, this is the 32-bit, 64-bit. So now, yesterday, whatever I was originally getting at, I was trying to come up with a clever way to set a value to the upper part. Of the 64-bit register. Except I can't do that without a whole bunch of rotates and shifts and like inefficient operations to get to this top part of the register. Because like the lower part, 32 bits, you can access it in like, especially 16 bits, it's easy. It's like all there. 32 bits is a little bit annoying because you can't get this top part separately. But now, in 64 bits, they zero out the top of the register. So like, let's say you have like a 64-bit value right here, right? So this is a 64 value. If I want to load 32 bits into this value, if I just do like a load from memory to this register, it's a 32-bit load, the result will always end up being when I do load whatever, it's a 32-bit load. It destroys the top half of the register because there's a clear distinction between when it's a 64-bit number or a 32-bit number. Because behind the scenes or something, they probably have two like table maps, or whatever you want to call it, a register map, or register bank, whatever the fuck they call it. They probably have a table for 64-bit, separate table for 32-bit, and when you're like accessing a 64-bit register and you do a move that's 32-bit, the cheapest, most efficient way to make it work without having to support or make a table that works between the two modes or whatever was to like just switch to the older CPU mode and then dump everything above it. That's what I think is going on. If it's not, it doesn't matter. All that matters is that you physically can't do a move that's 32-bit without destroying what's above it. Now here's the annoying part. Let's say you want to do a move, you want to move 32 bits. What you're going to have to do there's 16 registers, whatever, in 64-bit mode. You're going to have to use, like, let's say, like, I'm using RAX. Let's say RAX holds this value, 64-bit value. I'm going to have to use RBX if I want to load the 32-bit value. So I'd like do my load in RBX so like it'll hold the result. So now I did my move, whatever. RBX holds the result. The top 32 bits were zeroed out, but it doesn't matter because I knew it would be. I'm like, oh, I'm gonna use a separate register for the move. But now I have a 64-bit value and a 32-bit value. How the fuck do I simply get these 32 bits into 64-bit? I didn't check this yet, so let's chatbot. I'm thinking you could do like move R or EAX EPX, but I don't know if that'll work. I'm really hoping they won't zero out the top 60, the top 32 bits. I didn't even try that yet. Yesterday I was just trying like loads and like, but a couple instructions, I don't know. Yesterday I tried to work around this fact that like all the bits above 16 bits are really painful to work with in 64-bit mode because 32-bit loads do this funky zero at the top of the register. Why they do it technically? Are they bank switching between the old mode, the new mode? I don't know. I can't get a clear answer on it. That's what I would assume. But even if it's not correct, it doesn't matter. It doesn't matter if it's correct. That's just what I think is happening. Whatever's happening though, the reason why doesn't matter. The result does, and the result is that whatever's going on, they're zeroing out stuff in the top. They never used to do that for these old modes, and it's really frustrating. So I'm gonna ask chatbot what this move will do, if it will zero out the top of EAX. Like that, because if it does, that's annoying. If it doesn't, then I'll probably just have to do that then. I'll have to waste a 64-bit register to do 32-bit moves and then set it to the other register, which is why I think that they're possibly being switching between two modes, because they want you to work with 32-bit mode or 64-bit mode as two different modes, but kind of make it seem like it's your choice or your decision. But really, it's because like technically they didn't want to like support the between mode between 32-bit and 64-bit. So they did it like this to save time and money, which does make sense. So I don't know. Ask chatbot what this does. And then I'll stop complaining and explaining stuff. But I kind of gave up trying to come up with a clever way to like manage these bits. I'm just gonna have to give in and like ways to register to set values to another register so I don't lose values in a register.
With this, zero out the upper bits of racks. MOVX, EBX.
Oh my god. This is ridiculous. Fuck. How the fuck 64-bit assembly is stupid as fuck. That means I have to do like what? A 64-bit load operation every time and then just like dump the bits I don't need if I need 32 bits. So that means since I can't. Alright, here's what chatbot says.
Yes, in x86-64, the instruction MOVX, EBX does zero out the upper 32 bits of racks. Tick Y in 64-bit mode, writing to any 32-bit register, like X, EBX, etc. Automatically zero extends the value into the corresponding 64-bit register. So, moves the 32-bit value from EBX to X, zeros the upper 32 bits of racks.
When it says 0 extends, I hate that. I wish it would say it's bank switching, or it's a technical limitation where you lose the top bits because they didn't want to support 32-bit and 64-bit, so they pick between one mode or the other. But instead they call it 0 extending. That's ridiculous. I'm gonna ask it what 0 extending means, whatever.
By zero extends, are you explaining the technical limitation when it comes to support? What is the reason that the CPU changes to 32-bit mode and dumps the upper 32 bits? Is it switching register banks internally silently to the user? And masked as calling it zero extending. Great question. You're digging into the underlying design decisions of the x86-64 architecture. And it's a subtle but important distinction between architectural design and implementation mechanics. Shadow registers.
Like I said earlier, I don't know, shadow registers. None of this is real anymore. I can't waste time, like, picking apart the CPU. Well, I could waste time, but there's no point. So, like, here's what chatbot says. It's full of shit. So, like, this part, it says you've written to 32 bits. I'll treat it like a 32 register. There's a technicality. They don't just decide to zero out the top bits. Technically, there's something going on in the mechanics to internally do this behavior. Because they wouldn't do this intentionally unless it was with intention, meaning that something mechanically is happening on purpose. That has to do with like a limitation of the architecture design.
Microscope. Implementation. Are register banks involved? While microarchitectures may organize physical registers in complex ways, for example, register renaming, out-of-order execution, or shadow registers, these are transparent to the programmer. The concept of zero extending is architectural behavior, not necessarily a literal hardware action like clearing bits with an AND. Modern CPUs just ensure the architectural effect is achieved. It may or may not involve actual zeroing depending on the microarchitecture.
Right here.
It may or may not involve actual zeroing depending on the microarchitecture.
There is no actual zeroing of the bits. It's because you're accessing a different part of the register because they switch banks or something, or it's a different shadow register that's 32-bit. It's because there are no bits above it. So when you access it as a 64-bit, again, a bit gets set internally, and they're like, there's no bits here, send zeros. That's what's happening. Okay, so anyways, since this means that I will lose the value in EAX, I guess you could do an XOR swap the slowest way. So what you could do, because it's guaranteed that these top bits are 0, is you could XOR swap. So instead of move EAX, EBX, you could do this. Oh, I can't even do EAX because that's in a zeroed up. I think it would zero it out. I don't know. This is just frustrating and annoying. You can't just work with 32-bit values without all this extra overhead. So like RAX, whatever, you do like and I think that's 64. You could and you could do this. You can mask off, or you could keep whatever with an and. The top bits, set the rest to 0, and then or the value that was loaded to set it. This is ridiculous. You can't just do a move. You're gonna have to like physically mask it, or you could do this, but it's to be dreadfully slower. You could do shift right RAX 32, and that's gonna set the bottom bits off because you're shifting it right. It should set to this, and then you can shift it left 32 bits to undo what you just did to get rid of the bits on the bottom. And then now the bottom bits are off, which means you're safe to OR. So now you can OR to RAX what was in RBX. Or you could also do this. You could do XOR RAX RBX, RBX RAX, RAX RAX, whatever. I need some water. You could XOR 3 times to do an XOR swap, and then that would swap the bottom bits to both, whatever, they're both the same. That would swap the bottom bits of value. Unless the value was the same, then you would lose the bottom bits, which means you couldn't really do this realistically unless you know that they're different values. So these are probably the only 2 solutions. You can't just move a value. This is ridiculous, like for fuck's sake. It's just really fucking annoying. So I need to just accept that 64-bit assembly fucking sucks. I'm gonna have to write some shit-ass code. Like, what even is this? This is ridiculous. I would have to and then or, because I can't just move into memory. So now it's like, instead of this, it's like I can't just simply do this anymore. If I want to set only the 32 bits at the bottom, I can't do move EX memory location. Because if I do this, whatever, if this is my original value, and I do the move, I'm going to lose all these bits at the top. Because you can't move a 32-bit to a 64-bit, they 0 extend it. So that means if I ever need a 32-bit value, which is going to be a lot, the only way to do it, since I can't just simply move the value. And yesterday, whatever, I wasted time trying to like cleverly rotate, shift. There's no way to like simply come up with a systematic way to rotate and modify the register without a whole bunch of operations. So I'm not going to waste any more time trying to like figure out a way to do this. What I'm going to have to do is accept that I need to just use a different register, and I'll have to use the 32-bit because there's a overhead. If I do RBX, I would have to, I don't know, so I use like 32-bit registers when it's 32-bit. I have to accept that the top of the value is going to be lost because this is 64-bit RAX and EAX, 32-bit or whatever, but when it's a B register, it would be there. So now, instead of like simple assembly code, where it's like one register, one move, now I have assembly code where I have to use two registers to move a single value, and I have to like set to like EBX. I have to make a shadow register, basically. So I have to pick a register that I'm going to like use for holding intermediate values, because the way they wrote x86-64 is they hid what's actually going on, and they're like, just deal with it. So now I have to deal with it. So EBX is going to be my shadow register. I'm going to have to waste this register to hold partial values to set to the full value, because when they set up 64-bit, they ran out of memory in space. So they're like, that's on the assembly programmer to deal with. There's no reason why they couldn't have updated it to 64-bit and support 32-bit at the same time. This is just dumb. Anyways, I'm gonna have to use EBX, load it up with 32-bit value. So I'm wasting a register. They added 8 more registers. I don't know, it goes up to 16. But there's no point in adding them if I'm going to have to use half of them just to hold partial values, which is probably why they added them. Because they're like, there's already not enough registers. We did 64-bit. People are going to need to use registers to hold partial values. That's probably why they did it. Well, that makes a lot of sense. That way, you can run your program as a 32-bit program. You don't have to worry about the 32-bit registers. And you use the 64-bit registers only for 64-bit. Alright, I kind of have a systematic technique, possibly. So like earlier, I've been using like these as extra registers. I need to use these as, but there's only 1, 2, 3, 4, 5, 6, 7 of them. That was 8. So I'm going to have to use these 8 registers as 64-bit, and I'll use these as primarily 32-bit. And I'll use these to get the values into these. But then these are faster than these for certain operations because they're internally, they decode different. This sucks. So, I don't know. Basically though, I can't do something simple like this without losing half the value. So I'm going to have to use two registers, use EBX or RBX, EBX same thing, as a shadow register. So I load up from memory to my shadow register. And then I'm going to have to do and RAX 0xf 000 whatever. And I'm going to have to OR it. So I'm going to have to OR RAX to RBX. This could be slightly out of order. No, can't. Yes, it can, kind of. I don't know. This is not efficient. This sucks. I gotta think of. There has to be a better way. This is stupid as fuck. This is ridiculous. I can't just do move without losing the top 32 bits. So I'm gonna have to use a fucking extra register. And I have to and to intentionally zero out the bottom bits. And then I have to do move to a separate register. And I have to OR to set the bottom bits to the bottom of the register that is zeroed out at the bottom. Because it won't just fucking do a simple move without zeroing out the top bits. This is ridiculous. I don't know. 64-bit sucks. I'm gonna take a break or whatever. I asked chatbot if there's a better way than this technique, whatever. Because this is really ridiculous. This would be the better solution because this is going to waste a lot of space in the pipeline. This is like much smaller encoding to do a shift, but then that's going to be a lot slower because it's a shift operation. The mask is a lot quicker, but maybe they have like, they can short circuit this operation if they're close enough together. I don't know. 64-bit. It's cool, but it's not. It's just so fake. Like 32-bit was fake, but 64-bit is like super fake. Okay, so basically, I'm done playing games now. I'm gonna accept the fact that I'm gonna have to like deal with this really like with 32-bit and 64-bit stuff. I'm gonna have to come up with just plain solutions, basic ways to like deal with it because I can't just shift, rotate, mask. I don't know. I'll be.
Numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part, the MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part, the MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part, the MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part, the MV of decimal integer literal. 0 is 0, the MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal digits. Decimal digits decimal digit is the MV of decimal digits 10 plus the MV of decimal digit, the MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit, the MV of exponent part. Exponent indicator signed integer is the MV of signed integer, the MV of signed integer. Decimal digits is the negative of the MV of decimal digits, the MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 28. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or of binary digit. 0 is 0, the MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the MV of decimal digit. 2 or of non-zero digit, the MV of decimal digit. 3 or of non-zero digit, the MV of decimal digit. 4 or of non-zero digit, the MV of decimal digit. 5 or of non-zero digit, the MV of decimal digit. 6 or of non-zero digit, the MV of decimal digit. 7 or of non-zero digit, the MV of decimal digit. 8 or of non-zero digit, the MV of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of binary digits. Binary digits binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separated binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal. Capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit is the envy of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the envy of non-octal digit. The envy of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the envy of non-octal decimal integer literal times 10 plus the envy of decimal digit. The envy of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit is the envy of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the envy of octal digit. The envy of hex digits. Hex digit is the envy of hex digits 16 plus the envy of hex digit. The envy of hex digits. Hex digits numeric literal separator hex digit is the envy of hex digits 16 plus the envy of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions. Numeric literal, decimal literal, return round envy result, envy of decimal literal. Numeric literal, non-decimal integer literal, return, envy of non-decimal integer literal. Numeric literal, legacy octal integer literal, return, envy of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix, return the big int value for the envy of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit big int literal suffix 1. Return the big int value for the envy of non-zero digit. Decimal big integer literal, non-zero digit decimal digits big int literal suffix, non-zero digit numeric literal separator, decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let nv be the envy of non-zero digit 10n plus the envy of decimal digits. Return z, envy 2, 9. 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMAScript string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as two code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence. 30. ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, x hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 129.3. Source character is defined in 11.1. ECMA International 2024 231. Note 2, LF and CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2, 9, 4, 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text match by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2, 9, 4, to static semantics, SV. The syntax directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 129.3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit 0 times 2028 line separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029 paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028 line separator. The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029 paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000 null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, The following source text contains a syntax error. Function invalid. 7. Use strict. 32. Copyright sign. ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B 0 times 0008. Backspace BS T 0 times 0009. Character tabulation. HT N 0 times 000 line feed. LF V 0 times 000B. Line tabulity on VT F 0 times 000C. Form feed. FF R 0 times 000D. Carriage return CR double quote 0 times 0022 quotation mark apostrophe 0 times 0027 apostrophe backslash 0 times 005C reverse solidus comma the SV of non-escape character. Source character but not one of escape character or line terminator as the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence. Legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence. 8 is the string value consisting of the code unit 0 times 0038, digit 8. The SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039, digit 9. The SV of hex escape sequence. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence. U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4, 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3.
So, I don't know. I just have to accept that I'm gonna have to do a whole bunch of stupid shit to just get values into a fucking 64-bit register from 32-bit. This is ridiculous. Alice chatbot, really quick, the best way to handle this or whatever.
Hex digit.
It's just stupid as fuck. That it, the whole point of 64-bit, it's you can't even use the 64-bit register as a register. A register is supposed to be a malleable chunk of bits packed together to work with as pure data with operations. But 64-bit, you get that, but you get the overhead of having to do these funky operations because they broke compatibility with 32-bit, but then they maintained the original compatibility with 16-bit because they literally just updated 32-bit whatever's going on behind the scenes and extended it to 64-bit. So they didn't really make or change anything. They just took whatever was done for 32-bit and now it's 64-bit with 16-bit. And it's like 32-bit doesn't exist. It toggles between 32-bit and 16-bit, or 64-bit and 32-bit. It's ridiculous that they did that. There should be a between mode between 32 and 64-bit. But instead, 16-bit is the only real mode of the fucking processor. And it's not even a real. Because really, I'm pretty sure that this is register B and this is register A behind the scenes, but they call it A high and AL. The whole thing is fake as fuck and is lazy. So I gotta be lazy and do this kind of shit just to set a 32-bit value to a 64-bit value. So I'm gonna ask Chatbot the most efficient way to load a 32-bit value from memory to a 64-bit register to see if it shows me this or something else. Then after this, I already wasted time yesterday trying to rotate or shift a bunch of different things. In the shifts, I guess I don't know. Certain instructions seem to like zero at the top. And I was like, what the fuck is going on? Because in C language, there's zeroing out and stuff, but you can kind of hide it because you can cast it. I don't know. It's the same issue. But like now in assembly, it's like real obvious that like you lose the top of the register. It's really frustrating because it's like I just want to get the data to take advantage of 64 bits while still using smaller numbers. Because like this is ridiculous. Having to type up a 64-bit number takes twice the amount of work.
Flag text
I physically have to type twice as much.
piecewise over the following productions. Regular expression
This is 64-bit.
body regular expression flags. Return the source text that was recognized as regular expression flags. One
So I want to mask a 64-bit value.
technical components. Syntax. Template.
I had to do this much work.
Template head no substitution template character stop template head
And I gotta like find which parts I want to mask.
tail template middle
With 32-bit, it's this.
stop $, template tail template character stop template characters template character stopped. Note
I gotta like mask whatever part, doesn't matter.
expression literal
Do you see how much bigger this number is? This is a lot more work. So I gotta work with bigger numbers, bigger everything, and then I gotta waste registers to hold partial values. I gotta mask the register, then set to it a partial value. And this is gonna mess up a whole lot of optimizations. Because now the CPU, like, it's gonna and the register, but then it's a move here, but instead I have to wait to do this or here for this to complete. When if I didn't have to do this, I could just do move. The fastest code is no code. This code, it's gonna take longer to execute. Except things in 64-bit, the whole thing is so virtualized that everything is like the same slowness. So in reality, this is just about as slow as this would be in 64-bit mode. So I don't know. This all sucks. So I'm gonna ask Chatbot the best way to do this to simply load a 64-bit register with 32 bits from memory without losing the top 32 bits. Let's chat about that. I want to see if they say something like this, or maybe there's actually something better. Maybe there's an instruction for it. I don't think there is though, because it said like it's what it does, its behavior. So ask chatbot, and I'm gonna like just stop messing around with assembly and accept it, and like print values to the window so I can like time some stuff. And there's a bunch of other little things I want to test. Like this computer has 32 gigs of RAM. It's a first gen i7, 15 years old. But I want to set
Of template character, $sign is the string value consisting of the code unit 0 times 0024, $, the TV of
15 years old. 64-bit has been around for so long. And they still haven't fucking made a 64-bit, a true 64-bit processor. That's ridiculous. Where the heck is it?
6. To static semantics, TRV. The syntax directed operation TRV takes no
So the BSS section of memory is a bit segment. It's like 0 to whatever. I want to make an 8 gig span of memory that's zeroed out. I want to run it. I want to see if that's possible, or if they're going to limit me to 4 gigs. Because in 32-bit, you can't make more than 4 gigs. It'll say the disk image is too big when you try to like assemble it. So I want to try 8 or 5 or 6 to see if that's still the limit for 64-bit mode.
source character but not one of all.
I'm going to do that after I finish up whatever I was doing yesterday. I'm going to stop playing games with trying to come up with like tricks to load in the upper parts of the value. This sucks. So I'm going to ask chatbot. I'm going to undo these notes, make a backup of this stuff, get it printing. I'm just going to like bite the bullet, accept that this is how it works now. This sucks though. I lose a whole lot of optimizations and stuff. Makes everything more complicated. So I'm gonna ask chatbot, see what chatbot says. So like today, if I don't waste time trying to like find a impossible solution to a known problem, I got close, but it's not worth it. It's gonna end up being the same number of instructions as if I like just do this and accept it. So I'll ask chatbot, see what chatbot says. I don't know, I think I gotta take another break. I'll BRB.
0075, Latin small letter U, the TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the TRV of hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit. The TRV of not escape sequence, U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the code unit 0 times 007b, left
So I'm gonna ask chatbot this.
sequence, U, not code point, look ahead. In x86-64 ASM, will movx, rbx, 0 out the top 32 bits. How do I load to racks a 32-bit value from memory without losing the top 32 bits? Give me a working solution.
And chatbot says,
Yes, in x86-64, the movx, rbx will 0 out the top 32 bits of racks. Magnifying glass, Y, in 64-bit mode. Any instruction that writes to a 32-bit register, like EX, will automatically clear the upper 32 bits of the corresponding 64-bit register, racks.
and that's not even true. This.
Automatically clear the upper 32 bits.
It's like on a video card with mirrored RAM. If it's like a 4 gig video card, sometimes the memory is mirrored if they didn't put the chips on. So if it was like a 4 gig card and only have 2 gigs of memory, if you access above 2 gigs of memory, the memory manager, whatever they use on the GPU, it'll like mirror it. So you're actually accessing the same 2 gigs, but it's mirrored or whatever, because it's just like going to that part of the card. And this isn't for all of them. This is just like, just old or whatever. So like when it says automatically clear out upper 32 bits, I'm pretty sure there's no process of clearing out 32 bits. It's because when you access it as a 32-bit register, you're accessing a different part of the memory. So the mechanism internally or the software, it switches to a 32-bit location in memory. So like when you access it again as 64-bit, it's no longer a 64-bit. Now it's in a 32-bit location in memory. So when you get the value, it doesn't get those upper 32 bits again until you do an operation to set it back as being 64-bit. So there is no actual like clearing the upper bits. They just get destroyed because they don't exist anymore when you access it as the lower part, because it changes. It makes a copy with a shadow register or something to another bank in memory.
So after movx, rbx, the full racks becomes racks equals 0 extended ex. Red question mark. How to load a 32-bit value from memory into the lower 32 bits of racks without losing the upper 32 bits. You have two main options. Tick. Solution 1. Use movzx into a smaller register and 0 extend manually. If you want to preserve the upper bits and only overwrite the lower 32, do not use ex. Instead,
Oh my god, how do they make this many operations?
use a temp register and load the 32-bit value into a temporary 64-bit register, then insert it.
This is so stupid. They're loading 32 bits, and then they're anding Y to make sure you loaded 32 bits. Of course, the 32 bits above are lost, and then they're shifting left 32 bits. Huh? What? This is like backwards. This is just completely wrong. So like they're like saying that's clearly not what I was asking. And then they're like zero extended. This isn't even what I was asking. Okay, here it is. Here's the answer, I guess.
If you want to update only the low 32 bits of racks from memory without losing the upper 32 bits, NASM, copy, edit, assume racks has a value. We want to update its lower 32 bits from RBX, MOV ECX, RBX. Load 32-bit value into ECX. Upper bits zeroed, MOV EDX, EX. Save original lower 32 bits of racks, SHL racks. 32. Move high bits up, SHR racks. 32. Now racks equals 0 in low bits, or racks, LCX. Put new 32-bit value into low bits.
Is chatbot fucking dumb? This is why compilers suck, too. So they're moving into ECX, a 32-bit value. Then they're moving into EDX, EAX. So they're assuming RAX has the original value. So EDX holds a copy of EAX, so it's preserved. So what they're doing is they're shifting left RAX. They're getting rid of the top 32 bits. And then they're shifting right RAX, which means that you just destroyed the top 32 bits. It says assume, it says we want to update its lower 32 bits from RBX. Where even is RBX? There is, oh, I mean, I guess it means a load. Okay, so that means when you OR RAX with RCX, you're literally destroying the bottom 32 bits. Because you're ORing it. You're ORing RAX with the 32 bits of the 32 bits in CX. And there's no point even moving to DX because it's not used. Why would they even do that? And then here they're like, or even simpler, move EX RBX. So now ECX holds 32-bit. Are they stupid? If you shift left, you're losing the top 32 bits. You're not inserting the bottom bits, you just destroyed them. It should say shift right, then shift left. So it's like completely, utterly wrong. This just makes me angry and annoyed. I have to stop asking chatbot anything. When I ask chatbot, it just confuses me. It makes me angry. To say this is intelligent, chatbot, to say you can pass the standard GDE, to say you can pass the SAT, SATs, it can't even load 32 bits to the bottom of a 64-bit register. It even mixes that up. This thing is not intelligent. This is not taking anybody's jobs anytime soon. Ever. This is ridiculously dumb. This is just stupid. Like, this is literally stupid as fuck. It says, without losing the upper 32 bits, if you want to update RAX, only the 32 without losing, right? And then they're like, here's how you do that. Shift left. They just destroyed the upper 32 bits. Like, are you fucking kidding me? How stupid. This is the dumbest fucking shit. Anybody that uses ChatGPT to program, you are introducing so many bugs into your program. Like, you do not understand. This thing is literally, it doesn't know what it's doing. Anybody that gets code. Oh my god, it's so dumb. I'm gonna ask it, what's the most efficient way to do it? This is like the epitome of stupid. This is the dumbest thing that I've seen chatbot output. Like, literally. Like, some things I'm kind of like, well, I could see how I could do that. But this is just ridiculously dumb. And like, I can be dyslexic, flip things up, mix up numbers sometimes, or do the wrong thing. But this is like not dyslexia. This is like, it doesn't know what it's outputting. It didn't mix up left and right shifts. It doesn't know the difference between a left shift and a right shift. And people say like, chatbot has a soul. It has consciousness. No, it doesn't. I'm gonna ask it this. I'm gonna take a break. And I'm gonna try to get coding whatever.
You said, what is the most efficient way to update only the low 32 bits of racks from memory without losing the upper 32 bits? Great question. You're trying to load a 32-bit value from memory into the lower half of racks without disturbing the upper 32 bits in the most efficient way.
Okay, see, right here, it gave the correct answer. It's saying move ECX RBX and it's an OR. So that's what I came up with. It's like the only way to do it. But I also asked it the most efficient way. You know what? Micro optimizations, they don't matter. Because really, at 64-bit level, the ordering isn't going to make any difference at all, after all. So this is what I came up with, whatever. I'm pretty sure this is what other people do. You do the move to EBX, and you do the EBX on purpose. You don't want to do RBX. Well, you can't do that. Okay, whatever. In C, you could cast it, but then that's a casting, so that's different. So you do the move, do the and you do the or. Chatbot said, you do the move, you do the and you do the or, which makes sense. The only reason Chatbot gave the right answer this time is because it must have Googled it. In this one, it kind of like formed a solution based on other shit that it said. But when I asked it this directly, it must have Googled it or something and found an example to use. So the only time Chatbot is correct is when it doesn't involve thinking, when it's literally giving a copy-paste output. So I'm going to ask it why it said this last time. I'm going to try to get to work.
Great catch. Let's break it down honestly and carefully.
I like how Chatbot says honestly. Honestly. How can it be honest when it doesn't think, it doesn't have a soul, it doesn't know that's lying, it's just outputting what it does based on a list because it's biased in general, because people are biased. There's no honesty. It's just ridiculous.
Red question mark why previously wrote. Brain. My intent. I was trying to clear the lower 32 bits of racks without using and then insert a new 32-bit value into those cleared bits using a 0 extended load into RCX.
Yeah, it really didn't think. Its intent was to like copy paste things from other examples in its working training data set. And its intent was to like piece together parts to make it look like it knew what it's doing. You know what? This actually sounds like a whole lot of people who like take things from other people and then they like present it as like, this is a wonderful idea. Who thought of this idea? To see if someone will go, oh, that was my idea. And if they don't say that, they think, ooh, I got someone who doesn't know that I'm copying them. And then they try to copy you and take your identity. You know, I won't get into it. People are funny. They're kind of like ChatGPT.
Magnifying glass. But here's the technical flaw.
And when they don't get the reaction they want, which is like no reaction, or you're like, I don't know. People, I don't know. The image that you make up of somebody in your head, it's going to be wrong if that person is way out of your league or is smarter than you. You can't put people in a box. That's a really stupid thing to do.
SHL racks. 32. SHL racks. 32. This doesn't actually clear the lower 32 bits of racks. Instead, It preserves the upper 32 bits and zeroes out the upper bits of the lower 32, which is not what we want.
People will be like, let's see if you'll pass the test. It's like, bitch, I am the test, you stupid motherfucker.
Let's illustrate. Suppose Rax equals zeros of 11,223,344. So the upper 32 bits are lost, not preserved.
It would suck to lose. Especially to lose at your own test. It would really suck. I'm so glad I never lose. So chatbot was wrong, but chatbot is able to admit when it's wrong. Probably because it's not human.
Pencil, TL, DR. The previous version using SHL and SHR was wrong because it did not preserve the upper 32 bits. It was intended as a register clearing trick, but it cleared the wrong half. Thanks for catching that. You're absolutely right to question it.
But people won't say, you know what? I was clearly wrong. I apologize. Instead, people will like bottle it up, shove it all down, try to be the victim to their own game. Anyways, I'll be.
Earn the var scope declarations of statement for in of statement 4. Left-hand side expression in expression statement 4. For declaration in expression statement 4. Left-hand side expression of assignment expression statement 4. For declaration of assignment expression statement for await. Left-hand side expression of assignment expression statement for await. For declaration of assignment expression statement, return the var scope declarations of statement for in of statement 4. var for binding in expression statement 4. var for binding of assignment expression statement for await. var for binding of assignment expression statement. Let declarations 1 be for binding. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2. Note this section is extended by an XB 3.5. With statement, with expression statement, return the var scope declarations of statement. ECMA International 2024 105. Switch statement, switch, expression, case block 1. Return the var scope declarations of case block. Case block, return a new empty list. Case block, case clause assopt, default clause case clause assopt. If the first case clauses is present, let declarations 1 be the var scope declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be var scope declarations of default clause. If the second case clauses is present, let declarations 3 be the var scope declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses, case clauses, case clause. Let declarations 1 be var scope declarations of case clauses. Let declarations 2 be var scope declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause, case expression, statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Default clause, default, statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Labeled statement, label identifier, labeled item. Return the var scope declarations of labeled item. Labeled item, function declaration 1. Return a new empty list. Try statement, try block catch. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Return the list concatenation of declarations 1 and declarations 2. Try statement, try block finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of finally. Return the list concatenation of declarations 1 and declarations 2. Try statement, try block catch finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope d declarations of catch. Let declarations 3 be var scope declarations of finally. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch parameter, block. Return the var scope declarations of block. Function statement list, empty, 1. Return a new empty list. Function statement list, statement list. Return the top level var scope declarations of statement list. Class static block statement list, empty, 1. Return a new empty list. Class static block statement list, statement list. Return the top level var scope declarations of statement list. Concise body, expression body 1. Return a new empty list. Async concise body, expression body 1. Return a new empty list. Script, empty. Return a new empty list. Script body, statement list. Return top level var scope declarations of statement list. Module, empty. Return a new empty list. Module item list, module item list module item. Let declarations 1 be var scope declarations of module item list. Let declarations 2 be var scope declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item, import declaration 1. Return a new empty list. Module item, export declaration. If export declaration is export variable statement, return var scope declarations of variable statement. Return a new empty list. ECMA International 2024 107. 8. 2. 8 static semantics. Top level lexically declared names. The syntax directed operation top level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list, statement list item. Let names 1 be top level lexically declared names of statement list. Let names 2 be top level lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item, statement 1. Return a new empty list. Statement list item, declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 static semantics. Capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax directed operation, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list item. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item, statement 1. Return a new empty list. Statement list item, declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 static semantics. Top level var declared names. The syntax directed operation top level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list Statement list item. Let names 1 be top level var declared names of statement list. Let names 2 be top level var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then a return the bound names of hoistable declaration. Return a new empty list. 108. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement. Label identifier. Labeled item. Return the top level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 Static semantics. Top level var scope declarations. The syntax directed operation top level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be top level var scope declarations of statement list. Let declarations 2 be top level var scope declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then a let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the top level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. Copyright sign. ECMA International 2024 109. 8.3 Labels, 3.1 Static semantics. Contains duplicate labels. The syntax directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block, statim, empty list item, declaration, return false, statement list item. Let has duplicates be contains duplicate labels of statement list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of statement list item with argument label set. If statement, if, expression statement, else statement. Let has duplicate be contains duplicate labels of the first statement with argument label set. If has duplicate is true, return true. Return contains duplicate labels of the second statement with argument label set. If statement, if, expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while. Expression, return contains duplicate labels of statement with argument label set. While statement, while. Expression statement, return contains duplicate labels of statement with argument label set. For statement, 4. Expression statement, 4. Var variable declaration list. Expression statement 4. Lexical declaration expression statement, return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement. 4. Left-hand side expression in expression statement. 4. Var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. Var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement for await. Var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains duplicate labels of statement with argument label set. Note this section is extended by an XB. 3.5. With statement. With expression statement. Return contains duplicate labels of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains duplicate labels of case block with argument label set. Case block. 1. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains duplicate labels of the first case clauses with argument label set is true, return true. If contains duplicate labels of default clause with argument label set is true, return true. If the second case clauses is not present, return false. Return contains duplicate labels of the second case clauses with argument label set. Case clauses. Case clauses case clause. Let has duplicates be contains duplicate labels of case clauses with argument label set. If has duplicates is true, return true. Return contains duplicate labels of case clause with argument label set. Case clause. Case expression. Statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. If label set contains label, return true. Let new label set be the list concatenation of label set and label. Return contains duplicate labels of labeled item with argument new label set. Copyright sign. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. If contains duplicate labels of block with argument label set is true, return true. If contains duplicate labels of catch with argument label set is true, return true. Return contains duplicate labels of finally with argument label set. Catch. Catch. Catch parameter. Block. Return contains duplicate labels of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list. Module item. Let has duplicates be contains duplicate labels of module item list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax directed operation contains undefined break target takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list item. Let has undefined labels be contains undefined break target of statement list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of statement list item with argument label set. If statement, if expression statement, else statement. Let has undefined labels be contains undefined break target of the first statement with argument label set. If has undefined labels is true, return true. Return contains undefined break target of the second statement with argument label set. If statement, if exp Russian statement. Return contains undefined break target of statement with argument label set. Do while statement. Do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement. While. Expression statement. Return contains undefined break target of statement with argument label set. For statement. 4. Expression not. Expression not. Expression not statement. 4. var variable declaration list. Expression not. Expression not statement. 4. Lexical declaration. Expression not. Expression not statement. Return contains undefined break target of statement with argument label set. For in of statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement, return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5 Break statement, break. 1. Return false, copyright sign, ECMA International 2024 113. Break statement, break label identifier. If label set does not contain the string value of label identifier, return true. Return false, with statement, with expression statement. Return contains undefined break target of statement with argument label set. Switch statement, switch, expression, case block. Return contains undefined break target of case block with argument label set. Case block, return false, case block, case clause assopt, default clause case clause assopt. If the first case clauses is present, then if contains undefined break target of the first case clauses with argument label set is true, return true. If contains undefined break target of default clause with argument label set is true, return true. If the second case clauses is not present, return false. Return contains undefined break target of the second case clauses with argument label set. Case clauses, case clauses, case clause. Let has undefined labels be contains undefined break target of case clauses with argument label set. If has undefined labels is true, return true. Return contains undefined break target of case clause with argument label set. Case clause, case expression, statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Default clause, default, statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Labeled statement, label identifier, labeled item. Let label be the string G value of label identifier. Let new label set be the list concatenation of label set and label. Return contains undefined break target of labeled item with argument new label set. Labeled item. Function declaration 1. Return false. Try statement, try block catch. Let has undefined labels be contains undefined break target of block with argument label set. If has undefined labels is true, return true. Return contains undefined break target of catch with argument label set. 14. ECMA International 2024. Try statement, try block finally. Let has undefined labels be contains undefined break target of block with argument label set. If has undefined labels is true, return true. Return contains undefined break target of finally with argument label set. Try statement, try block catch finally. If contains undefined break target of block with argument label set is true, return true. If contains undefined break target of catch with argument label set is true, return true. Return contains undefined break target of finally with argument label set. Catch, catch, catch parameter, block. Return contains undefined break target of block with argument label set. Function statement list, empty, 1. Return false. Class static block statement list, empty, 1. Return false. Module item list, module item list module item. Let has undefined labels be contains undefined break target of module item list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.3 static semantics. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. The syntax directed operation. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Takes arguments iteration set, a list of strings, and label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement, block statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block statement with arguments iteration second. ECMA International 2024 115. Breakable statement. Iteration statement. Let new iteration set be the list concatenation of iteration set and label set. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E, of iteration statement with arguments new iteration second. Statement list. Statement list item. Let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E, of statement list with arguments iteration second. If has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E, of statement list item with arguments iteration second. If statement, if expression statement else statement, let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E, of the first statement with arguments iteration second. If has undefined lab else is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E, of the second statement with arguments iteration second. If statement, if expression statement, return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E, of statement with arguments iteration second. Do while statement, do statement while expression, return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E, of statement with arguments iteration second. While statement, while expression statement, return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E, of statement with arguments iteration second. For statement 4 expression statement 4 var variable declaration list expression statement 4 lexical declaration expression statement return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T, A, R, G, E, of statement with arguments iteration second. For in of statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Of statement with arguments iteration second. Note this section is extended by an XB. 3.5. Continue statement. Continue. 1. Return false. 116. ECMA International 2024. Continue statement. Continue label identifier. If iteration set does not contain the string value of label identifier, return true. Return false. With statement. With expression statement. Return. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Of statement with arguments iteration second. Switch statement. Switch. Expression. Case block. Return. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Of case block with arguments iteration second. Case block. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clause is present, then A. If capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Of the first case clauses with arguments iteration second is true. Return true. If capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Of default clause with arguments iteration second is true. Return true. If the second case clause is not present, return false. Return capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Of the second case clauses with arguments iteration second. Case clauses. Case clauses. Case clause. Let has undefined labels be capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Of case clauses with arguments iteration second. If has undefined labels is true, return true. Return capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E of case clause with arguments iteration set and case clause, case expression, statement list opt. If the statement Lee Street is present, return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments iteration set and return false default clause default statement list opt. If the statement list is present, return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments iteration set and return false labeled statement label identifier labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of labeled item with arguments iteration set and new label set. Labeled item function declaration 1 return false try statement try block catch. Let as undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a block with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of catch with arguments iteration set and ECMA International 2024 117 try statement try block finally. Let as undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a block with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E finally with arguments iteration set and try statement try block catch finally if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a block with arguments iteration set and is true, return true. If capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of catch with arguments iteration set and is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. Finally, with arguments iteration set and catch parameter block return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E. A block with arguments iteration set and function statement list empty 1. Return false. Class static block statement list empty 1. Return false. Module item list module item. Let as undefined labels be capital C O N T A I N S capital U N.
I spent like about a year, maybe a year and a half, planning out this JavaScript engine, whatever. So I had like a little bit of time
A R G
to like meet some, I guess you call, like interesting people.
return capital C O N.
And I know that I'm like a narcissist's best snack or supply or whatever. I know what attracts a narcissist. And like, I don't know. And narcissist is like overly used. It's like a set of traits. And it's on a sliding scale. Not everyone is a narcissist. Some people are just insecure. And some people are just assholes. But it's easier to just call people a narcissist when they have certain traits or whatever. And like, the worst thing is that I could make like a comment or whatever, and they would think it's about them, but really it's about a different person who is also like that. And there's so many people like that. Like 3 or 4% of the people are like real people without like these huge underlying massive holes in like their soul and how they treat people. And they don't even want to be fixed. That's why they're like that in the first place. And by fixed, I mean not fixed. I mean they don't care about other people other than themselves. And you can't make them care, and you shouldn't want to make them care. I don't know. You can't control people, but when those people control other people, it's just frustrating. Because people feed into it. And they make like monsters or whatever. I don't know. So like when I don't know. I think I'm gonna make comments now and then. Because it's not directed at one person specific. It literally is not directed at one person specific. And I'm not bitter about it. It's just an experience. And I'm just talking about it. So I don't know. I think I'm just gonna like drop little comments like that from now on. Even if someone were to think it's about them when it's really not. I don't know. That's not my problem. I'll just be selfish. Stop thinking about other people. All about me. Because really, if I like cater to like not try to trigger someone who I know could possibly be watching, that's like the same thing as intentionally triggering them. So I don't know.
Directed operation.
I guess that's not my problem. I guess I should just be an asshole then. I don't know. I gotta get this stupid shit assembly running.
T H E
So I'm gonna try that or whatever.
capital E X.
I gotta like set a 64-bit value. I'm gonna do like normal assembly. I'm not gonna play games with like rotating the value, shifting it, trying to like load up a register and then set it as a full register. And then like writing a program. You can't really write a whole program in assembly. It would take too long. You could, but it's like you need to write, or the time it takes to do every little operation takes too long. And then there's multiple processors. So writing something in C does make more sense, unless you have your own compiler written by hand. I don't know. That's why I gotta save assembly though for later. After it's like running, I can like pick and choose what to convert. Because before that, especially when I go through this stupid standard,
Plus unary expression, unary expression, unary expression, delete unary expression, void unary expression.
there's gonna be things that like have certain rules and conditions, and I'll meet them, and then I'll probably go to another page. Then something changes, I gotta go back up, I have to change the code. And if I write the whole thing, or parts of it in assembly to start with, it'll take so long to get done. Because this is, it's not flexible to write assembly, unless you have macros. Even then, it's only so flexible. And once you start making macros and stuff, you lose speed. Because you can't always use registers for certain uses. And there's no way to systematically approach it optimally without making macros. And you basically end up being a compiler, which is not efficient at all. The only way is to like have the total like program, like if this is a program, I don't know. Where's the C program?
Expression bitwise and expression bitwise or expression bitwise or expression bitwise or expression logical and expression and bitwise or expression logical or expression logical or expression logical and expression coalesce expression head bitwise or expression.
I'm trying to find something really quick.
Assignment expression 20 ECMA International 2024 assignment expression yield expression left hand side expression equals assignment expression left hand side expression assignment operator assignment expression left hand side expression and equals assignment expression left hand side expression equals assignment expression left hand side expression equals assignment expression assignment expression return false assignment expression arrow function async arrow function expression function binding identifier opt formal parameters function body generator
I don't know. 90% of my C code is macros. So I can't find a good example.
formal parameters async generator body async function expression async function.
But the only realistic way to write a program in assembly on the modern operating system based on everything set up, like if this was a C program, this is not. This is like just some test stuff from a program. You need like to write something in C. So then like this would be like semi cross-platform because C is kind of standardized. Kind of like how people treat each other. It's kind of standardized. You have expectations of stuff, but you know there's gonna be like those a-holes out there who think they gotta like cock block you because they're like, you must be talking to this chick because you want to sleep with her, so I'm gonna try to make you look like an idiot because I'm insecure about myself, so I gotta pull this little stunt here. I don't know. And then you know about that person what their true intentions are. You know that they just go around raging, want to sleep with everyone. I don't know. So like standards don't really mean much anyways. But in a C program, it's mostly standardized. So like this would run on a cell phone or like PC, whatever, x86 or ARM. And you write the code once, whatever. And then you like, after like you have the whole program, whatever, you could go through and like replace parts of it with assembly. This is like a stupid example. This makes no sense. This is like fake code. At this point, I'm just pasting the same block of code above. But what you need to do though is have the whole program like in front of you. So you can be like, all right, I got this many registers here, whatever. And then you take like, this is information, kind of like how I have a diagram here, whatever. And you like look at this and you like find like the data points. The best way to like pass one thing to the next is like a straight line. Well, you'd have branches or whatever. Like the only way to handle assembly is like that in the modern OS because it's text files. If the modern OS was more modern, you were able to like make shortcuts. Like you can do like on the desk. Oh my god, Windows sucks. Why can't it leave the windows on the right window? It just keeps fucking moving them around. On the desktop though, you could do new. I really hate this magnifier tool. You could do new, folder, shortcut, but you can't do that with text. With text, you're stuck to a folder that holds the text file, and it sucks. If the modern OS were modern, because it's not modern, but if it was modern, where the fuck is, which window is it? That didn't help. Is this it? If the OS was modern, you should be able to like right click on some code or whatever and then have it like open up a new window or something. You could type in assembly and you should be able to like click in menu and filter like, do you want to see C code? Do you want to see assembly code? I don't know. This is ridiculous, writing code in a text editor. This whole thing, the system, whatever, how the OS works, one day it'll be replaced with something better. But until then, just gotta deal with it. So I don't know. That's the only way to really write a program. So like now, at least I have my feet wet, whatever. I kind of like figured out most of x86, 64. I'm gonna have to do shit like this because you can't just do this because they zero extend at the top due to a technicality. There's no way it's by choice. It's because how it's designed and implemented. I don't know. Programming takes way too much work. And going through the standard, it's gonna suck. And I thought I was ready, but these things are taking way too long already. I'm still ready, but this is just annoying, like the learning curve. This is ridiculous though. You can't just do move. You have to freaking move it to a separate register, then and it, and then or it. That is just ridiculous. It's kind of like the compiler. In the compiler, the C compiler,
A N.
You have to like write code top to bottom. It has to be organized because the compiler won't reorganize the code. So with x86, 64, they were clever. By doing this, the sign extension, they're like, now it's on the user to deal with the conversion between 32-bit and 64-bit. So that way they can hand it off the issues that they didn't want to figure out or deal with to the user to deal with at the user end. So then the user is like, this isn't efficient. I hate having to program, do a load, do a mask, and then OR. And they're like, well, it's the only way to do it. Because they didn't do something at the CPU level. It's on the user. So like the workload and like, I don't know, it's like passing off the excuse onto the user. Everything is way more work than it should be. So I'm gonna get to work. I'm gonna undo my comments. I'll put this to my notes or something. I'm gonna like print a freaking 64-bit value to the window. Oh, I gotta move around all of my windows. They all moved. And like, where's the sound? It's not coming from this computer.
I N C capital A R R equals async
What even?
S T A
Something's wrong with this computer.
E capital A S Y.
So, I don't know. I'm gonna try to get to work, whatever. I think I'll be able to speed test stuff today. Hopefully. Maybe not. Who knows? Because I also have to like make sure that what Jetpack gave me works using the file system time. See how accurate it is. I have to like make a loop to find how long it takes to get the time so I can average it, to average out the noise. So I can like get a somewhat accurate speed test. Because getting the cycles that it takes to complete, that's not time. I want like the time. So I'm gonna figure out how to get that so I can speed test stuff. And I'll stop wasting time trying to like come up with clever ways. I'm gonna have to just, I don't know. 64-bit assembly sucks ass. So I'm gonna try to get to work or whatever.
2. If child is an instance of symbol, return true. B. If child is an instance of a non-terminal, then I let contained be the result of child contains symbol. 2. If contained is true, return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier opt. Formal parameters. Function body. Generator declaration. Function binding identifier. Formal parameters. Generator body. Function. Formal parameters. Generator body. Generator expression. Function binding identifier opt. Formal parameters. Generator body. Async generator declaration. Async function binding identifier. Formal parameters. Async generator body. Async function. Formal parameters. Async generator body. Async generator expression. Async function binding identifier opt. Formal parameters. Async genera to a body. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Async function. Formal parameters. Async function body. ECMA International 2024 123. Async function expression. Async function binding identifier. Formal parameters. Async function body. Return false. Note 1 static semantic rules that depend upon substructure generally do not look into function definitions. Class tail. Class heritage art. Class body. If symbol is class body, return true. If symbol is class heritage, then if class heritage is present, return true. Otherwise return false 3. If class heritage is present, then if class heritage contains symbol is true, return true. Return the result of computed property contains of class body with argument symbol. Class static block. Static. Class static block body. 1. Return false. Arrow function. Arrow parameters equals. Concise body. If symbol is not one of new target. Super property. Super cool. Super. Or this. Return false. If arrow parameters contain symbol is true. Return true. Return concise body contains symbol. Arrow parameters. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let formals be the array formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return formals contain symbol. Async arrow function. Async arrow binding identifier equals. Async concise body. If symbol is not one of new target. Super property. Super cool. Super. Or this. Return false. Return async concise body contains symbol. Async arrow function. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R equals. Async concise body. If symbol is not one of new target. Super property. Super cool. Super. Or this. Return false. Let head be the async arrow head that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. If head contains symbol is true. return true, return async, concise body contains symbol. 124. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class bodies except for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target. This and super usage within an arrow function or async arrow function. Property definition. Method definition. If symbol is method definition, return true. Return the result of computed property contains of method definition with argument symbol. Literal property name. Identifier name. Return false. Member expression. Member expression. Identifier name. If member expression contains symbol is true, return true. Return false. Super property. Super. Identifier name. If symbol is the reserved word super, return true. Return false. Call expression. Call expression. Identifier name. If call expression contains symbol is true, return true. Return false. Optional chain. Identifier name 1. Return false. Optional chain. Optional chain. Identifier name. If optional chain contains symbol is true, return true. Return false. 5.2 static semantics. Computed property contains. The syntax directed operation computed property contains takes argument symbol, a grammar symbol, and returns a boolean. It is defined piecewise over the following productions. Class element name, private identifier, property name, literal property name, return false, property name, computed property name, return the result of computed property name contains symbol, method definition, class element name, unique formal parameters, function body, get class element name, function body, set class element name, property set parameter list, function body, return the result of computed property contains of class element name with argument symbol, generator method, class element name, unique formal parameters, generator body, return the result of computed property contains of class element name with argument symbol, ECMA International 2024 125, async generator method, async class element name, unique formal parameters, async generator body, return the result of computed property contains of class element name with argument symbol, class element list, class element list, class element. Let in list be computed property contains of class element list with argument symbol. If in list is true, return true. Return the result of computed property contains of class element with argument symbol. Class element. Class static block 1. Return false. Class element 1. Return false. Async method. Async class element name. Unique formal parameters. Async function body 1. Return the result of computed property contains of class element name with argument symbol. Field definition. Class element name initializer opt. Return the result of computed property contains of class element name with argument symbol. 0.6 miscellaneous. These operations are used in multiple places throughout the specification. 6.1 runtime semantics. Instantiate function object. The syntax-directed operation instantiate function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions. Function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J, a function declaration with argument CNV and private env, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, of generator declaration with argument CNV and private env, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, return, capital I, N, S, T, A, N, T I A T E capital A S Y N C capital G E N E R A T O R capital F U N C T of a sync generate or declaration with arguments env and private env. 26. ECMA International 2024. A sync function declaration. A sync function binding identifier. Formal parameters. A sync function body. A sync function. Formal parameters. A sync function body. Return instantiate a sync function object of a sync function declaration with arguments env and private env8. 6. To runtime semantics. Binding initialization. The syntax-directed operation binding initialization takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Binding identifier. Let name be string value of identifier. Return. Initialize bound name. Name. Value. Environment. Binding identifier. Yield. Return. Initialize bound name. Yield. Value. Environment. Binding identifier. Await. Return. Initialize bound name. Await. Value. Environment. Binding pattern. Object binding pattern. Perform. Require object coercible. Value. Return. Binding initialization of object binding pattern with arguments value and environment. Binding pattern. Array binding pattern. Let iterator record be. Get iterator. Value. Sync. Let result be completion. Iterator binding initialization of array binding pattern with arguments iterator record and environment. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Object binding pattern. 1. Return unused. Object binding pattern. Binding property list. Binding property list. Perform. Property binding initialization of binding property list with arguments value and environment. Return unused. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 127. Object binding pattern. Binding REST property. Let excluded names be a new empty list. Return. REST binding initialization of binding REST property with arguments value, environment, and excluded names. Object binding pattern. Binding property list. Binding REST property. Let excluded names be. Property binding initialization of binding property list with arguments value and environment. Return. REST binding initialization of binding REST property with arguments value, environment, and excluded names. 6. 2. 1. Initialize bound name, value, environment. The abstract operation initialize bound name takes arguments name, a string, value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps: WH called if environment is not undefined, then a perform environment initialize binding name value be return unused, else a let LHS be resolve binding name be return put value LHS value, 6.3 runtime semantics, iterator binding initialization. The syntax-directed operation iterator binding initialization takes arguments iterator record, an iterator record, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Array binding pattern. 1. Return unused. Array binding pattern. Elision. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Array binding pattern. Elision not binding rest element. If elision is present, then a perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, a collision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Array binding pattern. Binding element list. Elision. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 2. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return.
Once I make like one macro, I go macro crazy, and I end up with zero code, all macros.
R, I, N.
So like this is from like maybe 2 days ago, 3 days ago, too many days ago. Talking really adds to time it takes to get anything done. Basically, there's a little endian, big endian,
If elision is present, then a put
at CPU level. Big endian means like, I don't know, it depends on context.
T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, a collision with argument iterator record.
I think big endian, it really doesn't matter. When it comes down to the value itself, whatever,
Binding element list with arguments iterator
if it's one way or the other way. One way,
binding elision element with
you compute the base, like here, whatever, and you have to write to it backwards. So like from left to right. So like if this is like at the address
S,
22, this is 23.
C, T, U, R, I, N, G, capital A, S, S, I, G, N, N.
You compute to like the address 22 like a normal sane person. But I think this is little endian, x86, and then ARM can be both, one or the other, which is kind of cool. But it's I don't know. I won't get into processes, whatever.
Value. Iterator record. B if next is not done.
I won't even ask chatbot. Little endian, big endian, whatever. If I write to it like this, starting from the base, like a sane person,
Value B. Evaluation of initialized
like the text up here, this box
environment is undefined.
that it makes.
Value. LHS. V. Return.
When I write to them in memory, I have to write in reverse order. So like I'll compute to like right here, but I have to add to get to the end of it and set it backwards. Because setting it from the base isn't the way that it's going to be pulled into memory. Because when you pull into memory, it grabs it from the end. It grabs it at the offset from the base of the type size that it is, and it ends up being flipped. So I have to write it in memory, have to compute to the end of it, and write backwards, if that makes any sense. And I have to literally add an offset or compute an offset beforehand, because
If environment is undefined. Return.
it's like physics, like physically. If you compute to the 22nd character, so if I have like a string,
To string. N. Next. E set n to n plus 1. Binding rest element. Binding pattern. Let A be. Array create. 0, let 0, repeat, let next be done, be if iterator record is false, then I set next to, iterate a step value, iterate to record see if next is done, then I return, binding initialization of,
This is a string, whatever. I'm going to count up the characters. Let's say I want to replace potato with the word chip.
M,
So I'm going to count up the characters. So like 0,
Fun
1, 2, 3, 4, 5, 6. So like these are all like byte characters, whatever.
and environment, return, iterate,
Assuming from
environment, formal parameter list, formal parameter list, formal parameter, perform,
the ASCII chart code table, whatever, all a byte. Since 1970s or something, nothing's changed.
data record and environment, arrow parameters, binding identifier, let v be undefined, assert, iterator record is false, let next be,
And when things do change, they add like emojis or some dumb shit instead of like updating, text encoding, fixing things, changing things, making them more efficient. They add like emojis, like okay, like they could have worked on the operating system. They could have made, I don't know, whatever. So like I'm gonna count up the letters to potato. So 6, 7.
O, N, capital A, N, let formals be the arrow,
So like 10 is bigger than, so I'm just gonna, whatever. I'm gonna count to the end. 1 second.
capital P, A, R, E, N, T, H, E, S, I, Z,
Alright, that's 28. So like, I was counting in my head. I was off by a couple characters. But I got to 28, so I have to like shift this back. One skill of programming is that you can kind of like memorize the length of words. And when we're making notes, you can get really good at like aligning notes and planning on how to word something. So it ends up being the same exact length as the line before it. It's a completely useless skill. So anyways, let's say this is 28.
syntax directed,
Well, it is. I guess based on context, nothing really matters in the end.
reference, identifier, if this
So if I want to like write to 28, I want to write the word chips.
fire reference, yield, await, call expression, expression, call expression, identifier name, call expression, private
So we'll say this is a chips.
expression, member expression, identifier name super property, member expression,
I can't physically. If it's like the computer is a little endian, big endian. I think little endian is this way, which is what this is, x86. If I write to here and I like increment and set the characters CHIPS to replace potato.
I, O, N, capital A, N, let X be the parenthesized,
Wow, insert, the insert key is actually useful. So I'm going to do replace whatever.
capital P, A, R, E, N, T,
So now it says chips, right?
Z, E, D, capital E,
So that's at indice 28. I have to loop, right? To set the characters, copy them. So it says 28, 29, 30, 31, 32, 33, 34. So I counted literally 28 to 34. It's not possible. So like the CPU, whatever, it loads it in from 28 to 34. But it grabs it backwards. So like if it's gonna grab 8 bytes, it's gonna be reversed because it grabs it from the end of the base, which is 28. So like if I load in memory, it ends up looking like this.
Template literal new member express.
So like if I wrote chips to memory, I'm gonna load chips
1. New target. New target.
or write whatever. It'll look like this. Instead of like this, it'll look like this.
Hand side expression plus plus. Left hand side expression plus plus unary expression. Unary expression. Unary expression. Delete unary expression. Void unary expression.
Which is chips backwards. Because the little endian grabs from the end, the smaller end, which is from the base. So like I started at character 28, the offset memory, that's at 29, 30, 31, whatever. There's no way to start from the end of the memory unless I add to 28 the end of it. So here, I had to physically add the offset of the data that I'm going to end, which is 8 bytes. So like in this case, I had to do 28 plus
See off shift expression relational expression in shift expression.
6 possibly, I don't know.
Equal.
So it adds like this extra annoyance where before I can't just start writing at 28. I have to do 28
T expression equals relational expression.
plus 6. So it's like another extra computation beforehand. But it could be compile time if I know if it's a little endian or big endian in advance.
Expression, logical and expression and bitwise or expression. 32. ECMA.
Was that 36? I don't know.
Logical or expression
Right? 28, 29, 30. 4 left. 34. 28, 29, 30. Possibly 34. I don't know. So I have to compute to 34, right?
A sync arrow function. Left hand side.
Because you can't just go from the end, from the beginning to the end, if you don't compute it.
Left hand side expression equals.
So now that I computed the end here at 34,
Return invalid, 6.5 static semantic.
it might be 33. I don't know, something's off here. It's just an example though.
Over the following productions, property definition.
So I have to compute to here, whatever. And now I can subtract backwards from here. Or I could write from here forwards, but I have to have my text reversed. So I could also, either way, something needs to be backwards to set it forwards to the other place. And you don't really, I can't explain how frustrating it is until you have to do it, because it's really frustrating. I had to add this extra stupid thing based on the direction of the data. If I load the data in bytes, one by one, I can shift them. That's be much slower though. So I gotta deal with this extra shit and flipping shit around. It's just annoying. Anyways, my point though, I think I'm gonna make a macro for this here, and I'll put a toggle for big endian or little endian, and I'll macrotize this loop structure to use for the stuff below that I'm writing.
1. Return empty.
Because writing this out every time is gonna be really annoying. I already have way too much code.
Class element name initializer opt 1. Return prop name of class element name. Class element name. Private identifier.
Right here I defined out 1, 2, 3, 4, up to 16.
1 environment records. Environment record is a specification type used to define the association of identifiers to.
So I literally typed it all up the same way to get the same spacing for the whole thing. What I need to do is make a loop, compute the size, and have it at runtime fill out the string instead of recompute it by hand.
Code is evaluated.
So I have to start making macros and shit.
Bindings that are created by that code.
This makes it completely unreadable and difficult to work with.
This is used to model the logical nesting of environment record values. The outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment record. An environment record may serve as the outer environment for multiple inner environment records. For example, if a
I don't know. I'm gonna try to like macrotize this stuff and then use it for the stuff below. But what I need to do now is focus on just printing these stupid characters. There's like so many things I gotta like. I can't multitask. I'll get back to making this macro later. For now, I'll just copy paste it and use it as a template. And later on, I'll have to go through and macrotize things. I also want to make the data segment bigger, or the zeroed segment BSS segment bigger to like larger than 4 gigs to see if it can support that. Because this computer is 32 gigs. So like, I don't know. I want to see if the 32-bit limits still exist for a quote 64-bit CPU. So I'm gonna undo these notes. I don't know, this sucks. 64-bit assembly is ridiculous.
supports super method invocations, a module environment record contains the bindings for the top-level declarations of a module. It also contains the bindings that are explicitly imported by the module. It is a global environment record, an object and
I need to get some water.
effective ECMAScript elements such as with statement that associate identifier bindings with the properties of some object. A global environment record is used for script global declarations. It does not have an outer environment. It is null. It may be prepopulated with identifier bindings, and it includes an associated global object whose properties provide some of the global environment's identifier bindings. As ECMAScript code is executed, additional properties may be added to the global object and the initial properties may be modified. The environment record abstract class includes the abstract specification methods defined in Table 16. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Table 16. Abstract methods of environment records. Method purpose has binding n. Determine if an environment record has a binding for the string value n. Return true if it does and false if it does not. Create mutable binding n. D. Create a new but uninitialized mutable binding in an environment record. The string value n is the text of the bound name. If the Boolean argument d is true, the binding may be subsequently deleted. Create a mutable binding n. S. Create a new but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. If s is true, then attempts to set it after it has been initialized will always throw an exception, regardless of the strict mode setting of operations that reference that binding. Initialize binding n. V. Set the value of an already existing but uninitialized binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and is a value of any ECMAScript language type. Set mutable binding n. V. S. Set the value of an already existing mutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and may be a value of any ECMAScript language type. S is a Boolean flag. If S is true and the binding cannot be set, throw a type error exception. Copyright sign, ECMA International 2024, 35. Table 16. Abstract methods of environment records. Continued. Method purpose get binding value n. S returns the value of an already existing binding from an environment record. The string value n is the text of the bound name. S is used to identify references originating in strict mode code or that otherwise require strict mode reference semantics. If S is true and the binding does not exist, throw a reference error exception. If the binding exists but is uninitialized, a reference error is thrown, regardless of the value of S. Delete binding n. Delete a binding from an environment record. The string value n is the text of the bound name. If a binding for n exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Has this binding. Determine if an environment record establishes this binding. Return true if it doesn't, false if it does not. Has super binding. Determine if an environment record establishes a super method binding. Return true if it doesn't, false if it does not. With base object. If this environment record is associated with a with statement, return the with object. Author ice. Return undefined. 9. 1. 1. 1 declarative environment records. Each declarative environment record is associated with an ECMAScript program scope containing variable, constant, let, class, module, import, and/or function declarations. A declarative environment record binds the set of identifiers defined by the declarations contained within its scope. The behavior of the concrete specification methods for declarative environment records is defined by the following algorithms. 1. 1. 1. 1 has binding. N. The has binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. If envrec has a binding for n, return true, return false, 1, 1, 1. 2. Create mutable binding. N. D. The create mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, and e, a boolean, and returns a normal completion containing unused. It creates a new mutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if d is true. The new binding is marked as being subject to deletion. It performs the following steps when called. Assert. envrec does not already have a binding for n. Create a mutable binding in envrec for n and record that it is uninitialized. If d is true, record that the newly created binding may be deleted by a subsequent delete binding call. Return unused. 36. ECMA International 2024. 9. 1. 1. 1. 3. Create a mutable binding. N. S. The create a mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns a normal completion containing unused. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Assert. envrec does not already have a binding for n. Create an immutable binding in envrec for n and record that it is uninitialized. If s is true, record that the newly created binding is a strict binding. Return unused. 1. 1. 1. 4. Initialize binding. N. V. The initialize binding concrete method of a declarative environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns a normal completion containing unused. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Assert. envrec must have an uninitialized binding for n. Set the bound value for n in envrec to v. Record that the binding for n in envrec has been initialized. Return unused. Set mutable binding. N. V. S. The set mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. A binding for n normally already exists, but in rare cases it may not. If the binding is an immutable binding, a type error is thrown if s is true. It performs the following steps when called. If envrec does not have a binding for n, then if s is true, throw a reference error exception. B. Perform envrec create mutable binding. N. True. C. Perform envrec initialize binding. N. V. D. Return unused. If the binding for n in envrec is a strict binding, set s to true. If the binding for n in envrec has not yet been initialized, then A. Throw a reference error exception. Else if the binding for n in envrec is a mutable binding, then A. Change its bound value to v. Else A. Assert. This is an attempt to change the value of an immutable binding. B. If s is true, throw a type error exception. Return unused. Note an example of ECMAScript code that results in a missing binding at step 1 is function f, eval, var x equals, delete x, 0. ECMA International 2024 137. 9. 1. 1. 1. 6. Get binding value, n, s. The get binding value concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert envrec has a binding for n. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec, 1, 1, 1, 7. Delete binding n. The delete binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert envrec has a binding for n. If the binding for n in envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1, 1, 1. 8 has this binding. The has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 9 has super binding. The has super binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 10 with Basia object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1, 1, 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide this binding. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide a super binding. 38. Copyright sign, ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. Object environment records created for with statements, 14.11, can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17, additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms, 1, 1, 2. 1 has binding, n. The has binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called. Let binding object be envrec. Let found binding be. Has property, binding object, n. If found binding is false, return false. If envrec is false, return true. Let unscopables be. Get binding object, add at unscopables. If unscopables is an object, then a let block be to Boolean. Get unscopables, n. Be if blocked is true, return false. Return true, 1, 1, 2. 2 create mutable binding, n. D. The create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused o or a throw completion. It creates an environment records associated binding object a property whose name is n and initializes it to the value undefined. If d is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called. Let binding object be envrec. Perform. Define property or throw, binding object, n, property descriptor, undefined. True, true, D. Return unused. Field name, value, meaning, binding object. An object. The binding object of this environment record is with environment. A boolean indicates whether this environment record is created for a with statement. Note normally envrec will not have a binding for an, but if it does, the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an abrupt completion to be returned. ECMA International 2024 139 9 1 1 2 3. Create a mutable binding. N. S. The create a mutable binding concrete method of an object environment record is never used within this specification. 1 1 2 4. Initialize binding. N. V. The initialize binding concrete method of an object environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. It performs the following steps when called. Perform envrec set mutable binding. N, v, false. Return unused. 1 1 2 5. Set mutable binding. N, v, s. The set mutable binding concrete method of an object environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment record's associated binding object's property whose name is n to the value v. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let binding object be envrec. Let still exist as b. Has property, binding object, n. If still exists as false and s is true, throw a reference error exception. Perform. Set. Binding object. N. V. S. Return unused. 1 1 2 6. Get binding value. N. S. The get binding value concrete method of an object environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its associated binding object's property whose name is n. The property should already exist, but if it does not, the result depends upon s. It performs the following steps when called. Let binding object be envrec. La t value b. Has property, binding object, n. If value is false, then, if s is false, return undefined. Otherwise throw a reference error exception for return. Get binding object, n, 1 1 2 7. Delete binding. N. The delete binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute have the value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object. N. 40. ECMA International 2024 9 1 1 2 8. Has this binding. The has this binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 2 9. Has superbinding. The has superbinding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 2 1 0. With base object. The with base object concrete method of an object environment record envrec takes no arguments and returns an object or undefined. It performs the following steps when called. If envrec is true, return envrec. Otherwise, return undefined, 1 1 3. Function environment records. A function environment record is a declarative environment record that is used to represent the top-level scope of a function and, if the function is not an arrow function, provides this binding. If a function is not an arrow function and references super, its function environment record also contains the state that is used to perform super method invocations from within the function. Function environment records have the additional state fields listed in Table 18. Table 18 Additional fields of function environment records. Note: object environment records do not provide this binding. Note: object environment records do not provide a super binding. Field name: value, meaning this value. An ECMAScript language value. This is the this value used for this invocation of the function. This binding status: lexical, initialized, or uninitialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object. An ECMAScript function object. The function object whose invocation caused this environment record to be created. New target. An object or undefined. If this environment record was created by the internal method, uTarget is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in Table 19. Table 19, additional methods of function environment records. Method. Purpose. Bind this value. V. Set the end record that it has been initialized. Get this binding. Return the value of this environment records this binding. Throws a reference error if this binding has not been initialized. Get super base. Return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records is defined by the following algorithms. 1, 1, 3, 1 bind this value, v. The bind this value concrete method of a function environment record envrec takes argument v, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert: envrec is not lexical. If envrec is initialized, throw a reference error exception. Set envrec to v. Set envrec to initialized. Return v, 1, 1, 3, 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true. 9, 1, 1, 3. 3 has super binding. The has super binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. If envrec is undefined, return false. Otherwise, return true. 1, 1, 3. Forget this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert: envrec is not lexical. If envrec is uninitialized, throw a reference error exception. Return envrec. 42. ECMA International 2024. 9, 1, 1, 3, 5 get superbase. The get superbase concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing either an object, null, or undefined, or a throw completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert: home is an object. Return home, 1, 1. 4 global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMAScript script elements that are processed in a common realm. A global environment record provides the bindings for built-in globals, clause 19, properties of the global object, and for all top-level declarations, 8, 2, 9, the 8th of February 2011, that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19. And all bindings introduced by a function declaration, generator declaration, async function declaration, async generator declaration, or variable statement contained in global code. The bindings for all other ECMAScript declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, The object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records. Field name, value, meaning, object record, an object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMAScript object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. V are names, a list of strings. The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024. 43. Table 21. Additional methods of global environment records. Method. Purpose. Get this binding. Return the value of this environment records. This binding has var declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration. Has lexical declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration. Has restricted global property. N. Determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var. N. Determines if a corresponding create global var binding call would succeed if called for the same argument. N. Can declare global function. N. Determines if a corresponding create global function binding call would succeed if called for the same argument. N. Create global var binding. N. D. Used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N. V. D. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1. 4. 1 has binding. N. The has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n, is true, return true. Let OBJREC be envrec. Beject record. Return. OBJREC has binding, n, 1, 4. 2 create mutable binding, n, d. The create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the name n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true. Throw a type error exception. Return. DCLREC create mutable binding n d, 1 1 4 3 create a mutable binding n s. The create a mutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true. Throw a type error exception. Return. DCLREC create a mutable binding n s, 1 1 4 4 initialize binding n v. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true, then a return. DCLREC initialize binding n v. Assert. If the binding exists, it must be in the object environment record. Let objrec be envrec. Return. Objrec initialize binding n v, 1 1 4 5 set mutable binding n v s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. If the binding is an immutable binding and s is true, a type error is thrown. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true, then a return. DCLREC set mutable binding n v s. Let objrec be envrec. Return. Objrec set mutable binding n v s, 1 1 4 6 get binding value n s. The get binding value concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true, then a return. DCLREC get binding value n s. ECMA International 2024 145 3. Let objrec be envrec. Return. Objrec get binding value n s, 1 1 4 7 delete binding n. The delete binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec if DCLREC has binding n is true, then a return. DCLREC delete binding n. Let objrec be envrec. Let global object be objrec. Let existing prop be has own property, global object n. If existing prop is true, then a let status be objrec delete binding n b. If status is true and envrec contains n, then I remove n from envrec. See return status. Return true, 1 1 4 8 has this binding. That has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1 1 4 9 has super binding. That has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 4 10 with base object. The with base object concrete method of a global environment record env rect takes no arguments and returns undefined. It performs the following steps when called. Return undefined 9, 1, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record env rect takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return env rec 146 ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9, 1, 1, 4, 1, 2 has var declaration. N. The has var declaration concrete method of a global environment record env rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be env rec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record env rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let DCL-rec be env rec. Return. DCL-rec has binding. N, 1, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let obj-rec be env rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, 1, 1, 4, 1, 5 can declare global var. N. The can declare global var concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if calls for the same argument n redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let obj-rec be env rec. Let global object be obj-rec. Let has property be has own property, global object. N. If his property is true, return true. Return is extensible, global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function. N. The can declare global function concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if calls for the same argument, and it performs the following steps when called. Let obj-rec be env rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values. True, enumerable. True, return true. Return false, 1, 1, 4, 1, 7 create global var binding. N. D. The create global var binding concrete method of a global environment record env rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called. Let obj-rec be env rec. Let global object be obj-rec. Let has property be has own property, global object. N. Let extensible be is extensible, global object. If his property is false and extensible is true, then a perform. Obj-rec create mutable binding. N. D. B perform. Obj-rec initialize binding. N. Undefined.
be like if this is like the header of the text blob, whatever. This is like the body or like category. I don't know. I gotta like come up with like a name or something and separate things out and make a loop, compute the size needed, have a loop through and populate the string when the program starts instead of beforehand. You could also compute it beforehand just as easily as at runtime because this is an assembly. It's um, it's like the macros are much better than C language. Like these are like real useful actual macros, at least with NASM. The NASM assembler is really good. Like, I don't know. Whoever designed it was actually really smart. Unlike Visual Studio, those people are idiots. Microsoft is, yeah. But this piece here, I have to separate it from the header. And this is like a subheader within a category, whatever I want to call it. I'll give it a name. And then I need to make a template of this in generic ties. Generic ties, if that's even a word. This header for this header. And then I have to like make this generic as a macro or a loop at runtime. Doesn't matter. Just make it generic so that I can like take this chunk, whatever, and have a second one underneath it here. So it's easier to like control stuff or whatever. Because now I need like, so I need to do that, okay? This is all tied to like doing a speed test. Because I have to test the address too. I'm trying to do a speed test, but I'm also trying to wrap my head around x86, its limitations, and like the things that it's good at. I have to like really understand it or whatever if I'm gonna have like an advantage when I convert later. Because basically when I set up my JavaScript engine that I had before them converting to 64-bit. I have to get back to that. But you're limited to like 4 gigs in 32-bit mode. So in 32-bit mode, you're limited to 4 gigabytes. So what I did is I used like 3.5 gigs. So like almost all of it. So like Windows, or like the program code and stuff, would use like 0.5 of a gig to hold like the program or whatever. And then I paged to the hard drive, like in this crappy diagram. So I'd use the 3 gigs, whatever, 3.5 to hold what was in use. And as things like were used less, page them off to the hard drive, the file system, whatever. Because I wrote it in 32-bit, I should have wrote it. I don't know. I did it on purpose as like a challenge. Because 64-bit sucks. It's not really 64-bit. But now I'm actually gonna write in 64-bit. It doesn't matter if it's real or not, because that's the only way to realistically access not even all the hardware. They still don't let you access everything. It's the only way to easily, I don't know, instead of going against the current, I'm just gonna do 64-bit. But how it looks though, with 64-bit assembly, they use default relative. That means it applies the program position to the offset, whatever. And then chatbot said, you can't do Chatbot said you can't do relative move on a register only if it's a label. And then it said that it's limited to a range of positive -2 gigabytes, which is 4 gigs, which is 32-bit. So it looks like AMD set up 64-bit, and these labels to memory, they may be limited to a 4 gigabyte area because you can't do a relative address on EBX, because when you pass in EBX, they expect you to follow RIP addressing, which means that technically it's absolute addressing. I don't know if you can type absolute. I think it defaults to absolute for convention reasons, whatever. So it's annoying. So like without the keyword, it means absolute, I guess, unless you use default, which is why they recommend using default so you don't think about it. I have to think about it because I have to set up this stupid program to optimally take advantage of the hardware. That's the whole point of spending my time converting it and writing this thing, is to get every little bit of performance that I can get relative to whatever the operating system runs at. Because a modern operating system, it sucks. But I'm just writing a program on the OS. Writing OS is a whole other thing. But since I'm writing on Windows, not apart from Windows, which I do some time to time. Anyways. I need to figure out if that's what's happening with this whatever. Because if that's true, when I make my large allocation, if I'm on a page, I was going to update my engine that I have right now. I don't have all the mechanisms, I have most of it. When I update it, I might have to like instead of making memory allocation like in the BSS segment, like in 32-bit mode, if it's true that this lower area, or like the start area of the program, is limited to 4 gigabyte offsets, I'm not sure if that affects the program, like the main function, if it's C. Like the main function, right? It's gonna exist in the 4 gigabytes or whatever at some address as the program runs. So like if main takes up this much memory, what about other functions? Like if I have a function called potato, I need to not stall if I'm thinking, so I don't know. I don't think this is technically stalling. I do have to get back to finishing up whatever. if I have like another function named foo, these functions, whatever, does AMD behind the scenes tie a segment to foo, potato, and main, or do they all exist within the same segment? Because the offset of the variables are applied to the relative offset. But is that offset relative to the whole area that's within relativity to whatever the fuck relative means of the program's base point? Which means that if something is relative at a memory offset, does this memory offset that applies to main like if I have var x offset, this is main. Let's say like this is at location 46 in memory. So like that's its offset relative to whatever the position. They call it position independent, but it's really not. If it can't change as the program's running, it's not position independent. It's position dependent. So if the position of the program's at like 32 or 50 or 37, doesn't matter. And the position of your x is at 46 or something. There's another function called potato whatever, and it's located in memory after main when it's compiled at runtime. And this position of the program is applied to the program because it's running, and it doesn't change even though they call it position independent code. The whole thing relies on the assumption that the position of the program will not change when it's started. So, if all that's true, the var x offset, if it's at 46 in memory, or an offset from the position of the program, does that mean, since like return the code between these things, whatever, is going to affect the offset because they take up space? When the potato is like linked to the program or set up, whatever you want to call it, it's after main. Is var x, var y inside of potato, even though it has no relation to main? Is its offset after main? Or does it like restart and maybe it's like at 35 then 39, it doesn't matter. So like is there like a segment to each function and they keep track of that behind the scenes, the CPU, whatever, or the Windows? Or is it all to one flat area? Because that means there's a finite amount of space, if it's true that they're all fixed to like whatever the position is at startup, even though they call it position independent. But if this is true, it means that there's a 4 gigabit byte hard limit on the code itself, if it's true. And that's what I'm trying to figure out. Unless behind the scenes they keep track of different segments, and then it wouldn't be limited. But this matters because since a program doesn't change its position because it's not truly position independent, the JavaScript engine has strings and data structures. Like I have like a string collection of all the strings in the program. Literally every program needs to make its own version, basically, of an operating system to make up for the lack that the operating system doesn't do, because a modern OS isn't really a functional operating system. So I have like, let's say a string collection offset, and then like a file system directory stuff, where in like the string collection, let's say like old strings. Like if this is a string collection, this is like file system directory stuff. Like if I have like a collection of open files or whatever, if I define these things in the data segment or whatever, then they'll take up my space here or whatever. And if it's fixed to like a 4 gig limit, then I'll have to make these pointers to memory that's allocated at runtime, which would be after the 4 gigs. So if you have like 32 gigs of RAM, and threads, they have their own segment. So this memory is segmented to some extent. And I gotta figure out how it's segmented. So like I don't want this stuff to use up 4 gigs if it's limited. Because this should only be used, the 4 gigs, for code then. And that's why it matters, because the code needs to like be able to run off whatever position independent means when it's not actually position independent. So we'll be able to know that it's at a fixed offset, these labels. So every function will be able to access the string collection, the file system offset, without having to know about the existence of other parts of the program. Because any part of the program I'm going to keep track of in a collection, and it's not going to be like simple. It'll be like a bunch of layers. It's not gonna, I'm making it sound very simple, but it's way more complicated than just a lookup. But there is a base somewhere, and things have to be stored from the base. So I have to figure out, because my make functions at runtime when the JavaScript engine is running, do these offsets relate to the base? Is it limited within 2 gigabytes? And if they do, can I get a segment or use a segment to use for my own stuff, like stuff that's not part of the main program, or if I have to like flatten it to make sure everything fits within here? Because if I make dynamic memory, like if I make a function called what I use, chip. So like the JavaScript engine, as it's running, after I meet this standard, the JavaScript standard 2024, 800 pages, my engine's gonna be way faster because mine is gonna run basically at sea level. I'm gonna make binary blobs. I have to figure out how to do it though. So instead of virtualizing, I'm gonna use memory as a C program, whatever. But runtime compilation is kind of complicated. I gotta figure out how it works. 64-bit. So like if the engine's running, since I'm not virtualized, I'm gonna use actual memory. So if I like use memory that's allocated as it's running, that memory is probably most likely gonna be after this 4 gigs. So like when I call malloc or kloc or whatever, it's probably not gonna be from the base, it's gonna be after the base, because it's probably gonna be an absolute address. And if it's an absolute address, that affects labels, I think. Because the labels are relative to the relative address. And then the relative address, it changes because there's FS in the GS registers as in the NASM docs, whatever. Somewhere in the docs, it's not worth finding. They say that whatever can be overridden is default whatever. It seems like you could do GS from the way it was worded. It looks like you can type in here relative, absolute, or a segment override of fs or gs. So that means the threads probably use a different segment in memory. And I think fs, one of them's for the file system. But it depends on Apple and Windows what they choose to use those two for. Because behind the scenes, there's still the code segment, stack segment, I think there's 6 of them. That's CD, stack, extra segment. I don't know, there's another one. So like, there is segmented memory behind the scenes. But are they limited to the 4 gigabytes? Or can some of them go off the 4 gigs into like other areas and then do some of them overlap? Like do the threads overlap possibly in a range between the main or like the base segment, whatever the position of the program is? And will I be able to like use one of these segments as an override to run my code so I get my own little area? Because I need to know the base of the program so that when I run my code or whatever, it'll be able to access the base, get a descriptor of everything, like register things to the base memory, and then the base memory, whatever, is then have to hold a registry of the things that are registered. And it's like a whole system, whatever. So I have to like set up a little system apart from Windows system, because you can't do, otherwise it would have to recompile the entire thing every time, and that would take longer to compile, and it wouldn't be possible to relocate things because it's not actually position independent. If it was position independent, then it might be possible to like recompile the whole thing as it's running, so like things could be like added after the things before it. But it's not like that. So there's like a whole bunch of shit I gotta figure out to just link everything together. And then when it comes to like compiling at runtime, I need everything to be its own separate little compilation, unless they're like grouped. Like if a function holds a function inside of a function, those would all need to be like the same chunk of a function. But like any functions that are apart, separate, like not in the same scope, those would have to be separated. Because when it compiles, it's faster to compile separate pieces rather than a huge chunk. And the C compiler is going to be a little bit slower than the J compiler, unless you turn up the settings to make it quicker, but then it's not as optimized code. Like when I go through the standard, some things will be faster in my engine, some things won't, but that depends entirely on the compiler that's used as it's running. But there's also settings of things that could be tweaked. I don't know. I have like the idea of everything, but everything else is like circumstantial. It's really annoying. So like I have all these fucking things to figure out. I kind of had an idea, and I was expecting position independent code, and now that it's not, it screws up my whole idea, and it makes it more complicated, because now that everything is position dependent, it just changes every fucking thing. I had a nice little fancy idea, but now that they shouldn't name things something that it's fucking not when they know it's not. You can't say programs are position independent when it's assumed that when the program starts, it won't change. That's not position independent. That's position dependent code. It just means you have to compile it and run it. There's no difference at all. So, when I make memory allocations, if they're outside of this base, 4 gigabyte base, the range, if it's stuck to one segment, which it can't possibly be, it has to be split up. If it is, that would suck. But if it is stuck to like a separate segment, and I were to call, like if I, at compile time, I compile code to JavaScript that meets this stupid standard. So it is like literal JavaScript, but in C, not in virtualized shit land. If these functions are malloc memory, and if malloc memory is outside of the 4 gig range of this relative offsetting, all of these functions will need to use only ever absolute addressing, which means that any of these things that are relative would technically be relative, but only ever to the base, which means I can't change what's originally defined or add to it or modify it. So I need to have a system, a structure, a data tree to account for all that. Like my own little fucking setup that Windows basically does, because Windows doesn't do jack shit. They just compile a C program, have shit ass file system calls, and they're like, good luck. And then like the program can crash at any time, and Windows will be like, oh, it's a memory fault. It'll give a blue screen, and they'll make it look like it was a program's fault, but really it might be Windows' fault, because it like said there's more memory than was available, and when the program used that memory, it crashed because Windows already gave it to another program. So I don't know. The modern operating system will be replaced. Until then, I'm gonna have to just go with the flow. So if I make separate functions, they're outside of this base, I guess relative addressing will still work. But I still have to link everything. So maybe these technically will be position independent. But like the things that are compiled at compile time for the original program, those aren't really position independent. It'd be nice if I could get my own segment, kind of like threads, but I don't think there is one, because they already use them for something else nonetheless related. So I don't know. I gotta figure that out. And it's annoying, because it's not just plainly printed out. Because if it was, it'd be clear that it's bullshit and it doesn't do what it says. So they have to like word things a certain way or lie about it straight up so they don't get sued. But then when people find out that they pay for a certain number of cores, a certain amount of memory, and a chip doesn't do it, they can sue them because illegally they lied about what they sold. So, I don't know. Everything's a bunch of bullshit. I'm gonna have to figure out still whatever the best way to throw shit, make it stick. I don't know, I was trying to like, I can't make jokes. I gotta think about this crap. This is so annoying. So I don't know. That's basically what I'm thinking. I also have to like update this thing to print to this stupid window. So I get back to this now. So I gotta figure out a whole bunch of shit. It's just annoying. I don't even think I changed this file yet. So I'll get back to thinking later. And I gotta turn this stuff off. I saved a backup. I have to make it populate these as it runs. I have to template it. And I can duplicate it to print addresses. And I have to print addresses for all the reasons I just explained here. I need to like get an address, print it to like probe the memory based on its offset and stuff to see if there's a relation between functions that are created and the offsets inside of those functions, and relation between the threads and also the memory that's made using malloc or whatever. I've never even called malloc in assembly because I'm 32-bit. I would just make like 3.5 gigs and then the assembler would link to that. I would use that, and then any like memory that's like page whatever, I don't know, I do call that in Windows and pass it in, so like I never had to like call malloc from assembly. But I'm gonna have to be able to figure out like when I do that, when I get back an address, is it suspectly like, is suspectly or suspiciously, I don't know. I have to like figure out if it's suspectly always around 4 gigabytes away from whatever the position of program base is, or does it possibly overlap? If it overlaps, doesn't suck. It'd be nice if I could like, there's a lot of things that'd be nice that aren't possible. I don't know, I'm limited to the modern OS. It's total shit. The whole thing needs to be rewritten. I can't believe we still use text editors in 2025. It's fucking ridiculous. This stuff is literally 1970s ancient technology. It's a fucking joke. So that's why I need to print the addresses. And I also need to print the addresses. Well, I want to figure out the address thing first. I don't need to get all of it. I just need to have it set up so I can like check things later. Like as I'm parsing, if I get bored, I can like probe the addresses, figure out what goes where. And I need that also because I'm going to need to like print the time it takes to complete. So I need to make like a couple of variations of like a list of numbers. So I need this to be templated. So that's what I'll do first. I don't know. I'll BRB. And then I'm gonna like get to templating this. I gotta turn off this. And then I can like duplicate the module I use for this to make other modules after it. And I'll be able to like, output data, speed test stuff, probe the memory addresses, and all that stuff, whatever. So I don't know. I think I thought I had enough. And to like get stuff set up and stop thinking ahead. Because I already had ideas that I was gonna do, but nothing's actually position independent. So I gotta like change what I thought I had done. It takes so much work to get everything set up to where you're thinking ahead at. I need a time machine or a monkey. I need to train a monkey to code. One of those two. So I don't know. LRB. And I gotta like clean up this code or something first, template it, print the addresses. I at least want to change default abs salute to, from default relative. I want to change it from relative to absolute. That's like the main thing. Because I want to like, even if I don't figure out all this addressing right now, I at least need to have like a general understanding of when it is a relative offset, if it's actually a 32-bit number or not, or I don't know, whatever. That's the first thing, and I'm gonna get the speed test, whatever, because I'm accessing memory and stuff. So I want to make sure like I have it figured out. So when I like type in here, whatever, this is an absolute address. If it wasn't, I do like rel whatever. So like I rather manually type it in than like use default. Because if I can, if it's possible to change this to FS or GS, but I don't think I can because OS is using it for threads and stuff. But if it's possible, that would affect the addresses or whatever. So I want to use like absolute, so I have like slightly more control, figure out what goes where. Because if I leave it on relative and I just like run off assumption, I'm gonna get fucked. I'm gonna have code to rewrite. I'm already like rewriting a bunch of code so I can just meet the 2002 standard first and then do the 2024 standard. So I want to like avoid writing any code and just write stuff correct the first time because I hate backtracking. Because right now I gotta backtrack anyways to make this thing templated when I should have made it templated in the first place. But instead I got lazy and I tried to copy paste it and duplicate it. Doesn't take too much work. So I gotta like just freaking template this stuff now so I can get the rest of the stuff in place to get further with her. Whatever. I don't know. I'll be
Environment record is a declarative environment record that is used to represent the outer scope of an ECMAScript module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms: 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert s is true, assert envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created. B let target envbm. C if target env is empty, throw a reference error exception. D return target env get binding value, n2, true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note s will always be true because a module is always strict mode. Code 9. 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method. Purpose. Create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding. Return the value of this environment records this binding. ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13, 5, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called: return true, 1, 5, 4 get this binding. The get this binding concret method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called: return undefined, 1, 5, create import binding, n, m, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. n2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called: assert envrec does not already have a binding for n. Assert when m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2. 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called: if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding. Name if exists is true, then a return the reference record, env, name, strict, empty. Else, 150. ECMA International 2024. Note: module environment records always provide this binding. AB let outer be env return. Get identifier reference, outer, name, strict 9, 1, 2, to new declarative environment. E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O. W. E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment. F. New target. The abstract operation new function environment takes arguments F, an ECMAScript F, function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical, else set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment. G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrec be new object environment. G. False. Null. Let DCLrec be new declarative environment. Null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to DCLrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env, ECMA International 2024 151, 9.2 private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMAScript code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9, 2, 1 private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9, 2, 1, 1 new private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1, to resolve private identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name Pn of names, do if Pn is identifier. Then I return Pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env. Identifier. 3 realms. Before it is evaluated, all ECMAScript code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMAScript global environment, all of the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024. Table 24. Realm record fields. Field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal, parse node, and v, an array, F, the agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2. As mentioned in host load imported module 16.2.1. 8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module, field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to int find. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.3. To create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property, length is the initial value of the function's length property, slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec. B set global obj to ordinary object create intrinsics. Assert global obj is an object. If this value is undefined, set this value to global obj. Set realm rec to global obj. Let new global env be new global environment. Global obj. This value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec. For each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4 the value of the attribute is the corresponding intrinsic object from realm rec. See perform. define prop, RTY or throw, global, name, desk, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMAScript features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMAScript code execution contexts have the additional state components listed in Table 26. Table 2. 6. Additional state components for ECMAScript code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records.
There's like a bunch of stuff with like a 6-word assembly that like it's not even implemented in the assemblers. Like multi-byte nop or whatever.
NASM macro syntax consistency. Compiler Explorer. 1. And nop is the same as nop and how do I do a multi-byte nop. The CPU has a multi-byte nop instruction that I would like to use instead of a line of single nops.
I know some people that are nops.
Perfect. Let's clear this up.
Calling someone a nop. A nop. I don't know. It's like not as offensive as a ding dong. Or like other words. Because they're like non-operative. So they're NOP.
In NASM, the instruction mnemonics are case insensitive. So,
That would make me just as bad as some people. Just keep it to myself.
knob, knob, knob.
I'm not gonna run around going, NOP, NOP, NOP. Like a little gossip king.
Are all exactly the same. They assemble to the same opcode. 2. Multibyte NOP in x86/x86-60 for the CPU. Intel and AMD does have multi-byte NOP instructions designed for alignment and padding that are more efficient than multiple single-byte NOPs.
In this case insensitive part, I didn't know that to this extent. That like case insensitive meant even the middle letter is case insensitive. Because sometimes I define things, I'm like, what the hell? It's not working. What's wrong with this name? And it must be because it's case insensitive. That's really annoying. This is the monomic, however you say it. Monomics, that they're case insensitive. I don't think the VARs are. But like if you name something that happens to be the same as whatever.
Two. Multibyte NOP in x86/x86-60 for the CPU. Intel and AMD does have multi-byte NOP instructions designed for alignment and padding that are more efficient than multiple single-byte NOPs. What is a multi-byte NOP? The single-byte NOP opcode is 0 times 90. For longer NOPs, 2 to 9 byte, Intel defines specific multi-byte NOP instructions using XCHG or LER with 0 effect. These are called multi-byte NOPs and are officially recommended for padding instead of multiple single-byte NOPs.
That's such a waste of an instruction.
How to emit a multi-byte NOP in NASM? You can emit them as byte sequences or use the assembler-friendly macros provided by Intel or others.
They should have had like added an instruction instead to like do a move operation from a 32-bit to a 64-bit register without destroying the contents. But no, I guess they wasted some instruction encoding on NOPs. Well, this is stupid. I was reading the Intel docs and they said use multi-byte NOPs. I'm like, oh, that's a thing. I guess it's not technically a thing. It's just a made-up thing by Intel. That's why I don't like reading Intel docs. So what are these instructions? And then this here, an 8-byte NOP. It looks like chatbot's recommending this is the original NOP. This is a 2-byte NOP. But this is an actual instruction that's like add 0 or XOR something with itself. And like to get like 7 bytes of NOP, to use like a 3-byte instruction with a bunch of zeros. So maybe this is like an add 0, and then that way when it runs this NOP it's able to continue. Well, it can't, because 0 isn't a NOP. I need to soundtrack. I have to make macros for half this stuff. I don't remember the macros in ASM. It's really confusing and difficult to read. I think I can make a define called %1, but then it's like defined within the macro. Unless I can undefine it after the macro, then I gotta test if it's defined in the macro in case I have to use the same name for another macro. So that's annoying, but it's still better than C programming because the C preprocessor, that thing sucks ass. This preprocessor is like way better. I need to drink some water. My mouth is so dry. I wish I could like multitask and drink water. But instead it's like I just gulp down water and then just fucking dry out. And I like can't drink the water while I'm doing something. I need to get back on track. I'm gonna ask chatbot whatever these stupid instructions are.
For the 1 to 9 multibyte instructions, list what the inst is and what does 0 decoders instruction-wise. Sure. Here's a clear rundown of the 1 to 9 byte multibyte NOP instructions Intel uses, what each instruction actually is, plus what the trailing 0 bytes mean in those sequences. Single byte NOP. Operand size prefix plus NOP. NOP using 3 byte NOP opcode with ECMAScript. Same as above, with 1 byte displacement 0. Subbyte and 1 byte displacement. Operand size override plus above.
There's a EAX register encoding where every register that uses, or every place that EAX is used, it can use 1 less byte per instruction. Did they waste? Is that the reason that they made that optimization for this? To make multi-byte NOPs?
The not word PTR, x plus 0, what does it assign to as the DST, and do any of those use the RAX mode encoding that uses one less byte per instruction? Great questions. Let me clarify both parts precisely. 1. What does not word PTR, x plus 0, do? Semantically, it does not perform any write or meaningful effect. What is the DST register, where you say no destination register or memory is actually modified, but what does it map to instruction set wise? What's the DST, and the SRC is as you stated? Great question. Let's dig into exactly how that instruction encodes operands and why it has no architecturally visible effect. List the encoding for other things that start with the byte 0f. ChatGPT said, sure. The byte 0f in x86/x86-64 instruction encoding is a mandatory 2-byte opcode prefix that extends the opcode space. In other words, instructions starting with 0f are often called 2-byte opcodes. So when the second byte is 1f, what does that specify as the DST reg specified in the bits, or is that in a following right? Great question. Let's break down what happens when the second opcode byte is 1f after the 0f prefix, and how operands are specified.
Testing. It is, I don't know. So it's set to, there is a destination. Pretty sure EAX is technically the destination. I would have to like find the encoding chart. I need to like get back on track. I wish chatbot would just answer what you're asking. But instead it just gives you a bunch of shit.
The RM equals 000, EX register as base. What would the encoding be to select the EBX register as base instead? And would it be an opstil or a valid inst? Awesome question. Let's analyze exactly what happens if you change the RM field from 000 EX to 011 EBX in the mod-rm byte of the 0f1f0 multi-byte NOP. For the multi-byte NOP, reg equals 000, opcode extension 0, mod and rm specify the memory addressing mode. Original example. 40 equals 01000000b, mod equals 01, memory with 8-bit displacement, reg equals 000, NOP opcode extension, rm equals 000, EX base, displacement 00, 8-bit displacement 0, instruction NOP word PTR, EX plus 0. What if RM equals 011, EBX, new mod rm byte, mod equals 01, memory with 8-bit displacement, reg equals 000, NOP opcode extension, RM equals 011, EBX, binary, 01, 000, 011, equals 0100, 0011, equals 43 hex, so bytes would be. What does this instruction mean? It's the same multi-byte NOP opcode, 0f1f0, but now the memory operand is EBX plus 0. NOP word PTR, EBX plus 0. Is it still a valid NOP? Yes. This is still a valid multi-byte NOP instruction. The multi-byte NOP family, 0f1f0, allows any memory addressing mode, as specified by the mod-rm byte, with 0 in the reg field, so changing the base register from EX to EBX does not change the instruction's semantics. It remains a multi-byte NOP. What instruction is that close to what bits would need to be changed to keep the same instruction length but have it actually carry out an operation? You've reached our limit of messages per hour. Please try again later.
It's weird that there's like no destination or whatever, or that it's defined but doesn't use one. So it's like close to like a real instruction. I wonder if you like change a couple bits, if it makes it a valid instruction. Because then it'd be possible to like hide instructions within other instructions and modify them at runtime to protect code or to hide code. It seems like a vulnerability. What do I know?
If the internal slot of this function is false, the length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5. Make constructor f. Writable prototype, prototype. The abstract operation make constructor takes argument f, an ECMAScript function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMAScript function object, then a assert is constructor, f is false. B assert f is an extensible object that does not have a prototype own property. C set f to the definition specified in 10, 2, 2. Else a set f to the definition specified in 10, 3, 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create. %object prototype %. B perform. Define property or throw prototype constructor property descriptor f. Writable prototype false true perform. Define property or throw f. Prototype property descriptor prototype, writable prototype, false, false, return unused. 80. ECMA International 2024. 102. 6. Make class constructor, f. The abstract operation make class constructor takes argument f, an ECMAScript function object, and returns unused. It performs the following steps when called. Assert f is false, set f to true, return unused. 0, 2, 7. Make method, f. Home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object, return unused. 0, 2, 8. Define method property, home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert home object is an ordinary, extensible object. If key is a private name, then a return private element. Method, closure 3. Else, a let desk be the property descriptor, closure, true, enumerable, true. B perform. Define property or throw, home obj, act, key, desk. C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9. Set function name, f. Name, prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description, and else if name is a private name. Then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then optionally set f to name. Perform. Define property or throw f name property descriptor name false enumerable false true return unused. ECMA International 2024 181. The 10th of February 2010. Set function length f length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f length property descriptor length false enumerable false true return unused. 0 2 1 1 capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I func arguments list. The abstract operation capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I. All other bindings are initialized. During evaluation of the function body, it performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be as simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor of the binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, The last declaration is used. Insert D is the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note. Arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then a function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note. Only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else a note. A separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be
The modern OS or whatever. It's so modern that it can't even like separate code for security's sake. It's ridiculous. So I have to like try to account for that and move things around at runtime and keep like a little list of the address ranges in use. And I can't like do every single check all the time, but every now and then make a counter like check certain things to test if there's like address injection or whatever. Nothing is modern about the modern OS. Nothing at all.
list. B else. I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter. Any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true, then I perform env create immutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. D else, I perform env create mutable binding, arguments, false. E perform env initialize binding, arguments. O, F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, A let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then a perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else a perform iterator binding initialization of formals with arguments iterator record and env 27. If his parameter expressions is false, then a note. Only a single environment record is needed for the parameters and top-level vars. B let instantiated var names be a copy of the list parameter bindings. C for each element n of var names. Do I have instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding, n. False. Perform env initialize binding, n. Undefined. D let var env be env 28. Else, a note. A separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative environment. env. C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names. Do I have instantiated var names does not contain n, then ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding, n. False. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined 4. Else, a let initial value be env get binding value, n. False. Perform var env initialize binding, n. Initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb, 3, 2, 1 adds additional steps at this point. 0. If strict is false, then a let lexi env be new declarative environment. Var env be note. Non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else a let lexi-env be var-env. 2. Set the lexical environment of callee context to lexi-env. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element D of lex declarations, do a note. A lexically declared name cannot be the same as a function-generated declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D, do I if this constant declaration of D is true, then perform lexi-env create immutable binding. Dn, true 2. Else perform lexi-env create mutable binding. Dn, false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexi-env and private env. C perform var-env set mutable binding. Fn, fo, false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1, 0, 3, 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1, 0, 3, 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 103.1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps where n called return, built-in call or construct, f, this arguments list, undefined 1, 0, 3, 2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f, uninitialized, arguments list, new target 1, 0, 3, 3 built-in call or construct, f, this arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object, this argument, an ECMAScript language value, or uninitialized, arguments list, a list of ECMAScript language values, a new target, a constructor undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized, that this value is uninitialized. Otherwise, This argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note, when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended, and retain it by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set fun to prototype, set fun to true, set fun to realm, set fun to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in table 30. Instead, they have the internal slots listed in table 31, in addition to and table 31, internal slots of bound function exotic objects. Internal slot type description bound target function a callable object the wrapped function object bound this an ECMAScript language value the value that is always passed as the this value when calling the wrapped function bound arguments a list of ECMAScript language values a list of values w whose elements are used as the first arguments to any call to the wrapped function. 186 ECMA International 2024 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f. Let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target. Return. Construct. Target. Args. New target. 0, 4, 1. 3 bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMAScript language value. And bound args. A list of ECMAScript language values. And returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1 0 4 1 1. If this constructor target function is true, then a set obj as described in 1 0 4 1 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0 4 to array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6 1 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index. Whenever a known property of an array is created or hanged, other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own ECMA International 2024 187 properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desc. Else if p is an array index, then a let length desc be ordinary get own property a length b assert is data descriptor length desc is true c assert length desc is false d let length be length desc e assert length is a non-negative integral number f let index be 32 p g if index length and length desc is false return false h let succeeded b ordinary define known property a p desc I have succeeded is false return false j if index length then I set length desc index plus 1 2 set succeeded to ordinary define known property a length desc 3 assert succeeded is true k return true return ordinary define known property a p desc 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform ordinary define known property a length property descriptor length true false false return a 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negate, I've integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array, original array. If is array is false, return array create, length. Let C be get, original array, constructor. If is constructor, C, is true, then 88. ECMA International 2024. Let this realm be the current realm record. B let realm be. Get function realm, C. See if this realm and realm are not the same realm record. Then, I have same value, C, realm is true. Set C to undefined. If C is an object, then I set C to get C. Add at species. B if C is null, set C to undefined. If C is undefined, return array create, length. If is constructor, C, is false, throw a type error exception. Return construct, C, length 0, 4, 2, 4 array set length, A, desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define known property, A, length, desk. Let new len desk be a copy of desk. Let new len be to 32, desk. Let number len be to number, desk. If same value 0, new len, number len, is false, throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property, A, length. Assert is data descriptor, old len desk is true. Assert old len desk is false, 0. Let old len be old len desk, 1. If new len old len, then a return ordinary define known property, A, length, new len desk, 2. If old len desk is false, return false, 3. If new len desk does not have a field or new len desk is true, then a let new writable be true, 4. Else, a note, setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true, 5. Let succeeded be ordinary define known property, A, length, new len desk, 6. If succeeded is false, return false, 7. For each own property key P of a such that P is an array index and 32, P, new len, in descending numeric index order, do a let delete succeeded B, A, P, B if delete succeeded is false, then I set new len desk to 32, P plus 1, 2. If new writable is false, set new len desk to false, 3. Perform ordinary define known property, A, length, new len desk, I've return false, 8. If new writable is false, then assert succeeded to ordinary define known property, A, length, proper tie descriptor, false. B assert succeeded is true, 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1, 0, 4, 3, 1, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, S, P. If desk is not undefined, return desk. Return string get own property, S, P, 0, 4, 3, 2, P, desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property, S, P. If string desk is not undefined, then a let extensible be S. B return is compatible property descriptor, extensible, desk, string desk, return. Ordinary define own property, S, P, desk, 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str for each integer I such that 0 len, in ascending order. Do a append to string I, commenter keys, for each own property key P of O such that P is an array index and to an integer or infinity, P, len, in ascending numeric index order. Do a append P to keys, for each own property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024. 8. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do a append P to keys. 9. Return keys 0, 4, 3, 4 string create, value, prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5 string get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be S, assert. Str is a string. Let len be the length of str. If r, int x, 0, or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r, index plus 1, 1. Return the property descriptor, result str, false, true, false, 0, 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 2, 0, 1, 3, 6 to identify them as such. Note 1: while creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2: the integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings, and the Function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument's object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note: for ordinary arguments, objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note 5. ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor 0441p. The internal method of an argument's exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property args p. If desc is undefined, return undefined. Let map be args let is mapped be has own property map p. If is mapped is true, then a set desc to get map p6 return desc 0442 p d esc. The internal method of an argument's exotic object args takes arguments p, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args let is mapped be has own property map p. Let new arg desc be desc. If is mapped is true and is data descriptor desc is true, then if desc does not have a field, desc has a field, and desc is false, then I set new arg desc to a copy of desc 2. Set new arg desc to get map p. Let allowed be ordinary define own property args p. New arg desc 92 ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor desc is true, then I perform map p. Be else if desc has a field, then assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map p desc false 2. If desc has a field and desc is false, then perform map p8 return true 0443. The let map be args let is mapped be has own property map p. If is mapped is false, then a return ordinary get args p receiver 4 else a assert map contains a formal parameter mapping for p. B return get map p 0444. The if same value args receiver is false, then a let is mapped be false, else a let map be args b let is mapped be has own property map p. If is mapped is true, then a assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, b perform set map p v false return ordinary set args p v receiver 0445 p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args let is mapped be has own property map p. Let result be ordinary delete args p. If result is true and is mapped is true, then a perform map p5 return result. ECMA International 2024 193 1044 6. Create and mapped arguments object Arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create, %object prototype %set obj to undefined. Perform. Define property or throw, obj, length, property descriptor, len, true, enumerable, false, true, let index be 0. Repeat. While int x, len, a let val be arguments list. Index b perform. Create data property or throw, obj. To string, int x, val, c set index to index plus 1. Perform. Define property or throw, obj, at iterator, property descriptor, %array prototype values true, false, true. Perform. Define property or throw, obj, callee, property descriptor, %throw type error false, false. Return obj 0, 4, 4, 7. Create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0, 4, 4, 1. Set obj is specified in 1 0, 4, 4, 2. Set obj is specified in 1 0, 4, 4, 5. Set obj to %object prototype %0. Let map be ordinary object create, null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat. While int x, len, a let val be arguments list. Index b perform. Create data property or throw, obj. To string, int x, val, c set index to index plus 1, 6. Perform. Define property or throw, obj, length, property descriptor, len, true, false, true 7. Let map names be a new empty list 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names 2. If int x, len, then let g be make arg getter, name, env. Let p be make arg setter, name, env. Perform map. To string, int x, property descriptor get, g, false, true. Set index to index 1, 20. Perform. Define property or throw, obj, at iterator, property descriptor, %array prototype values true, false, true 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true 2. Return obj 0, 4, 4, 7, 1. Make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note, getter is never directly accessible to ECMAScript code. Return getter, 0, 4, 4, 7, to make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, Setter closure. 1. Note. Setter is never directly accessible to ECMAScript code. Return setter. 0. 4. 5. Typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally, length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then I let value be typed array get element numeric index 2. If value is undefined, return undefined 3. Return the property descriptor value true true true. Return ordinary get own property O. P. ECMA International 2024 195 1045 P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Return as valid integer index O. Numeric index return. Ordinary has property O. P 0, 4, 5, 3. P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then if as valid integer index O. Numeric index is false, return false 2. If desk has a field and desk is false, return false 3. If desk has an field and desk is false, return false 5. If as accessor descriptor desk is true, return false v. If desk has a field and desk is false, return false v. If desk has a field, perform typed array set element numeric index desk 7. Return true return ordinary define own property O. P. Desk 0, 4, 5, 4. The if P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then I return typed array get element numeric index 2. Return ordinary get O. P. Receiver 0, 4, 5, 5. The if P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then if same value O. Receiver is true, then perform typed array set element numeric index v. Return true 2. If as valid integer index O. Numeric index is false, return true return ordinary set O. P. V. Receiver 96 ECMA International 2024 1045 P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then if as valid integer index O. Numeric index is false, return true, else return false 2. Return ordinary delete O. P 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, Sexy let keys be a new empty list. If is typed array out of bounds, tar record is false. Then a let length be typed array length, tar record be for each integer I such that 0 I length in ascending order. Do I append to string I to keys for each own property key p of O such that p is a string and p is not an integer index. In ascending chronological order of property creation, do I append p to keys for each own property key p of O such that p is a symbol. In ascending chronological order of property creation, do I append p to keys 6. Return keys 0, 4, 5, 8 typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, OBJ, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexy or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj if is detached buffer is true. Then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. Obj, byte length, 0, 4, 5, 1 0 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be dart. Let A be make basic object. Internal slots list. Set A is specified in 1 0, 4, 5, 1. Set A is specified in 1 0, 4, 5, 2. Set A is specified in 1 0, 4, 5, 3. Set A is specified in 1 0, 4, 5, 6. Set A is specified in 1 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1 1 typed array byte length. Tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If is typed array out of bounds, tar record is true. Return 0. Let length be typed array length. Tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1 2 typed array length. Tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds. Tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert byte length is not detached. Return floor. Byte length. Byte offset. Element size 0, 4, 5, 1 3 is typed array out of bounds. Tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O if O is auto. Then, a let byte offset end be buffer byte length, else, a let element size be typed array element size. O, be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note, 0 length typed arrays are not considered out of bounds. 0, return false. 0, 4, 5, 1 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments O, a typed array, and an x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer O is true, return false. If is integral number int x is false, return false. If index is -0, return false. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O unordered. Note, bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true, return false. Let length be typed array length, tar record. If r int x 0 or r int x length, return false. Return true. 0, 4, 5, 1 5 typed array get element O index. The abstract operation typed array get element takes arguments So, a typed array, and int x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index O int x is false, return undefined. Let offset be O. Let element size be typed array element size O. Let byte index in buffer be R int x element size plus offset. Let element type be typed array element type O. Return get value from buffer O. Byte index in buffer element type true unordered. 0, 4, 5, 1 6 typed array set element O int x value. The abstract operation typed array set element takes arguments So, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be to big int value. Otherwise, let num value be to number value. If is valid integer index O int x is true, then a let offset be O. Be let element size be typed array element size O. C let byte index in buffer be R int x element size plus offset. D let element type be typed array element type O. E perform set value in buffer O. Byte index in buffer element type num value true unordered. Return unused. ECMA International 2024 199 104 5 17 is array buffer view out of bounds O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R O sexiest T B return is view out of bounds view record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexiest T. Return is typed array out of bounds. tar record 0 4 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module. C16 2 3. There is a one-to-one correspondence between the string key DOM properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare FN 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00. ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V. 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal C, completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor value true, true, false. 0 4 6 6. P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define own property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is accessor descriptor desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value desk current. Return true. 0 4 6 7. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true. Return false. ECMA International 2024 201 1 0 4 6 8. The. If P is a symbol, then a return ordinary get O. P. receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M. Resolve export. P. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace. Target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception 2. Return target env get binding value. Binding true 0, 4, 6, 9. The I'm steps when called. Return false 1, 0, 4, 6, 1, 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return. Ordinary delete. O. P. Let exports be O. If exports contains P, return false. Return true 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pairs arguments it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 104612 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert. Module is empty. Let internal slots list be the internal slots listed in table 33. Let M be make basic object. Internal slots list. Set M's essential internal methods to the definitions specified in 104. 6. Set M to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare FN. Set M to sorted exports. Create own properties of M corresponding to the definitions in 28.3. Set module to M 0. Return M 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return. Set immutable prototype O. V10, 4, 7, 2 set immutable prototype O. V. The abstract operation set immutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O. If same value, V, current, is true, return true. Return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of as an object, called the proxy's handler object, or null. Methods. See table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34. Proxy handler methods. Internal method. Handler method. Get prototype of. Get prototype of. Set prototype of. Set prototype of. Is extensible. Is extensible. Prevent extensions. Prevent extensions. Get own property. Get own property descriptor. Define own property. Define property. Has property. Has get. Get. Set. Set. Delete. Delete property. Own property keys. Own keys. Call. Apply. Construct. Construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariance defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object, P is a property key value, V is any ECMAScript language value, and desc is a property descriptor record. O for copyright sign, ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible. Target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception. 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of. If trap is undefined, then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible. Target 0. If extensible target is true, return true 1. Let target proto be target 2. If same value, V, target proto, is false, throw a type error exception. 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return. The same value is applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Is extensible. If trap is undefined, then a return. Is extensible. Target. Let boolean trap result be to boolean. Call. Trap. Handler. target. Let target result be is extensible. Target. If Boolean trap result is not target result, throw a type error exception 0. Return Boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. If Boolean trap result is true, then a let extensible target be is extensible. Target. B. If extensible target is true, throw a type error exception. Return Boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a Boolean value. Applied to the proxy object must return the same value as. Applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a Boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy O. Let target be O, 06, ECMA International 2024. 3. Let handler be O, assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then if target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target. D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be is extensible. Target. 2. Let result desk be to property descriptor, trap result obj. 3. Perform complete property descriptor, result desk. 4. Let valid be as compatible property descriptor, extensible target, result desk, target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p, desk. The internal method of a proxy exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desk. Let desk obj be from property descriptor. Desk. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. Desk obj. If Boolean trap result is false, return false. 0. Let target desk be target. P. ECMA International 2024 207. 11. Let extensible target be is extensible. Target. 2. If desk has a field and desk durable is false, then a let setting config false be true. 13. else a let setting config false be false. 4. If target desk is undefined, then A if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else A if is compatible property descriptor, extensible target, target desk, is false. Throw a type error exception. B if setting config false is true and target desk is true, throw a type error exception. C if is data descriptor, target desk, is true, target desk is false, and target desk is true. Then, if desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined. Then a return target. P. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. If Boolean trap result is false, then a let target desk be target. P. B if target desk is not undefined, then I if target desk is false. Throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. Return Boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariants. The result of is a Boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The S either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor, target desk, is true and target desk is false, then I if same value, trap result, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true and target desk. 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its. 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. V. Receiver. If Boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024 209. If is data descriptor, target desk, is true and target desk is false, then I if same value, V, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true, then I if target desk 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value O f a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its. 0, 5, 10 p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key be. If desk is not undefined and desk is false, then I append key to target non-configurable keys. See else I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a L as to whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments. This argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let arg-array be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. Arg-array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let argArray be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. argArray. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0. 5. 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0. 5. 1 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P, 12, ECMA International 2024. Note 1 a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write N instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0CP0 times 10FF. If CP0XFF, return the string value consisting of the code unit whose numeric value is CP. Let CP1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let CP2 be the code unit whose numeric value is CP0 times 10,000. Modulo 0 times 400 plus 0 XDC00. Return the string concatenation of CP1 and CP2. ECMA International 2024 213. 1. 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result 1. 3 static semantics. UTF-16 surrogate pair to code point lead trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead a code unit and trail a code unit and returns a code point. 2 code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0 XD800. 0 times 400 plus trail 0 XDC00 plus 0 times 10,000. Return the code point CP 1. 4 static semantics. Code point at string position. The abstract operation code pointed takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-1, 6 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert position 0 and position size. Let first be the code unit at index position within string. And let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then I return the record CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then I return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then I return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2 false 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string. Position be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: property definition list, property definition list, property definition, perform. Property definition evaluation of property definition list with argument object, perform. Property definition evaluation of property definition with argument object, return unused. ECMA International 2024 251. Property definition. Assignment expression, let x per value b. Evaluation of assignment expression, let from value b. Get value, x per value, let excluded names be a new empty list. Perform. Copy data properties, object, from value, excluded names, return unused. Property definition, identifier reference, let prop name be string value of identifier reference, let x per value be. Evaluation of identifier reference, let prop value be. Get value, x per value, assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw, object, prop name, prop value, return unused. Property definition, property name, assignment expression, let prop key be. Evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse. Then, a let is proto set to be false, else if prop key is proto and is computed property key of property name is false. Then a let is proto set to be true, else a let is proto set to be false. If is anonymous function definition, assignment expression, is true and is proto setter is false, then a let prop value be. Named evaluation of assignment expression with argument prop key, else a let x per value ref b. Evaluation of assignment expression be let prop value b. Get value, x per value ref. If this proto setter is true, then if prop value is an object or prop value is null, then I perform object, prop value be return unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw, object, prop key, prop value 0. Return unused. Property definition, method definition. Perform. Method definition evaluation of method definition with arguments object and true. Return unused. 3, 2, 6 function defining expressions. See 15.2 for primary expression. Function expression. See 15.5 for primary expression. Generator expression. See 15.7 for primary expression. Class expression. See 15.8 for primary expression. Async function expression. See 15.6 for primary expression. Async generator expression. 52. Copyright sign. ECMA International 2024. 132. 7 regular expression literals syntax. C12. 9. 5. 3. 2. 7. 1 static semantics. Early errors. Primary expression. Regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2 static semantics, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U L A R capital E X P R E S S I O N capital L I T E R A takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal if flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal if U is false and V is false. Then, a let string value be code points to string, pattern text, B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern, pattern text, U, V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of regular expression literal. Return. regexp create, pattern, flags. 3, 2, 8 template literals syntax. Template literal, yield, await, tagged. No substitution template. Substitution template yield await tagged. Substitution template yield, await, tagged, template head expression, plus in yield await. Template spans yield await tagged. Template spans, yield, await, tagged, template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list, yield, await, tagged, template middle expression, plus in yield await. Template middle list yield await tagged, template middle expression, plus in yield await. 3, 2, 8, 1 static semantics, early errors. Template literal, yield, await, tagged, no substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence. Template literal, yield, await, tagged, substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument force is greater than or equal to 232. Substitution template, yield, await, tagged, template head expression, plus in yield await, template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans, yield, await, tagged, template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list, yield, await, tagged, template middle expression, plus in yield await, template middle list yield await tagged, template middle expression, plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, 2 static semantics. Template strings. The syntax-directed operation template strings takes argument draw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template, raw. Substitution template, template head expression template spans. Let head be template string, template head, raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans, template tail. Return template string, template tail, raw. Template spans, template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string, template tail, raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression 1. Return template string, template middle, raw. Template middle list, template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string, template middle, raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics. Template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token, else a let string be the TV of template token. Return string 3, 2, 8, 4 get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0 2. Repeat while index count a let prop be to string index b. Let cooked value be cook strings index c. Perform define property or throw template prop property descriptor cooked value writable false true false d. Let raw value be the string value raw strings index e. Perform define property or throw raw obj prop property descriptor raw value false true false f. Set index index plus 1 3. Perform set integrity level raw obj frozen 4. Perform define property or throw template raw property descriptor raw obj false enumerable false false 5. Perform set integrity level template frozen 6. Append the record template literal template to realm 7. Return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1 3 2 8 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 1 3 2 8 5 Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let preceding be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3 2 8 6 Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1 2 9 6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1 2 9 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3 future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics are ply to the expression value like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1 2 9 6. Template spans. Template middle list. Template tail. Let head be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1, 2, 9, 6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return the string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. 2. Runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return. Evaluation of expa parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3. The string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type-off may be applied to parenthesized expressions. ECMA International 2024 257. 13.3 Left-hand side expressions syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged super property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier super property yield await. Super expression plus in yield await. Super identifier name meter property. New target. Import meter new target. New target. Import meter. Import meta. New expression yield await. Member expression yield await. New expression yield await. Call expression yield await. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Yield await. Super call Y. Yield await. Import call yield await. Call expression yield await. Arguments yield await. Call expression yield await. Expression plus in yield await. Call expression yield await. Identifier name. Call expression yield await. Template literal yield await. Plus tagged. Call call expression yield await. Private identifier supercall yield await. Superarguments yield await. Import call yield await. Import assignment expression plus in yield await. Arguments yield await. Argument list yield await. Argument list yield await. 58. ECMA International 2024. Argument list yield await. Assignment expression plus in yield await. Dart. Assignment expression plus in yield await. Argument list yield await. Assignment expression plus in yield await. Argument list yield await. Assignment expression plus in yield await. Optional expression yield await. Member expression yield await. Optional chain yield await. Call expression yield await. Optional chain yield await. Optional expression yield await. Optional chain yield await. Optional chain yield await. Arguments yield await. Expression plus in yield await. Identifier name template literal yield await plus tagged. Private identifier optional chain yield await. Arguments yield await. Optional chain yield await. Expression plus in yield await. Optional chain yield await. Identifier name optional chain yield await. Template literal yield await plus tagged. Optional chain yield await. Private identifier left-hand side expression yield await. New expression yield await. Call expression yield await. Optional expression yield await. Supplemental syntax when processing an instance of the production. Call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. The interpretation of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R is refined using the following grammar. Call member expression yield await. Member expression yield await. Arguments yield await. 3 3 1 static semantics. 3 3 1 1 static semantics. Early errors. Optional chain template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A dot B C so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meta. It is a syntax error if the syntactic goal symbol is not module 1.3.3.2 property accessors. Note properties are accessed by name using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, car, LL expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3 3 2 1 runtime semantics. Evaluation. Member expression. Member expression. Expression. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict 60 ECMA International 2024 member expression identifier name let base reference be Evaluation of member expression. Let base value be get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict member expression private identifier let base reference be evaluation of member expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string call expression expression let base reference be evaluation of call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name let base reference be evaluation of call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier let base reference be evaluation of call expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E.
When you decrement, it's working.
Script language value
Testing.
parse node and strict a boolean and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be evaluation of expression. Let property name value return the reference record.
Testing.
Strict this value empty 3 4 capital E V A L U T
Testing.
C C E S S capital W I T H capital I D E N base value identifier name strict the abstract operation capital E
Testing, testing. Oh, now it's working. Great. I don't know what I'm missing here. Register, RBX, whatever.
The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict optional chain. Identifier name. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. New value. New reference.
Okay. So this is really annoying. I don't have time to question every single operation.
New reference.
I don't have the time to look into every single mother-loving thing. And I keep running into like stupid little shit. Like, it's not even related. Or how, I don't even know. So like, this is a loop, okay? Right here, I'm doing Lee to load the effective address. It just assigns it. It doesn't really load anything from an address. It doesn't dereference. So it's doing the size times the count, adding it to the base register. So I'm decrementing afterwards.
P R new value expression strict optional chain identifier name let optional chain be optional chain let new reference be chain evaluation of optional chain with arguments let new value be get value new reference if the source text match.
Okay, wait. No, wait, never mind. Is this 1? Okay, wait. I think the number ended up being negative. Okay, that's what it was.
Capital P R O
Because it's a byte. Or it should be byte. Okay, never mind. That's what it was. It's taking forever. I gotta just template this.
capital I D
I was like, yet it doesn't matter.
strict 66 ECMA International 2024 optional chain private identifier let optional chain be optional chain let new reference be chain evaluation of optional chain with arguments base value and base reference let new value be get value new reference let field name string be the string value of private identifier return make private reference new value field name string the 3rd of March 2010 import calls 3.3.1.0 1 runtime semantics evaluation import call import assignment expression let ref Ruby get active script or module if referrer is null set referrer to the current realm record let arggraph be evaluation of assignment expression let specifier be get value arggraph let promise capability be new promise capability %promise let specifier string be completion to string specifier if abrupt reject promise specifier string promise capability perform host load imported module referrer specifier string empty promise capability return promise capability 3.3.1.0.1 continue dynamic import promise capability module completion the abstract operation continue dynamic import takes arguments promise capability a promise capability record and module completion either a normal completion containing a module record or a throw completion and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call promise capability undefined. Module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined. Reason be return unused. Let onRejected be create built-in function. Rejected closure 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and onRejected and performs the following steps when called. A let link be completion. Module link be if link is an abrupt completion, then I perform call promise capability undefined. Link 2. Return unused. C let evaluate promise be module evaluate. D let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace. Module 2. Perform call promise capability undefined. Namespace 3. Return unused. Let unfulfilled be create built-in function. Fulfilled closure 0. F perform promise then. Evaluate promise. Unfulfilled. Unrejected. G return unused. Link and evaluate be create built-in function. Link and
Okay.
perform
Really, is the mic not working again?
promise. Link and evaluate. Unrejected. Return unused. ECMA International
Testing, testing.
267. The 13,011 tag templates. 3. 3. 1 1. 1 runtime semantics. Evaluation. Member expression. Member expression template literal. Let tag ref be. Evaluation of member expression. Let tag fun be. Get
Testing, testing.
The host-defined abstract operation host finds import meter takes arguments import meter, an object,
What is up?
a module record, and returns a
What is up with the fucking Mac? The sound keeps failing, and then like Siri goes slow-mo.
import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter.
For fuck's sake. Oh my god, it's so annoying. Why can't shit just work? For fuck's sake.
ECMAScript code. The
I should be able to click a button and just let it run. But no. No. Everything has fucking memory leaks. Nothing fucking works.
Hello, I'm Siri. Hello, I'm Siri. Hello, I'm Siri. Hello, I'm Siri. Hello, I'm Siri.
Anyways, I figured out what my problem was. Normally, I increment inside of a loop, but now I'm decrementing because I don't want to add an offset to every excess. So I want to decrement it, the counter, whatever. But when I define the macro, I was putting an increment. So I was subtracting 1, and I was incrementing it 1. But I meant to put decrement. Because it's a little endian, so it starts from the end. So I have to loop backwards from the end of it to the beginning. Because it's backwards from big endian. I don't know. That was a waste of time. That was annoying. Well, I don't need to put this here now. I don't know. Instead of putting the field decrement here, I'm just going to subtract 1 from the field offset and check to make sure that it's 0. Or not 0. Because then it'll go negative. This is getting boring. I need to like hurry up and get this done. now have a macro to do the leave operation, whatever, destination, source, field offset. If I have to add more arguments, I'll just make more variants of the macro. And then increment, decrement, address. And I pass in the size t to make sure that it's 1. Because increment, decrement, they set different flags in the flag field on x86. So I have to differentiate between increment, decrement, subtract, or add. So when I need to make like an add macro to add an offset, whatever, then there'll be a reason for this, like the size t. But for now, at least, I can like type check or whatever to make sure that what I'm passing in is size t1. And now, if it's endian, big endian, little endian, I can check, or it does check, whatever, at assemble time. And then I can simply put code here for like big endian. And I won't have to adjust the address. It'll just be that, whatever. Except I have this set up. I highly doubt there's like a middle endian x86. But on the off chance, I could put code here too. I don't even know what I would fucking put for the address, because this seems like a joke to like access the value from the middle in 2 parts. Like that makes no sense. Or like part of it's flipped after 32 bits or something. That'd be ridiculous to support. If that were the case, then I would like need a whole new loop. But if I did need a whole new loop, it'd be easier to support it. I should probably make a move macro. I'm not going to bother with it for now. This works for now. I don't know. This is getting boring. I need some pop, sugar, caffeine, soda pop. I just want to be done. It's take forever.
Ship named by the operator holds between its 2 operands. Note 1 given the above definition of equality.
Series like stuck in slow-mo or something.
Equality. String comparison.
This somehow there might be like a shortcut on the keyboard. Maybe I accidentally click it. I don't know. I think it's fixed. I don't know.
Equals $, B, Numeric comparison can be forced by plus A equals plus B. Boolean comparison can be forced by A equals B. Note 2. The equality operators maintain the following invariants. A equals B is equivalent to A equals B. A equals B is equivalent to B equals A, except in the order of evaluation of A and B. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string equals A and A equals new string are both true. New string equals new string is false. Note: for comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 3.12 Binary bitwise operators syntax. Bitwise and expression in yield await. Equality expression in yield await. Bitwise and expression in yield await. And equality expression in yield await. Bitwise or expression in yield await. Bitwise and expression in yield await. Bitwise or expression in yield await. Bitwise and expression in yield await. Bitwise or 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 expression in yield await. 3.1.2 1 runtime semantics. Evaluation. Bitwise and expression. Bitwise and expression and equality expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E. Bitwise and expression and equality expression. ECMA International 2024 279. Bitwise or expression. Bitwise or expression. Bitwise and expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E. Bitwise or expression. Bitwise and expression. Bitwise or expression. Bitwise or expression. Bitwise or expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E. Bitwise or expression. Bitwise or expression. 3.13 Binary logical operators syntax. Logical and expression in yield await. Bitwise or expression in yield await. Logical and expression in yield await. And bitwise or expression in yield await. Logical or expression in yield await. Logical and expression in yield await. Logical or expression in yield await. Logical and expression in yield await. Coalesce expression in yield await. Coalesce expression head in yield await. Bitwise or expression in yield await. Coalesce expression head in yield await. Coalesce expression in yield await. Bitwise or expression in yield await. Short circuit expression in yield await. Logical or express ion in yield await. Coalesce expression in yield await. 3.1.3 1 runtime semantics. Evaluation. Logical and expression logical and expression and bitwise or expression, letter FB. Evaluation of logical and expression, letter val B. Get value, ref, letter bool b to boolean, val, if the bool is false, return val, letter FB. Evaluation of bitwise or expression, return. Get value, ref, logical or expression, logical or expression, logical and expression, letter FB. Evaluation of logical or expression, letter val B. Get value, ref, letter bool b to boolean, val, if the bool is true, return val, letter FB. Evaluation of logical and expression, return. Get value, ref, 280, ECMA International 2024. The value produced by a and or operator is not necessarily of type Boolean. The value produced, note, will always be the value of one of the two operand expressions, coalesce expression head. Bitwise or expression, letter FB. Evaluation of coalesce expression head, letter val B. Get value, ref, if the val is either undefined or null, then a letter FB. Evaluation of bitwise or expression be return. Get value, ref, else a return val. 3.14 Conditional operator. Syntax, conditional expression, in, yield, await, short circuit expression in yield await, short circuit expression in yield await, assignment expression, plus in yield await, assignment expression in yield await. 3.14. 1 runtime semantics. Evaluation, conditional expression, short circuit expression, assignment expression, letter FB. Evaluation of short circuit expression, letter val b to boolean. Get value, ref, if val is true, then a let true FB. Evaluation of the first assignment expression be return. Get value, true ref, else a let false FB. Evaluation of the second assignment expression be return. Get value, false ref. Note the grammar for a conditional expression in ECMAScript is slightly different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMAScript is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International 2024 281 13.15 Assignment operators syntax. Assignment expression, in, yield, await. Conditional expression in yield await plus yield. Yield expression in await. Arrow function in yield await. Async arrow function in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await. Assignment operator assignment expression in yield await. Left-hand side expression yield await. And equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Assignment operator, 1 of, equals percent equals plus equals and equals. 3.15. 1 static semantics. Early errors. Assignment expression. Left-hand side expression equals assignment expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. Assignment expression. Left-hand side expression assignment operator assignment expression left-hand side expression and equals assignment expression left-hand side expression equals assignment expression left-hand side expression equals assignment expression. It is a syntax error if assignment target type of left-hand side expression is not simple. 3.15. 2 runtime semantics. Evaluation. Assignment expression. Left-hand side expression equals assignment expression. 82. If left-hand side expression is neither an object literal nor an array literal, then a letter FB. Evaluation of left-hand side expression. BF is anonymous function definition. Assignment expression. and is identifier ref of left-hand side expression are both true, then I let eval be. Named evaluation of assignment expression with argument ref. See else. I let ref be. Evaluation of assignment expression 2. Let eval be. Get value ref d perform. Put value ref. Reval e return reval. Let assignment pattern be the assignment pattern that is covered by left-hand side expression. ECMA International 2024. 3. Let ref be. Evaluation of assignment expression. Let eval be. Get value ref perform. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. Of assignment pattern with argument reval. Return reval. Assignment expression. Left-hand side expression. Assignment operator. Assignment expression. Let ref be. Evaluation of left-hand side expression. Let eval be. Get value ref. Let ref be. Evaluation of assignment expression. Let eval be. Get value ref. Let assignment op text be the source text matched by assignment operator. Let op text be the sequence of Unicode code points associated with assignment op text in the following table. Assignment op text equals percent plus equals and equals. Let R be. Capital A P P L Y. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital O P E R. Reval op text. Reval perform. Put value ref. R. Return R. Assignment expression. Left-hand side expression and equals assignment expression. Let ref be. Evaluation of left-hand side expression. Let eval be. Get value ref. Let bool be to boolean. Val. If bool is false, return val. If is anonymous function definition. Assignment expression is true and is identifier ref of left-hand side expression is true, then a let eval be. Named evaluation of assignment expression with argument ref. Else a let ref be. Evaluation of assignment expression be let reval be. Get value ref. Perform. Put value ref. Reval. Return reval. Assignment expression. Left-hand side expression equals assignment expression. Let ref be. Evaluation of left-hand side expression. Let eval be. Get value ref. Let bool be to boolean. Val. If bool is true, return val. If is anonymous function definition. Assignment expression is true and is identifier ref of left-hand side expression is true, then a let eval be. Named evaluation of assignment expression with argument ref 6. Else a let ref be. Evaluation of assignment expression be let reval be. Get value ref. ECMA International 2024 283 7. Perform. Put value ref. Reval. Return reval. Assignment expression. Left-hand side expression equals assignment expression. Let ref be. Evaluation of left-hand side expression. Let eval be. Get value ref. If eval is neither undefined nor null, return val. If is anonymous function definition. Assignment expression is true and is identifier ref of left-hand side expression is true, then a let eval be. Named evaluation of assignment expression with argument ref. Else a let ref be. Evaluation of assignment expression be let reval be. Get value ref. Perform. Put value ref. Reval. Return reval. 3 1 5 3. Capital A P P L Y. Capital S T R I N G. Capital O R. Capital N U M E R I C capital B I N A R Y capital O P E R val op text reval. The abstract operation capital A P P L Y capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital O P E R takes arguments val, an ECMAScript language value, op text, comma percent, plus, or, and reval, an ECMAScript language value, and returns either a normal completion containing either a string, a begint, or a number, or a throw completion. It performs the following steps when called. If op text is plus, then a letter from B. To primitive, val, B letter from B. To primitive, reval, see if prim is a string or reprim is a string, then I let lstrb. To string, prim 2. Let rstrb. To string, reprim 3. Return the string concatenation of lstr and rstr, d set reval till prim, e set reval to reprim. Note, at this point, it must be a numeric operation. Let num be. To numeric, reval, let num be. To numeric, reval, if type, num, is not type, renum. Throw a type error exception. If num is a big int, then, note when this expression occurs within strict mode code. It is a runtime error if ref in step 1d, 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7, 6 is a reference to a data property with the attribute value false, to an accessor property with the attribute value. These cases a type error exception is thrown. ABCD. Let if op text is return begint exponentiate num renum. If op text is comma return begint divide num renum. If op text is percent return begint remainder num renum. If op text is return begint unsigned right shift num renum. Operation be the abstract operation associated with op text and type num. In the following table, 84 ECMA International 2024 op text type num operation number exponentiate number multiply begint multiply number divide number remainder number add percent plus number big int number op text type num plus big int number big int number big int number big int comma number big int number big int number big int operation big int add number subtract big int subtract number left shift big int left shift number signed right shift big int signed right shift number and signed right shift number bitwise and big int bitwise and number bitwise or big int bitwise or number bitwise or big int bitwise or return operation num renum. Note 1 no hint is provided in the calls to primitive in steps 1a and 1b. All standard objects except dates handle the absence of a hint as if number were given. Dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2 step 1c differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, left operand, op text, right operand. The abstract operation, capital E, V, A, L, U, A, T, E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, takes arguments left operand, a parse node, op text, a sequence of Unicode code points, and right operand, a parse node, and returns either a normal completion containing either a string, a big int, or a number, or an abrupt completion. It performs the following steps when called. Letter FB. Evaluation of left operand. Letter val B. Get value. Ref. Letter FB. Evaluation of right operand. Letter val B. Get value. Ref. Return. Capital A P P L Y, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital O P E R, val, op text, reval 315. 5. Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern. Yield. Await. Object assignment pattern yield await. Array assignment pattern yield await. ECMA International 2024 285. Object assignment pattern. Yield. Await. Assignment dress property yield await. Assignment property list yield await. Assignment property list yield await. Assignment dress property yield await opt. Array assignment pattern. Yield. Await. Eligible assignment dressed element yield await opt. Assignment element list yield await. As. Inment element list yield await. Eligible assignment dressed element yield await opt. Assignment dress property. Yield. Await. Dart. Destructuring assignment target yield await. Assignment property list. Yield. Await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list. Yield. Await. Assignment elision element yield await. Assignment element list yield await. Assignment elision element yield await. Assignment elision element. Yield. Await. Elision assignment element yield await. Assignment property. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await opt property name yield await. Assignment element yield await. Assignment element. Yield. Await. Destructuring assignment target yield await. Initializer. Plus in yield await opt. Assignment dressed element. Yield. Await. Dart. Destructuring assignment target yield await. Destructuring assignment target. Yield. Await. Left-hand side expression yield await. 3. 1 5. 5. 1 static semantics. Early errors. Assignment property. Identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment dress property. Destructuring assignment target. It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target. Left-hand side expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. 86. Copyright sign. ECMA International 2024. It is a syntax error if assignment target type of left-hand side expression is not simple. 1 3 1 5 5. To runtime semantics. Capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A L U A T. The syntax directed operation. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, takes argument value, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Object assignment pattern. Perform. Require object coercible. Value. Return unused. Object assignment pattern. Assignment property list. Assignment property list. Perform. Require object coercible. Value. Perform. Capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N. The assignment property list with argument value. Return unused. Object assignment pattern. Assignment dress property. Perform. Require object coercible. Value. Let excluded names be a new empty list. Return. Capital R, E, S, T, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A. The assignment dress property with arguments value and excluded names. Object assignment pattern. Assignment property list. Assignment dress property. Perform. Require object coercible. Value. Let excluded names be. Capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N. On of assignment property list with argument value. Return. Capital R, E, S, T, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A. Of assignment dress property with arguments value and excluded names. Array assignment pattern. Let iterator record B. Get iterator. Value. Sync. Return. Iterator close. Iterator record. Normal completion. Unused. Array assignment pattern. Elision. Let iterator record B. Get iterator. Value. Sync. Let result be completion. Iterator destructuring assignment evaluation of elision with argument. Iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Elision not assignment dressed element. Let iterator record B. Get iterator. Value. Sync. If elision is present, then a let status be completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. Let result be completion. Iterator destructuring assignment evaluation of assignment dressed element with argument iterator record. ECMA International 2024 287. 4. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Let iterator record B. Get iterator. Value. Sync. Let result be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If iterator record is false, return, iterator close, iterator record, result, return result, array assignment pattern, assignment element list, eligible assignment rest element opt, let iterator record be, get iterator, value, sync, let status be completion, iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then if iterator record is false, return, iterator close, iterator record, status be return status. If elision is present, then assert status to completion, iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. If assignment rest element is present, then assert status to completion, iterator destructuring assignment evaluation of assignment rest element with argument iterator record. If iterator record is false, return, iterator close, iterator record, status, return status. 3. 1 5 5 3 runtime semantics, capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N. The syntax directed operation, capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, takes argument value, an ECMAScript language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all destructured property keys. It is defined piecewise over the following productions as assignment property list, assignment property list, assignment property. Let property names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property list with argument value. Let next names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property identifier reference initializer opt. Let P be string value of identifier reference. Let ref be resolve binding. P let V be jet value. P if initializer is present and V is undefined. Then if is anonymous function definition initializer is true. Then I set var2 named evaluation of initializer with argument P be else I let default value be evaluation of initializer 2 set var2 get value default value perform put value ref V return P 88 ECMA International 2024 assignment property property name assignment element let name be evaluation of property name perform capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V, of assignment element with arguments value and name. Return name 3155 for runtime semantics. Capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A. The syntax directed operation. Capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A takes arguments value, an ECMAScript language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment dress property. Destructuring assignment target. Letter FB. Evaluation of destructuring assignment target. Let rest objb ordinary object create. Object prototype perform. Copy data properties. Rest obj. Value. Excluded names. Return. Put value. Ref. Rest obj. 3155 runtime semantics. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. The syntax directed operation. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N takes argument iterator record, an iterator record, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element list. Assignment elision element. Return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment elision element with argument iterator record. Assignment element list. Assignment element list. Assignment elision element perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment element list with argument iterator record. Return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment elision element with argument iterator record. Assignment elision element. Assignment element. Return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment element with argument iterator record assignment elision element elision assignment element perform capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of elision with argument iterator record return capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment element with argument iterator record Elicio N. If iterator record is false, then a let next be completion iterator step iterator record B. If next is an abrupt completion, set iterator record to true. C. Return if abrupt next. D. If next is false, set iterator record to true. Return unused. Elision perform capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of elision with argument iterator record. If iterator record is false, then a let next be completion iterator step iterator record B. If next is an abrupt completion, set iterator record to true. ECMA International 2024 289. C. Return if abrupt next. D. If next is false, set iterator record to true. 3. Return unused. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then elect if B. Evaluation of destructuring assignment target. Let value be undefined. If iterator record is false, then elect next B. Iterator step value. Iterator record B. If next is not done, then I set value to next. If initializer is present and value is undefined, then if is anonymous function definition initializer is true and is identifier ref of destructuring assignment target is true, then I let VB. Named evaluation of initializer with argument ref b else I let default value be. Evaluation of initializer 2. Let VB. Get value. Default value else a let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Be return capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument V. Return put value ref V assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then elect ref B. Evaluation of destructuring assignment target. Let A be array create 0. Let M 0 repeat. While iterator record is false, elect next B. Iterator step value. Iterator record B. If next is not done, then I perform create data property or throw A to string N next 2. Set N to N plus 1. If destructuring assignment target is neither an object literal nor an array literal, then A return put value ref A. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Return capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A L U A T, of nested assignment pattern with argument A 3 1 5 5 6 runtime semantics, capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V. The syntax directed operation, capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V, takes arguments value, an ECMAScript language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following PROLOGUE: shines, assignment element, destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then let lref be. Evaluation of destructuring assignment target, let VB. Jet value, property name. If initializer is present and v is undefined, then 290. ECMA International 2024. Note: left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition, initializer, and is identifier ref of destructuring assignment target are both true, then I let RHS value be. Named evaluation of initializer with argument ref be else I let default value be. Evaluation of initializer 2. Let RHS value be. Get value, default value else I let RHS value be v. If the structuring assignment target is either an object literal or an array literal, then a let assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A L U A T, of assignment pattern with argument RHS value return. Put value ref RHS value 3.16 comma operator. Syntax: expression in yield await, assignment expression in yield await, expression in yield await, assignment expression in yield await. 1316 1 runtime semantics. Evaluation expression assignment expression let ref be. Evaluation of expression perform. Get value ref let ref be. Evaluation of assignment expression return. Get value ref. For ECMAScript language, statements and declarations syntax: statement yield await return, block statement yield await return, variable statement yield await, empty statement expression statement yield await, if statement yield await return, breakable statement yield await return, continue statement yield await, break statement yield await, plus return statement yield await, with statement yield await return, labeled statement yield await return, throw statement yield await, try statement yield await return, debugger statement. Note: get value must be called even though its value is not used because it may have observable side effects. ECMA International 2024 291. Declaration yield await, hoistable declaration yield await, default, class declaration yield await, default, lexical declaration, class in yield await, hoistable declaration, yield, await, default, function declaration yield await default, generator declaration yield await default, async function declaration yield await default, async generator declaration yield await default, breakable statement, yield, await, return, iteration statement yield await return, switch statement yield await return. 4.1 Statement semantics. 4.1 runtime semantics. Evaluation, hoistable declaration, generator declaration, async function declaration, async generator declaration, return empty, hoistable declaration, function declaration, return. Evaluation of function declaration, breakable statement, iteration statement, switch statement, let new label set be a new empty list, return. Labeled evaluation of this breakable statement with argument new label set. 4.2 Block syntax. Block statement, yield, await, return, block yield await return, block, yield, await, return, statement list yield await return opt, statement list, yield, await, return, statement list item yield await return, statement list yield await return, statement list item yield await return, statement list item, yield, await, return, statement yield await return, declaration yield await. 92. ECMA International 2024. 142. 1 Static semantics. Early errors. Block. Statement list. It is a syntax error if the lexically declared names of statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of statement list also occurs in the are declared names of statement list. 4.2. 2 Runtime semantics. Evaluation. Block. Return empty. Block. Statement list. Let old env be the running execution context's lexical environment. Let block env be new declarative environment. Old env perform block declaration instantiation. Statement list. Block env. Set the running execution context's lexical environment to block env. Let block value be completion. Evaluation of statement list. Set the running execution context's lexical environment to old env. Return block value. Statement list. Statement list item. Let SL be. Evaluation of statement list. Let S be completion. Evaluation of statement list item. Return. Update empty. S. SL. 4.2. 3 Block declaration instantiation. Code. env. The abstract operation block declaration instantiation takes arguments code, a parse node, and env, a declarative environment record, and returns unused code is the parse node corresponding to the body of the block. Env is the environment record in which bindings are to be created. It performs the following steps when called. Let declarations be the lexically scoped declarations of code. Let private env be the running execution context's private environment. For each element D of declarations, do a for each element Dn of the bound names of D. Do. ECMA International 2024 293. Note 1. No matter how control leaves the block, the lexical environment is always restored to its former state. Note 2. The value of a statement list is the value of the last value producing item in the statement list. For example, the following calls to the eval function all return the value 1, eval, 1, eval, 1, eval, 1. Var. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block, scoped variable, constant, function, or class declared in the block are instantiated in the environment record. If this constant declaration of D is true, then perform env create a mutable binding. Dn, true 2. Else, perform env create mutable binding. Dn, false. Note. The step is replaced in section B, 3, 2, 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding. fn, fo. Note, this step is replaced in section B, 3, 2, 6. Return unused. 4.3 declarations in the variable statement. 4, 3, 1. Syntax. Lexical declaration. In yield, await. Let or const binding list in yield await. Let or const binding list. In yield, await. Lexical binding in yield await. Binding list in yield await. Lexical binding in yield await. Lexical binding. In yield, await. Binding identifier yield await. Initializer in yield await opt binding pattern yield await. Initializer in yield await. 4, 3, 1. 1 static semantics. Early errors. Lexical declaration. Let or const binding list. It is a syntax error if the bound names of binding list contains let. It is a syntax error if the bound names of binding list contains any duplicate entries. Lexical binding. Binding identifier initializer opt. It is a syntax error if initializer is not present and is constant declaration of the lexical declaration containing this lexical binding is true. 94. ECMA International 2024. Let and const declarations. Let and const declarations define variables that are scoped to the running execution contexts. Note, lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable's lexical binding is evaluated. A variable defined by a lexical binding with an initializer is assigned the value of its initializer's assignment expression when the lexical binding is evaluated, not when the variable is created. If a lexical binding in a let declaration does not have an initializer, the variable is assigned the value undefined when the lexical binding is evaluated. 1, 4, 3, 1. 2 runtime semantics. Evaluation. Lexical declaration. Let or const binding list. Perform. Evaluation of binding list. Return empty. Binding list. Binding list. Lexical binding. Perform. Evaluation of binding list. Return. Evaluation of lexical binding. Lexical binding. Binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Perform. Initialize reference binding. LHS. Undefined. Return empty. Lexical binding. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition. Initializer is true, then a let value be. Named evaluation of initializer with argument binding id, else a let RHS be. Evaluation of initializer be let value be. Get value, RHS perform. Initialize reference binding, LHS, value, return empty, lexical binding, binding pattern initializer, let RHS be. Evaluation of initializer, let value be. Get value, RHS. Let env be the running execution context's lexical environment. Return. Binding initialization of binding pattern with arguments value and env. 4, 3, 2 variable statement. Syntax. Variable statement. Yield. Await. Our variable declaration list. Plus in yield await. A static semantics rule ensures that this form of lexical binding never occurs in a const. Note, declaration. A var statement declares variables that are scoped to the running execution contexts. Note, variable environment. Our variables are created when their containing environment record is instantiated and are initialized to undefined when created. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer's assignment expression when the variable declaration is executed, not when the variable is created. ECMA International 2024 295. Variable declaration list. In yield, await. Variable declaration in yield await. Variable declaration list in yield await. Variable declaration in yield await. Variable declaration in yield await. Binding identifier yield await. Initializer in yield await opt binding pattern yield await. Initializer in yield await. 4, 3, 2, 1 runtime semantics. Evaluation. Variable statement. var variable declaration list. Perform. Evaluation of variable declaration list. Return empty. Variable declaration list. Variable declaration list. Variable declaration. Perform. Evaluation of variable declaration list. Return. Evaluation of variable declaration. Variable declaration. Binding identifier 1. Return empty. Variable declaration. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be resolve binding. Binding id. If is anonymous function definition initializer is true, then a let value be named evaluation of initializer with argument binding id. Else a let RHS be evaluation of initializer be let value be get value RHS. Perform. Put value LHS value. Return empty. Variable declaration. Binding pattern initializer. Let RHS be evaluation of initializer. Let val be get value RHS. Return. Binding initialization of binding pattern with arguments reval and undefined. 4. 3. 3 destructuring binding patterns syntax. Binding pattern. Yield. Await. Object binding pattern yield await. Array binding pattern yield await. Note if a variable declarer, tion is nested within a with statement and the binding identifier in the variable declaration is the same as a property name of the binding object of the with statements object environment record. Then step 5 will assign value to the property instead of assigning to the variable environment binding of the identifier. 96. ECMA International 2024. Object binding pattern. Yield. Await. Binding rest property yield await. Binding property list yield await. Binding property list yield await. Binding rest property yield await opt. Array binding pattern. Yield. Await. Eligible binding rest element yield await opt. Binding element list yield await. Binding element list yield await. Eligible binding rest element yield await opt. Binding rest property. Yield. Await. Dart. Binding identifier yield await. Binding property list. Yield. Await. Binding property yield await. Binding property list yield await. Binding property yield await. Binding element list. Yield. Await. Binding elision element yield await. Binding element list yield await. Binding elision element yield await. Binding elision element. Yield. Await. Elision binding element yield await. Binding property. Yield. Await. Single name binding yield await. Property name yield await. Binding element yield await. Binding element. Yield. Await. Single name binding yield await. Binding pattern yield await. Initializer. Plus in yield await opt. Single name binding. Yield. Await. Binding identifier yield await. Initializer. Plus in yield await opt. Binding rest element. Yield. Await. Dart. Binding identifier yield await. Binding pattern yield await. 4. 3. 3. 1 runtime semantics. Property binding initialization. The syntax-directed operation property binding initialization takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion contain in a list of property keys or an abrupt completion. It collects a list of all bound property names. It is defined piecewise over the following productions: binding property list, binding property list, binding property. Let bound names be property binding initialization of binding property list with arguments value and environment. Let next names be property binding initialization of binding property with arguments value and environment. Return the list concatenation of bound names and next names. ECMA International 2024 297. Binding property. Single name binding. Let name be the sole element of the bound names of single name binding. Perform. Keep binding initialization of single name binding with arguments value, environment, and name. Return name. Binding property. Property name. Binding element. Let P be evaluation of property name. Perform. Keep binding initialization of binding element with arguments value, environment, and P. Return P. 4. 3. 3. 2 runtime semantics. Rest binding initialization. The syntax-directed operation rest binding initialization takes arguments value, an ECMAScript language value, environment and environment record or undefined, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding rest property, binding identifier, let LHS be, resolve binding, string value of binding identifier, environment, let rest obj be ordinary object create, %object prototype %perform, copy data properties, rest obj, value, excluded names. If environment is undefined, return, put value, LHS, rest obj, return, initialize reference binding, LHS, rest obj, 4, 3, 3, 3 runtime semantics, keep binding initialization. The syntax-directed operation keep binding initialization takes arguments value, an ECMAScript language value, environment and environment record or undefined, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding element, binding pattern initializer opt, let VB, jet, value, property name. If initializer is present and v is undefined, then a let default value be. Evaluation of initializer be set v2. Get value, default value, return. Binding initialization of binding pattern with arguments v and environment. Single name binding, binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be. Resolve binding, binding id, environment. Let VB. Jet, value, property name. If initializer is present and v is undefined, then if is anonymous function definition, initializer, is true, then I set v2. Named evaluation of initializer with argument binding id be else. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 98. ECMA International 2024. I2. Let default value be. Evaluation of initializer. Semvia2. Get value, default value. 5. If environment is undefined, return. Put value, LHS, v, return. Initialize reference binding, LHS, v. 4.4 empty statement syntax. Empty statement. 4, 1 runtime semantics. Evaluation. Empty statement. 1. Return empty. 4.5 expression statement syntax. Expression statement. Yield. Await. Look ahead. Function. Async. No line terminator here. Function. Class. Let. Expression. Plus in yield await. Note an expression statement cannot start with a u+007b, left curly bracket, because that might make it ambiguous with a block. An expression statement cannot start with the function or class keywords because that would make it ambiguous with a function declaration, a generator declaration, or a class declaration. An expression statement cannot start with a sync function because that would make it ambiguous with an async function declaration or a sync generator declaration. An expression statement cannot start with the two-token sequence let, because that would make it ambiguous with a let lexical declaration whose first lexical binding was an array binding pattern. 4, 5, 1 runtime semantics. Evaluation. Expression statement. Expression. Let expref be. Evaluation of expression. Return. Get value. Expref. 4.6 If statement syntax. If statement. Yield. Await. Return. If. Expression. Plus in yield await. Statement yield await return. Else. Statement yield await return. If. Expression. Plus in yield await. Statement yield await return. Look ahead else. The look ahead restriction. Look ahead else. Resolves the classic dangling else problem in the usual way. That is, when the choice of associated if is otherwise ambiguous, the else is associated with the nearest, innermost, of the candidate ifs. ECMA International 2024 299 146 1 Static semantics. Early errors. If statement. If. expression statement else statement. It is a syntax error if is labeled function. The first statement is true. It is a syntax error if is labeled function. The second statement is true. If statement, if, expression statement. It is a syntax error if is labeled function. Statement is true. Note it is only necessary to apply this rule if the extension specified in B3.1 is implemented. 4, 6. To runtime semantics. Evaluation. If statement, if, expression statement else statement. Let x per f be. Evaluation of expression. Let x per value be to boolean. Get value, x per f. If x per value is true, then let stmt completion be completion. Evaluation of the first statement 4. Else let stmt completion be completion. Evaluation of the second statement 5. Return. Update empty. STMT completion. Undefined. If statement. If. Expression statement. Let x per f be. Evaluation of expression. Let x per value be to boolean. Get value. X per f. If x per value is false, then a return undefined 4. Else let STMT completion be completion. Evaluation of statement be return. Update empty. STMT completion. Undefined. 4.7 Iteration statement syntax. Iteration statement. Yield. Await. Return. Do while statement yield await return. While statement yield await return. For statement yield await return. For an of statement yield await return. 4, 7, 1 Semantics. 4, 7, 1. 1 loop continues. Completion. Label set. The abstract operation loop continues takes arguments completion, a completion record, and label set, a list of strings, and returns a boolean. It performs the following steps when called. If completion is a normal completion, return true. If completion is not a continue completion, return false. If completion is empty, return true. 300. ECMA International 2024. 4. If label set contains completion, return true. Return false. 4, 7, 1. To runtime semantics. Loop evaluation. The syntax-directed operation loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Iteration statement. Do while statement. Return. Do while loop evaluation of do while statement with argument label set. Iteration statement. While statement. Return. While loop evaluation of while statement with argument label set. Iteration statement. For statement. Return. For loop evaluation of for statement with argument label set. Iteration statement. For an of statement. Return. For an of loop evaluation of for an of statement with argument label set 1 4 7 2 the do while statement. Syntax. Do while statement. Yield. Await. Return. Do statement yield await return. While. Expression. Plus in yield await. 4, 7, 2, 1 Static semantics. Early errors. Do while statement. Do statement while. Expression. It is a syntax error if is labeled function. Statement. Is true. Note it is only necessary to apply this rule if the extension specified in B3.1 is implemented 1 4, 7, 2. To runtime semantics. Do while loop evaluation. The syntax-directed operation do while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Do while statement. Do statement while. Expression. Let v be undefined 2. Repeat. Let stmt result be completion. Evaluation of statement. B if loop continues. stmt result. Label set. Is false. Return. Update empty. stmt result. V. See if stmt result is not empty. Set v to stmt result. D let x per f be. Evaluation of expression. Note within the statement part of an iteration statement a continue statement may be used to begin a new iteration. Copyright sign. ECMA International 2024 301. E let x per value be. Get value. X per f. F if to boolean. X per value. Is false. return v. 4, 7, 3 while statement syntax. While statement, yield, await, return, while, expression, plus in yield await, statement yield await return. 4, 7, 3, 1 static semantics, early errors. While statement, while, expression statement. It is a syntax error if is labeled function, statement, is true. Note it is only necessary to apply this rule if the extension specified in B3.1 is implemented. 1.4.7.3 to runtime semantics. While loop evaluation. The syntax-directed operation while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. While statement, while, expression statement, let v be undefined 2. Repeat, a let x per f be. Evaluation of expression, b let x per value be. Get value, x per f, see if to boolean, x per value, is false. Return v, d let stmt result be completion. Evaluation of statement, e if loop continues, stmt result, label set, is false. Return. Update empty, stmt result, v, f if stmt result is not empty, set v to stmt result. 4, 7, 4th f for statement syntax. For statement, yield, await, return. 4, look ahead let, expression, in yield await opt. 1.4.7.4.1 expression, plus in yield await opt, expression, plus in yield await opt, statement yield await return. 4, var variable declaration list, in yield await, expression, plus in yield await opt, expression, plus in yield await opt, statement yield await return. 4, lexical declaration, in yield await, expression, plus in yield await opt, expression, plus in yield await opt, statement yield await return. Static semantics, early errors. For statement, 4, expression not, expression not, expression not statement. 4, var variable declaration list, expression not, expression not statement. 4, lexical declaration expression not, expression not statement. 02 ECMA International 2024, it is a syntax error if is labeled function, statement, is true. Note it is only necessary to apply this rule if the extension specified in B3.1 is implemented. For statement, 4, lexical declaration expression not, expression not statement. It is a syntax error if any element of the bound names of lexical declaration also occurs in the are declared names of statement. 4, 7, 4. To runtime semantics. For loop evaluation, the syntax-directed operation for loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. For statement, 4, expression not, expression not, expression not statement. If the first expression is present, then a let x per f be. Evaluation of the first expression be perform. Get value, x per f. If the second expression is present, let test be the second expression. Otherwise, let test be empty. If the third expression is present, let increment be the third expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement, 4, var variable declaration list, expression not, expression not statement. Perform. Evaluation of variable declaration list. If the first expression is present, let test be the first expression. Otherwise, let test be empty. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement, 4, lexical declaration expression not, expression not statement. Let all DNV be the running execution context's lexical environment. Let loop env be new declarative environment. old env. Let is const be is constant declaration of lexical declaration. Let bound names be the bound names of lexical declaration. For each element dn of bound names, do if this const is true, then I perform loop env create immutable binding. dn true be else I perform loop env create mutable binding. dn false set the running execution context's lexical environment to loop env. Let for DCL be completion, evaluation of lexical declaration. If for DCL is an abrupt completion, then A set the running execution context's lexical environment to old env. B return for DCL. If this const is false, let per iteration lets be bound names, otherwise let per iteration lets be a new empty list. 0. If the first expression is present, let test be the first expression, otherwise, let test be empty. 1. If the second expression is present, let increment be the second expression, otherwise, let increment be empty. 2. Let body result be completion, for body evaluation, test, increment, statement, per iteration lets, label set. 3. Set the running execution context's lexical environment to old env. 4. Return body result. Copyright sign, ECMA International 2024 303 147 4 3 for body evaluation, test, increment, STMT, per iteration bindings, label set. The abstract operation for body evaluation takes arguments test, an expression pars node or empty, increment, an expression pars node or empty, STMT, a statement pars node, per iteration bindings, a list of strings, and label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let v be undefined. Perform. Create per iteration environment, per iteration bindings. Repeat. If test is not empty, then I let testref be. Evaluation of test. 2. Let test value be. Get value, testref. 3. If to boolean, test value, is false, return v. B let result be completion, evaluation of STMT. See if loop continues, result, label set, is false, return. Update empty, result, v. D if result is not empty, set v to result. Perform. Create per iteration environment, per iteration bindings. F if increment is not empty, then I let incref be. Evaluation of increment. 2. Perform. Get value, incref. 4, 7, 4. 4 create per iteration environment, per iteration bindings. The abstract operation create per iteration environment takes argument per iteration bindings, a list of strings, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If per iteration bindings has any elements, then a let last iteration env be the running execution context's lexical environment. B let outer be last iteration env. C assert. Outer is not null. D let this iteration env be new declarative environment. Outer. E for each element bn of per iteration bindings. Do I perform this iteration env create mutable binding. Bn. False. 2. Let last value be last iteration env get binding value. Bn. True. 3. Perform this iteration env initialize binding. Bn. Last value. F set the running execution context's lexical environment to this iteration env. Return unused. 04. ECMA International 2024 147 5 the for of, and for await of statement syntax. For in of statement, yield, await, return. 4. Look ahead let, left-hand side expression yield await, in, expression, plus in yield await, statement yield await return. 4. var for binding yield await, in expression, plus in yield await, statement yield await return. 4. For declaration yield await, in expression, plus in yield await, statement yield await return. 4. Look ahead, let, async of, left-hand side expression yield await, of assignment expression, plus in yield await, statement yield await return. 4. var for binding yield await, of assignment expression, plus in yield await statement yield await return. 4. For declaration yield await of assignment expression plus in yield await statement yield await return plus await. For await, look ahead let left-hand side expression yield await of assignment expression plus in yield await statement yield await return plus await. For await, var for binding yield await of assignment expression plus in yield await statement yield await return plus await. For await, for declaration yield await of assignment expression plus in yield await statement yield await return. For declaration yield await let or const. For binding yield await. For binding yield await binding identifier yield await binding pattern yield await. Note this section is extended by an XB 3.5.1.4.7.5.1 static semantics. Early errors for in of statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await, left-hand side expression of assignment expression statement. For await, var for binding of assignment expression statement. For await, for declaration of assignment expression statement. It is a syntax error if is labeled function statement is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. Copyright sign, ECMA International 2024 305. For in of statement. 4. Left-hand side expression in expression statement. 4. Left-hand side expression of assignment expression statement. For await, left-hand side expression of assignment expression statement. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. For in of statement. 4. For declaration in expression statement. 4. For declaration of assignment expression statement. For await, for declaration of assignment expression statement. It is a syntax error if the bound names of for declaration contains let. It is a syntax error if any element of the bound names of for declaration also occurs in the for are declared names of statement. It is a syntax error if the bound names of for declaration contains any duplicate entries. 4. 7. 5. To static semantics is destructuring. The syntax-directed operation is destructuring takes no arguments and returns a boolean. It is defined piecewise over the following productions. Member expression, primary expression. If primary expression is either an object literal or an array literal, return true, return false. Member expression, expression, member expression. Identifier name member expression template literal super property meter property new member expression arguments member expression private identifier new expression new expression left hand side expression call expression optional expression return false. For declaration let or const. For binding return is destructuring of for binding binding identifier return false. 06. ECMA International 2024. For binding pattern 1. Return true. Note this section is extended by an XB 3.5.4.7.5.3 runtime semantics. Capital F O R capital D E C L A R A T I O N capital B I N D I N G capital I N I T I A L I Z. The syntax directed operation. Capital F O R capital D E C L A R A T I O N capital B I N D I N G capital I N I T I A L I Z takes arguments value, an ECMAScript language value, and environment an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: for declaration, let or const for binding, return. Binding initialization of for binding with arguments value and environment. 4, 7, 5. For runtime semantics, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A. The syntax-directed operation, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A, takes argument environment a declarative environment record, and returns unused. It is defined piecewise over the following productions: for declaration, let or const for binding. For each element name of the bound names of for binding, do A. If this constant declaration of let or const is true, then I perform environment create immutable binding. Name. True B else I perform environment create mutable binding. Name. False 2. Return unused. 4, 7, 5. Runtime semantics. For an of-loop evaluation, the syntax-directed operation for an of-loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: for an of statement, for left-hand side expression in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, left-hand side expression, statement, key result, enumerate, assignment, label set. For an of statement, for var for binding in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, for binding, statement, key result, enumerate, var binding, label set. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements in the formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 307. For an of statement, for declaration in expression statement, let key result be. For an of head evaluation, bound names of for declaration, expression, enumerate, return. For an of body evaluation, for declaration, statement, key result, enumerate, lexical binding, label set. For an of statement, for left-hand side expression of assignment expression statement, let key result be. For an of head evaluation, assignment expression, iterate, return. For an of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set. For an of statement, for var for binding of assignment expression statement, let key result be. For an of head evaluation, assignment expression, iterate, return. For an of body evaluation, for binding, statement, key result, iterate, var binding, label set. For an of statement, for declaration of assignment expression statement, let key result be. For an of head evaluation, bound names of for declaration, assignment expression, iterate, return. For an of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set. For an of statement, for await, left-hand side expression of assignment expression statement, let key result be. For in of head evaluation, assignment expression, async iterate, return. For in of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set, async. For in of statement, for await, var for binding of assignment expression statement, let key result be. For in of head evaluation, assignment expression, async iterate, return. For in of body evaluation, for binding, statement, key result, iterate, var binding, label set, async. For in of statement, for await, for declaration of assignment expression statement, let key result be. For in of head evaluation, bound names of for declaration, assignment expression, async iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set, async. Note this section is extended by an XB 3.5, 4, 7, 5, 6 for in of head evaluation, uninitialized bound names, expr, iteration kind. The abstract operation for in of head evaluation takes arguments uninitialized bound names, a list of strings, expr, an expression parse node or an assignment expression parse node, and iteration kind, enumerate, iterate, or async iterate, and returns either a normal completion containing an iterator record or an abrupt completion. It performs the following steps when called. 1. 2. Let old env be the running execution context's lexical environment. If uninitialized bound names is not empty, then 08. ECMA International 2024 ABC D. Assert. Uninitialized bound names has no duplicate entries. Let new env be new declarative environment. Old env for each string name of uninitialized bound names. Do I perform new env create mutable binding name false. Set the running execution context's lexical environment to new env. 3. Let expr be completion evaluation of expr. Set the running execution context's lexical environment to old env. Let expr value be get value expr. If iteration kind is enumerate, then if expr value is either undefined or null, then I return completion record. Break empty b let obj be to object expr value. C let iterator be enumerate object properties. Obj d let next method be jet iterator next e return the iterator record. Iterator next method false else assert iteration kind is either iterate or async iterate. B if iteration kind is async iterate, let iterator kind be async. C else let iterator kind be sync. D return get iterator expr value iterator kind. The abstract operation for in of body evaluation takes arguments LHS, a parse node, STMT, a statement parse node, iterator record, an iterator record, iteration kind, enumerate or iterate, LHS kind, assignment, var binding, or lexical binding, and label set, a list of strings, and optional argument iterator kind, sync or async, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If iterator kind is not present, set iterator kind to sync. Let old env be the running execution context's lexical environment. Let v be undefined. Let destructuring be as destructuring of LHS. If destructuring is true and LHS kind is assignment, then assert LHS is a left-hand side expression. B let assignment pattern be the assignment pattern that is covered by LHS. Repeat. A let next result be call iterator record. Iterator record. B if iterator kind is async, set next result. 2. Await next result. C if next result is not an object, throw a type error exception. D less done B iterator complete next result. E if done is true, return v. F let next value be iterator value next result. G if LHS kind is either assignment or var binding, then I if destructuring is true, then if LHS kind is assignment, then a let status be completion. Destructuring assignment evaluation of assignment pattern with argument next value 2. Else assert LHS kind is var binding. B assert. LHS is a for binding. C let status be completion. Binding initialization of LHS with arguments next value and undefined. 2. Else, let LHS ref be completion. Evaluation of LHS. It may be evaluated repeatedly. If LHS ref is an abrupt completion, then a let status be LHS ref 3. Else, a let status be completion. Put value, LHS ref. Next value, H else. I assert, LHS kind is lexical binding. 2. Assert, LHS is a for declaration. 3. Let iteration env be new declarative environment. Old env, I've. Perform, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A, of LHS with argument iteration en v, for in of body evaluation, LHS, STMT, iterator record, iteration kind, LHS kind, label set, iterator kind, 4, 7, 5, 7, ECMA International 2024.
I have this stuff
8. Runtime semantics.
set up whatever, where like
Lexical environment to iteration.
I have an enum and then a define to pick the option, and
Iteration binding initialization of LHS with arguments next value.
if I have to like type this up 3-4 times for every thing I define, like in a block, that'll be annoying.
Resolve binding. LHS name. Let status be completion. Initialize.
So I want to like put this in a macro.
Then I set the running execution context's lexical environment to old env.
And then like, if possible, like glue a keyword at the end.
If iteration kind is enumerate, then return status sive. Else assert. Iteration kind is iterate. Return. Iterator close. Iterator record. Status. J let result be completion. Evaluation of STMT. K set the running execution context's lexical environment to old env. L if loop continues. Result. Label set. Is false. Then I if iteration kind is enumerate. Then 1. Return. Update empty. Result. V2. Else assert. Iteration kind is iterate. Set status to completion. Update empty. Result.
So if I do that, I can define this once here, and then I'll auto-define, or not auto-define, well, it'll be like wrapped up or whatever in one macro I can call, and I can pass in a single name to tag it as. I think that works in this compiler. Assembler. This wouldn't work in C. I think you can define things inside of a macro. In C you can't do that. I don't remember. Like, look up how to like glue the token. So boring. So then I can like define all the stuff. Like this first one's to print binary whatever, and I can toggle it to print hexdes, like a word.
Properties of the target object may be deleted during enumeration. A property that is deleted before it is processed by the iterator.
So if I like change it
New properties are added to the target object during enumeration. The new
to pick well, sorry, binary word,
a property name will be returned by the iterator's next method at
and then I run it
enumerating the
after I build it and link it. Then click the executable. This is so boring.
Property of a prototype is not processed if it has the same 10 copyright sign. ECMA International 2024.
So like now whatever it's printing binary.
Next method.
If I switch it
Not considered when determining if a property of a
to hexadecimal word, it'll print 16 bits. That's hexadecimal.
prototype object is the argument. Enumerate object properties must obtain the own property keys of the
And then it builds.
terminal method. Property attributes.
And now it's hexadecimal, 16 bits, but it's not setting value. So I gotta update the loop later. I don't know. That's my best option to get done quick. And the better option, because I don't want to define the same thing
One of the
everywhere, because the file becomes a big ass mess.
or an object in its prototype chain. A property is added to
And then I can like
a chain, or the value of the attribute of a property of O or an object in its prototype chain changes. No
make the header a separate parameter,
to implement the algorithm in 1.4.
and then print like 3-4 boxes of different data, and they'll all populate the same, and it can change the types, whatever.
Algorithm unless
And if I need, I can like add another define to pick certain indices and change the value from like binary to hexadecimal, 2 byte, 4 byte, 8 byte. So I'll do that. This is so boring.
continue. Const desk equals reflect get own property descriptor.
But then, so I gotta add like,
Desk enumerable yield key. Const proto equals reflect
I think it's called a quad for like 8 byte, 64 bit.
4. Const proto key of enumerate object properties.
So I'll like template this stuff. I'll make a quad,
List of exotic objects for which
make a number 4 option.
implementations historically differed in behavior for those cases and agreed in all the others. 4, 7, 5.
Then I find all the places where it's hexadec, or one of them,
An object that represents a specific iteration.
and I do like define quad,
For an iterator
and that's 8 bytes.
script code. They exist solely to illustrate the behavior of enumerate object properties. ECMA International 2000.
So 63 bits. The sign bit,
5.
and if I want default value, and then right here I double check to make sure the default value is not bigger than size t, and then the count of how many.
Iterator. It is used to create a for an iterator
So if you need like, I don't know. Oh no, this is the count of the list.
to be ordinary object create. Percent for an iterator.
Or no, that's the count of the characters.
Set iterator to a new empty list. Set iterator to a new empty list. Return iterator 4, 7, 5, 1, 0 to the percent for an iterator prototype percent object. The percent for an iterator prototype percent object has properties that are inherited by all for an iterator objects. Is an ordinary object. Has an internal slot whose value is percent iterator prototype percent. Is never directly accessible to ECMAScript code. Has the following properties 4, 7, 5, 1, 0.
Now this is the count of how many chart codes that are needed to print it. So I need to make this, it's a calculated value, because this is a byte, I'm defining binary. So it's 16 instead of just 1 or 2 in hexadecimal, because it's like 16 bits, chart codes, whatever.
As a string, then a append key to 03. Set O to true.
So I'm going to template this, and I add more options, well, another option for like printing 64-bit as a hexadecimal.
Same value. R, V is true. Then let desk be object. R if desk is not undefined. Then A append R to O. B if desk is true.
Then I can change or print the address, whatever. Check that.
O to false. F if object is null. Return create.
And then do some speed tests and print speeds at the end.
5 1 0 3 property.
All I have to do is make this into a macro. It's probably going to take longer than it should.
Prototype % intrinsic object. For an iterator, instances are initially created with the internal slots listed in table 39.12. Copyright sign, ECMA International 2024. Table 39.
So, I don't know, I'm going to do that then.
Internal slot. Type, description, object, an object. The object value whose properties are being iterated. Object was visited. A boolean, true if the iterator has invoked on. False otherwise. Visited keys. A list of strings. The values that have been emitted by this iterator thus far. Remaining keys. A list of strings. The values remaining to be emitted for the current object before iterating the properties of its prototype. If its prototype is not null. 14.8 The continue statement syntax. Continue statement. Yield. Await. Continue. Continue. No line terminator here. Label identifier yield await. 148. 1 static semantics. Early errors. Continue statement. Continue. Continue label identifier. It is a syntax error if this continue statement is not nested, directly or indirectly, but not crossing function or static initialization block boundaries within an iteration statement. 148. To runtime semantics. Evaluation. Continue statement. Continue. Return completion record. Continue. Empty. Empty. Continue statement. Continue label identifier. Let label be the string value of label identifier. Return completion record. Continue. Empty. Label. 4.9 The break statement syntax. Break statement. Yield. Await. Break. Break. No line terminator here. Label identifier yield await. 149. 1 static semantics. Early errors. Break statement. Break. ECMA International 2024. 13. It is a syntax error if this break statement is not nested, directly or indirectly, but not crossing function or static initialization block boundaries within an iteration statement or a switch statement. 4. 9. To runtime semantics. Evaluation. Break statement. Break. Return completion record. Break. Empty. Empty. Break statement. Break label identifier. Let label be the string value of label identifier. Return completion record. Break. Empty. Label. 4.10 The turn statement syntax. Return statement. Yield. Await. Return. Return. No line terminator here. Expression. Plus in yield await. 4. 1 0. 1 runtime semantics. Evaluation. Return statement. Return. Return completion record. Return. Undefined. Empty. Return statement. Return expression. Let x per f be. Evaluation of expression. Let x per value be. Get value. X per f. If get generator kind is a sync. Set x per value to. Await. X per value. Return completion record. Return. X per value. Empty. A return statement causes a function to cease execution and, in most cases, return ns a value to. Note the caller. If expression is emitted, the return value is undefined. Otherwise, the return value is the value of expression. A return statement may not actually return a value to the caller depending on surrounding context. For example, in a try block, a return statement's completion record may be replaced with another completion record during evaluation of the finally block. Legacy 4.11 Fewth statement. Note 1 use of the legacy with statement is discouraged in new ECMAScript code. Consider alternatives that are permitted in both strict mode code and non-strict code, such as destructuring assignment. 14. ECMA International 2024. Syntax with statement. Yield. Await. Return with expression plus in yield await. Statement yield await return. 4. 1 1. 1 static semantics. Early errors with statement with Expression statement. It is a syntax error if the source text matched by this production is contained in strict mode code. It is a syntax error if is labeled function statement is true. Note it is only necessary to apply the second rule if the extension specified in B3.1 is implemented. 4.1.1 to runtime semantics. Evaluation with statement with expression statement. Let val be. Evaluation of expression. Let obj be. To object. Get value. Val. Let old env be the running execution context's lexical environment. Let new env be new object environment. Obj. True. Old env. Set the running execution context's lexical environment to new env. Let c be completion. Evaluation of statement. Set the running execution context's lexical environment to old env. Return. Update empty. C. Undefined. Note 2. The with statement adds an object environment record for a computed object to the lexical environment of the running execution context. It then executes a statement using this augmented lexical environment. Finally, it restores the original lexical environment. Note no matter how control leaves the embedded statement, whether normally or by some form of abrupt completion or exception, the lexical environment is always restored to its former state.
So outputs as hexadecimal.
Await. Case block yield await return. Case block yield await return. Case clauses yield await return opt. Case clauses yield await return opt. Default.
Or binary.
Case clauses yield await return opt. Case clauses yield await return. Case clause yield await return. Case clauses yield await return. Case clause yield await return. ECMA International 2024 315. Case clause
I change the enum option.
plus in yield await. Statement list yield await return opt.
I don't want to type that up several times.
Default. Statement list yield.
So I need to find everything named that like relate only to the size and stuff.
Expression. Case block. K. It is a syntax error.
To like a new macro name.
Case block contains
Separate it from the other things.
physically declared names of case block also occurs in the are declared names of case block. 4.1.2 to runtime semantics. Case block evaluation. The syntax-directed operation case block evaluation takes argument input, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Case block, return undefined. Case block, case clauses. Let v be undefined. Let a be the list of case clause items in case clauses. In source text order, let found be false. For each case clause C of A. Do if found is false. Then I set found to. Case clause is selected. C. Input B if
Might not need to rename anything. Everything's kind of already categorized with a really long name.
update empty. R. V. Return V. Case block.
I don't know. I'm just gonna make this a macro, I guess.
Let V be undefined. If the first case clause
If I can like, I don't know. And then I can like finish up all the other things I gotta do, like check the address and print the times and whatever.
false, then I set found to. Case clause is selected. C. Input B if found is true. Then I let R be completion. Evaluation of C. 2. If R is not empty, set V to R. 3. If R is an abrupt completion, return. Update empty. R. V. Let found INB be false. If the second case clause is present, then a let B be the list of case clause items in the second case clauses. In source text order 8. Else a let B be a new empty list 9. If found is false, then 16. ECMA International 2024. For each case clause C of B. Do I have found INB is false. Then set found INB to. Case clause is selected. C. Input 2. If found INB is true, then let R be completion. Evaluation of case clause C. If R is not empty, set V to R. If R is an abrupt completion, return. Update empty, R, V 0. If found INB is true, return V 1. Let default be completion. Evaluation of default clause 2. If defaulter is not empty, set V to defaulter 3. If defaulter is an abrupt completion, return. Update empty, defaulter V 4. Note: the following is another complete iteration of the second case clauses. 5. For each case clause C of B, do a let R be completion. Evaluation of case clause C. B if R is not empty, set V to R. C if R is an abrupt completion, return. Update empty, R, V 6. Return V 4, 1 2, 3 case clause is selected. C. Input. The abstract operation case clause is selected takes argument C, a case clause parse node, and input, an ECMAScript language value, and returns either a normal completion containing a boolean or an abrupt completion. It determines whether C matches input. It performs the following steps when called. Assert. C is an instance of the production case clause. Case expression. Statement list opt. Let X per F be. Evaluation of the expression of C. Let clause select to be. Get value. X per F. Return is strictly equal. Input. Clause selector. 4, 1 2. For runtime semantics. Evaluation switch statement. Switch. Expression. Case block. Let X per F be. Evaluation of expression. Let switch value be. Get value. X per F. Let old-env be the running execution context's lexical environment. Let block-env be new declarative environment. Old-env perform block declaration instantiation. Case block. Block-env. Set the running execution context's lexical environment to block-env. Let R be completion. Case block evaluation of case block with argument switch value. Set the running execution context's lexical environment to old-env. Return R case clause. Case expression. 1. Return empty case clause. Case expression. Statement list 1. Return. Evaluation of statement list. Note this operation does not execute C's statement list, if any. The case block algorithm uses its return value to determine which statement list to start executing. Note no matter how control leaves the switch statement, the lexical environment is always restored to its former state. ECMA International 2024 317. Default clause. Default. 1. Return empty. Default clause. Default. Statement list 1. Return. Evaluation of statement list. 4.13 Labeled statement syntax. Labeled statement. Yield. Await. Return. Label identifier yield await. Labeled item yield await return. Labeled item. Yield. Await. Return. Statement yield await return. Function declaration yield await. Default. 4. 1 3. 1 Static semantics. Early errors. Labeled item. Function declaration. It is a syntax error if any source text is matched by this production. Note an alternative definition for this rule is provided in B 3.1, 1.4, 1.3, 2 Static semantics is labeled function, STMT. The abstract operation is labeled function takes argument STMT, a statement parse node, and returns a boolean. It performs the following steps when called. If STMT is not a labeled statement, return false. Let item be the labeled item of STMT. If item is labeled item, function declaration, return true. Let sub STMT be the statement of item. Return is labeled function, sub STMT. 4. 1 3. 3 Runtime semantics. Evaluation labeled statement. Label identifier. Labeled item. Return. Labeled evaluation of this labeled statement with argument. Note a statement may be prefixed by a label. Labeled statements are only used in conjunction with labeled break and continue statements. ECMAScript has no goto statement. A statement can be part of a labeled statement, which itself can be part of a labeled statement, and so on. The labels introduced this way are collectively referred to as the current label set when describing the semantics of individual statements. 318. ECMA International 2024 1413 for runtime semantics. Labeled evaluation. The syntax-directed operation labeled evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: breakable statement, iteration statement, let STMT result be completion, loop evaluation of iteration statement with argument label set. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else, set STMT result to normal completion, STMT result, return STMT result, breakable statement, switch statement, let STMT result be completion, evaluation of switch statement. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else, set STMT result to normal completion, STMT result, return STMT result. Note 1. A breakable statement is one that can be exited via an unlabeled break statement. Labeled statement, label identifier, labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Let STMT result be completion, labeled evaluation of labeled item with argument new label set. If STMT result is a break completion and STMT result is label, then A set STMT result to normal completion, STMT result. 5. Return STMT result, labeled item, function declaration, return, evaluation of function declaration, statement, block statement, variable statement, empty statement, expression statement, if statement, continue statement, break statement, return statement, with statement, throw statement, try statement, debugger statement, return. Evaluation of statement. Note 2. The only two productions of statement which have special semantics for labeled evaluation are breakable statement and labeled statement. ECMA International 2024 319 14.14 Throw statement syntax. Throw statement, yield, await, throw, no line terminator here, expression, plus in yield await. 4. 1 runtime semantics. Evaluation. Throw statement, throw expression, let x per f be. Evaluation of expression, let x per value be. Get value, x per f. Return, throw completion, x per value. 4.15 Tree statement syntax. Try statement, yield, await, return. Try block yield await return. Catch yield await return. Try block yield await return. Finally yield await return. Try block yield await return. Catch yield await return. Finally yield await return. Catch, yield, await, return, catch parameter yield await, block yield await return, catch, block yield await return. Finally, yield, await, return. Finally block yield await return. Catch parameter, yield, await, binding identifier yield await, binding pattern yield await. 4. 1 static semantics, early errors. Catch parameter, block. It is a syntax error if bound names of catch parameter contains any duplicate elements. It is a syntax error if any element of the bound names of catch parameter also occurs in the lexically declared names of block. It is a syntax error if any element of the bound names of catch parameter also occurs in the declared names of block. Note an alternative static semantics for this production is given in B. 3.4 Note, the try statement encloses a block of code in which an exceptional condition can occur, such as a runtime error or a throw statement. The catch clause provides the exception handling code. When a catch clause catches an exception, its catch parameter is bound to that exception. 320 ECMA International 2024 1415 to runtime semantics. Catch clause evaluation. The syntax-directed operation catch clause evaluation takes argument thrown value, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: catch, catch, catch parameter, block. Let old env be the running execution context's lexical environment. Let catch env be new declarative environment. Old env, for each element arg name of the bound names of catch parameter. Do a perform catch env create mutable binding, arg name. False. Set the running execution context's lexical environment catch env. Let status be completion. Binding initialization of catch parameter with arguments thrown value and catch env. If status is an abrupt completion, then A set the running execution context's lexical environment to old env. B return status. Let B be completion. Evaluation of block. Set the running execution context's lexical environment to old env. Return. B catch. Catch block. Return. Evaluation of block. 4, 1, 5, 3 runtime semantics. Evaluation. Try statement. Try block catch. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause evaluation of catch with argument B. Else. Let C be B. Return. Update empty. C. Undefined. Try statement. Try block finally. Let B be completion. Evaluation of block. Let F be completion. Evaluation of finally. If F is a normal completion, set F to B. Return. Update empty. F. Undefined. Try statement. Try block catch finally. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause evaluation of catch with argument B. Else. Let C be B. Let F be completion. Evaluation of finally. If F is a normal completion, set F to C. Return. Update empty. F. Undefined. Note: no matter how control leaves the block, the lexical environment is always restored to its former state. ECMA International 2024 321 14.16 The debugger statement syntax. Debugger statement. Debugger. 4, 1, 6. 1 runtime semantics. Evaluation. Debugger statement. Debugger. If an implementation-defined debugging facility is available and enabled, then A. Perform an implementation-defined debugging action. B. Return a new implementation-defined completion record. Else A. Return empty. 5 ECMAScript language. Functions and classes. 5.1 Parameter lists syntax. Unique formal parameters. Yield. Await. Formal parameters yield await. Formal parameters. Yield. Await. Empty. Function rest parameter yield await. Formal parameter list yield await. Formal parameter list yield await. Formal parameter list yield await. Function rest parameter yield await. Formal parameter list. Yield. Await. Formal parameter yield await. Formal parameter list yield await. Formal parameter yield await. Function rest parameter. Yield. Await. Binding rest element yield await. Formal parameter. Yield. Await. Binding element yield await. 5, 1. 1 static semantics. Early errors. Unique formal parameters. Formal parameters. 22. Copyright sign. ECMA International 2024. Note: evaluating a debugger statement may allow an implementation to cause a breakpoint when run under a debugger. If a debugger is not present or active, this statement has no observable effect. Note: various ECMAScript language elements cause the creation of ECMAScript function objects. 10.2. Evaluation of such functions starts with the execution of their internal method. 102. 1. It is a syntax error if bound names of formal parameters contains any duplicate elements. Formal parameters. Formal parameter list. It is a syntax error if is simple parameter list of formal parameter list is false and bound names of formal parameter list contains any duplicate elements. 5. 1. 2 static semantics. Contains expression. The syntax directed operation contains expression, takes no arguments and returns ChatGPT, Compiler Explorer. In NASM can %defines be defined inside a %macro, and what was the syntax to glue tokens? So I can glue to format assemble time name, like how this works in C language. Token name here, was it like token %name %% here for an ASM? I can't remember. Give me a direct answer to save me time from having to check the NASM docs. Direct answers 1. Tick. Can %define be used inside a %macro in NASM? Yes. You can use %define inside a %macro to define macros during assembly time. Link symbol. What is the syntax for token pasting? Gluing tokens in NASM. Plus is the correct syntax to concatenate tokens in NASM, not %%. Example. NASM copy edit %define prefix my define name function. Define full name prefix %+ name. Results in my function. Or inside a macro, NASM copy edit %macro macro 1 %define my %+ %1 123 int macro macro func. Now my func is defined as 123. Let me know if you want a live example.
Chatbot defined it with the space, whatever, to make it easier to read. For here, whatever. So I can put a space. It's easy to read. But Chatbot didn't do that for this one. It like scrunched them all together. I wonder if it did that on purpose to make it difficult to read. Or it's just copy pasting from somewhere else, and wherever it copied it from, it defined it differently. So it didn't think of making it easier to read like it did in the other example. That's probably what happened. This is like argument 1 of a macro. You make a macro, this is the length. The macros are named by percent and the number that is starting from 1, the length of how many there were. I don't know. This is so boring. I just gotta convert it, make it done. I could finally print the address and shit. And like speed test shit. I still have to like average the time and stuff to get the time that things took to complete, to like remove the static from whatever, I don't know. That's the goal. It's taking forever. I just want to be done. And going through the stupid standard. That's all I want to do. I still have to parse the freaking program. This stuff, I think most of it's like, I don't know. Just gonna make a macro. And then name everything. And then glue the name to the macro for all these parameters, whatever. And that's it. This is so much better than C language. In C language, you can't put a define inside of a macro. Technically, you possibly could, but it's not cross-platform, and it probably doesn't work very good if it is supported. This is so much better than C language. Put a macro after the word times. That's cool. I want to know what they mean by position independent access, because it's dependent position. If the program starts once and then doesn't change its position when it's running, it's annoying. It's like it's like they're describing what it's not as what it is. It's just bullshit and annoying. So I don't know, I just remembered in 32-bit, you could pick a segment, select or whatever, and I think they flattened the whole thing and removed it. So we have relative or absolute. And chatbot's like, just not answering.
In NASM, when accessing an address was the 32-bit format like CS mem location, replaced in 64-bit with rel mem location and abs mem location. Tick direct answer. In NASM 64-bit mode, yes, you typically use rel mem location for RIP relative addressing, common for accessing data in position independent code. Abs mem location for absolute addressing, if you explicitly want a fixed address, less common and restricted in 64-bit mode. Restricted symbol, old 32-bit style like CS, mem location, is generally not used in 64-bit mode. Segment overrides like CS, DS, etc. are largely ignored or have limited use in 64-bit mode. CS mem location is invalid in 64-bit mode.
Unless you put in FS or GS, because they use those for threading or something. It's an exception to the rule. The rules suck for 64-bit. The whole CPU is right there, and it's crippled for 64-bit for the convenience of calling it 64-bit. And like spreading out, whatever. So I guess it did kind of answer it.
rel addressing is used, does it dereference the label itself or does it dereference the label and add to it? If rel addressing is used, does it use the label itself or does it dereference the label? Tick direct answer, rel label. In NASM dereferences the label. It accesses the memory at the address of the label using RIP relative addressing.
Wait, what? Is there like an extra dereference when it's relative? This is confusing. So it does 32-bit mode. In 64-bit mode. Well, that's stupid. Isn't it kind of like saying it still does it? I hate how they push bullshit. They're like, unless it's a specific type of code, and I don't say why, and they're like, you should, blah blah blah. And like,